Hello and welcome to this tutorial series. In this series we're going to be covering how to make a Minecraft style inventory system. In the system we're going to be able to have a backpack, chest, a hotbar. We're going to be able to pick up items from the ground. We're going to have them stack. We're going to have different max stack sizes. We're also going to be able to split stacks, combine stacks and drag and drop stuff out of the inventory. The way this tutorial system is going to work is it's split into 7 parts. There's 8 videos in total because I've got like a part 5.5 which will come out midweek on that week, and that's a code review. So at that point in the project I'm just going to go through all of the code and kind of refresh ourselves what all of the code's doing. So there's 8 videos but 7 parts. Each video is going to come out here on YouTube weekly, but the full series is recorded and it's available over on patreon.com/danposs. So if you want early access, you can support me over on Patreon and you'll get the full series right now. And at the end of each episode, I've exported the scripts for like as they were at the end of that episode. And again, if you support over on Patreon, you'll get access to the scripts as well as early access. A link for that is in the description below. If at any point you get kind of confused or lost, or you want a bit more information, leave a comment under that video or join the Discord server, which again is linked in the description below. Either me or someone else in the community will be able to help you hopefully solve the issue that you're having. Some things that this series isn't going to cover is, just to set expectations, is there's no saving and loading of the inventory. That's almost like a save load system is almost its own other series, and there are lots of tutorials out there that would allow you to do that. But if this series is well received and there's a lot of support, I am thinking of doing an expansion sort of video series to this to show you how to make a save and load system and save our inventories. Some of the things I might do in the future with this course is I wouldn't mind to do like a shop inventory system, so where you can sell and buy items, but again that's not included in this video. It's a big time commitment to make series like this where they're all done kind of in advance, so I didn't want to go too far into a complex system, people not like the series. So if you do and you want to support these videos, make sure you share and like them and comment, and if they're positively received then I will do an expansion, so save load NPCs. But let's just jump into the project. I'll show you exactly what we are going to have by the end of this course. Okay, so you can see that we've got our tomatoes here on the ground and we can pick them up and they can stack. By holding down the shift key, we can split a stack. So we can take 2 off that stack and halve it. You can see that we can now combine stacks. So I can press the 2 and put it on the 3, they become 5. If I split them again, so the maximum stack of these tomatoes is 5. If I try and combine the 3 with the 3, it'll fill 1 stack up to its maximum and it'll leave 1 stack on the mouse, which I can then place back down. We can also come up here and we can get these potatoes. These don't stack at all. They've got a max stack size of 1, so they just go into the next available slot. You can see our hotbar is full now. If I press B and bring up our backpack, when we start to walk over stuff now, it'll go into our backpack. So I can pick up these other potatoes and these other tomatoes. So that's all of the tomatoes. I know there's 2 more here, so if I pick up these, so this stack is now full and this spare one went into our backpack. I can come over to these chests here and open the chest, and you've got our chest panel here. And this is the large chest. We've also got the small chest, and this fills out dynamically. These panels don't have any slots in them and it responds dynamically to the inventory system that you pass into it. And then of course I can move stuff out of my backpack over into the chest. I can take out the ones from my hotbar and place them in the chest. I can come over here and open this chest, place in some potatoes, and press escape and walk away from them, and go back, open up the chest, and we've got our chest, the stuff that we stored in our chest here, so I can take them back out, take these potatoes out. I can even split this stack, place it in here, put the other part of the stack into this chest. I can open up this chest, take these back out, and then combine them back into this chest. So they all kind of link in. You can move stuff through dynamically. The way these work is it's not drag and drop, it's you can click once on a slot and then it follows the mouse around and then we can click to place it back in a slot. So this is where we're going to be at the end of episode 7, and each episode is going to cover a different topic. So parts 1 and 2 are going to be about creating and finishing the back end sort of code system. Part 3 we're going to create the UI. Part 4 will be about interacting with the UI and be able to click on different slots. Part 5 we're going to be splitting and combining the stacks. Part 5.5, which will come out midweek, is a code review. just to go over and make sure that we're all on the same page with the code. Part 6 is going to be creating the chests, and then part 7 will be creating the player backpack system. So with all that said, I hope you enjoyed this series. Episode 1 is up now on YouTube. As I said, the full course is already available over on Patreon, and going forward here on YouTube, episode 2 will release in a week, and then episode 3 a week after that, etc. So make sure you subscribe to see them as they go up, and in the meantime, thanks for watching, and I'll see you in the next one. Bye! Hello, welcome to the first video in the inventory tutorial series. If you haven't watched episode 0, I highly recommend doing that, because that's just going to go over kind of an introduction to the system, demoing how it works, as well as talking about kind of the skill level that this tutorial is aimed at and how you can get the access to the files and all that sort of stuff. So if you're coming across this video and this is the first one, I do recommend watching episode 0. But with that said, let's just get straight into episode 1. So this first video, or it may be 2 videos, we'll see how we get on, is actually going to cover the system part of our inventory system. The way to think of this is, we've got the code, the code version, all the 1 zeros. This is the system, and then we've also got the the UI element. And this is actually going to display our inventory as you would expect in a game. So there's going to be an inventory screen with different inventory slots. Each of these slots will have an item in it, and it'll have an amount of that item, which is the stack amount. So we're going to be covering this part in the first sort of 1 or 2 videos. And then once we've got the framework for the system set up, we'll start to build on the UI. And as we need new functions of the system from the UI, for example, splitting a stack is something that we'll need to do. We can go back and we can add this to our system and expand on our system, but we need a framework first for the UI to have just something to display in the first place. And the way the system is going to work is there's going to be 3 parts. There's going to be a inventory holder. Think of this as, we've got a player, and then they've got their hotbar, which you could think of as a utility belt. They might have a backpack. You see, a holder can have multiple systems, and that's different to the actual the inventory system is all of this, but we will have a class called inventory system. Hopefully that's not confusing. So we've got the code system and the UI sort of representation of this system, and then we've got a inventory holder, which is our player with a backpack and hotbar, utility belt. This could also be, a chest. Will hold an inventory system. So the system is going to be a container for all of our inventory slots. So you can see on the UI representation, we've got the inventory system, and then it's made up of different slots. So system and slots kind of go hand in hand here to talk about them. So we've got the holder, which is like a player or a chest. That can have 1 or multiple systems, and a system is made up of 1 or multiple slots. So again, the system is a container for slots, and an actual slot is one of these individual squares. So, we've got our inventory slot, which could have it's a really bad sword, but it's got a sword in it, and they've got 2 swords in their inventory slot. In another slot, they may have a potion, and they could have 5 potions, and they can have as many slots as they want in each system, and you can have multiple systems. So a chest would have a system with, say, 10 slots. The hotbar has got, normally in a game you'd have a hotbar across the bottom of the screen like this, and it'd have a number of slots on it, and the player would be able to press 1, 2, 3, 4, all the way through to 0 on their keyboard. So that's 10 slots. So a hotbar would have 10 slots. Backpack could maybe have 20. The chest could have 15 slots in it. So each of these holders has the systems which have the slots inside them, and hopefully this will make sense as we start to build upon this. And it's this kind of system that allows us to have stackable items. So each slot is going to keep track of the item it has and the stack size, and we could define how big this stack size can get within the sort of item's properties. So the item may be flagged to have a max stack size of 5, So our potion here, say we've got a max stack size of 5 and we've got 5 in our inventory, and then we pick up another potion on the ground, we can see that this is currently at its maximum capacity, so we'll just fill the next slot with the potion that we've just picked up. So hopefully this all makes sense. If it doesn't, or you want some more clarity, let me know in the comments below and I can do some follow-up videos to talk about this. As I said, as we actually go through the code, hopefully this will all start to begin to make sense. So let's just jump over into Unity. Okay, so this is just a blank 3D project within Unity. You know, we could have had a 2D project. It doesn't matter which pipeline you're using, just create a new project. And just so you know, not that it should matter, but I'm using Unity 2020.3.22 F1. The first thing we want to do is, you know, we need to define what exactly an item is, just so we can have something to store in an inventory. So I'm just going to right click and go to create folder, and I'm just going to call this script. And within our scripts folder, I'm just going to make a new folder called item scripts. I'm just going to right click here, create C# script, and I'm just going to call this inventory item data. I'm just going to open this up in Visual Studio. So the first thing to do with our inventory item data is to get rid of mono behavior, and we're going to derive from scriptable object, which means we don't need these. And to make these visible in the inspector, we just want to come up here and open the square brackets and go create asset menu. Menu name is equal to inventory system / inventory item. So now when we go back over to Unity, I'm going to go back to our asset folder, right click, create folder, and I'm just going to call this scriptable objects. And now we can right click, create inventory system, and we've got our inventory item, which I'm just going to call test item. You can see that there's no sort of properties on that just yet. So we can go ahead and create those. For the inventory system, all we're going to really care about here is we need a public sprite for the item's icon. And we need we can define a public int for our maximum stack size. So for this tutorial, these are going to be the only things that we need to use. However, this is going to feed into the rest of your game, presumably. So when defining an item, some of the stuff you may want is a public int, you know, ID, a public string for the display name. You could have a text area with a description. And you know, you can define whatever it is in your game an item is. You may have an item type or a weapon type or armor type. You know, whatever you want your inventory item to be, that's down to you. But the ones that we're going to use actually in the inventory system is an icon, so we can see what item we've got in the inventory. And then we need a max stack size, which, as I explained, will define how many of that item an inventory slot can actually hold. Just going to make sure that's saved, and let's go back over to our inventory system project. And then I'm going to go back to scriptable objects, and you can see that our test item now has an ID, a display name, description, a slot for an icon, and a maximum stack size. For now, I'm just going to put 5 in the maximum stack size, and we'll import some sprites later on when we need them. I'm going to leave ID alone, but for this, I'll just say test item 1. And this is a test item. Okay, that's great. So I'm going to rename that to test item 1. And then we can make another inventory system inventory item, and we could say test item 2. Test item 2. Description, this is another test item, and we can hold 1 of these. So this has got a max stack size of 1. Great, so we've defined what an inventory item is now. So now we can make a slot to actually hold the item. So let's go back over to our scripts folder, and I'm just going to right click, create folder, and I'm going to call this one the inventory scripts. We'll open this up, and then I'm going to right click, create C# script, inventory slot. Again, this isn't a mono behavior. It's not going to sit anywhere on this scene. So it doesn't need the mono behavior, it doesn't need start or update. What it does need is, it needs to be marked as system.serializable, so we can actually see these in the inspector. Then I want to serialize field, again, so we can see these in the inspector. I want a private inventory item data, which is that scriptable object we've just made, and I'm going to call this item data. And then we want a serialized field, private int called stack size. So this is going to keep track of how many of the item data we've got access to. And then I'm just going to make some public properties so we can get this stuff elsewhere. So I'm going to say inventory item data equals item data, not equal, sorry, we use this separator for the expression body definition, and then we want to do the same for the public int stack size. So we can't accidentally change these from outside the script, but we can get a reference to them using the public properties. And then we need, when we're making an inventory slot, what we do want to do is we want to make a constructor. So we can say public inventory slot, and this is going to take in some source data. For example, test item 1, test item 2, sword of doom, whatever the inventory slot is going to contain, we can pass in a source. And we can also pass in an amount of that item if we want to construct it with more than one item. So item data equals source, and then we can say stack size is equal to the amount that we've passed in. But I'm also going to want a public inventory slot with no parameters that sets the item data to null, and stack size is equal. Stack size equal to -1, so that's essentially null as well. And the reason we're doing this is because if we go back over here, our bag, or the hotbar has the slots on it, regardless of whether there's an item in them. These are all slots that exist. But there's no item in it, so there's null. So I'm on my mouse now instead of my tablet. So the item is equal to null, even though the slot's there, there's no item in it, and it doesn't have any amount in it either. So we'll set the amount to -1, just so we know that that's also null as well, and we can check for that if we need to anywhere down the line. But these slots, they exist. They're made, they're ready to go, they're ready to hold an item, but in their default empty state, they don't have anything in them. So we can make an inventory slot with nothing in it, or we can make one that's full of stuff and give it an amount of that stuff. And actually, what's probably better is we may want to clear a slot as well at some point down the line. So we can say public void clear slot, and then we can actually do this here, and then just call clear slot from our constructor, and then we're not having to write this code out again, because we probably want to be able to empty out a slot. For example, if we delete an item, we can just clear the slot instead of creating a new slot and replacing them. We can just set this slot back to empty. And then what we want to do is we can make two methods here. So we can say public bool add to stack, and we can say int amount, and then we can just say stack size plus equals amount, and public void remove from stack, and we can pass in an amount as well, and this will be stack size minus equals the amount that we're passing in. And before we add to the stack, it's probably good if we have a method that checks whether there is actually room left in the stack. And if there's not going to be enough room in the stack for the amount that we want to pass in, then let us know how much room is actually left in the stack. We can just make two more methods here. So we can do a public bool room left in stack, which will take in the amount to add, and it'll pass back out the int amount remaining. I'm going to make another version of this method that just takes in the amount to add, because we may not always need to know how much is remaining. So we can just do public bool room left in stack and make sure these are named the same. And this will just take in an amount to add. So we'll do this one first. So we can say if stack size plus the amount to add. So if we've picked up 2 of an item, we're going to pass in 2 on the amount to add. So if stack size plus amount to add is less than or equal to the item data, which again is that scriptable object we've made, the item data dot max stack size, then we can just return true, because if we add this amount to the stack size, then we're not going to encroach on the maximum stack size. So if our maximum stack size was 5, we had a stack size of 3, and we tried to add 2 to the stack, then that would equal 5, so that'd be fine, because the stack would be, it would have room left in the stack to add this amount to it. So it's just going to return true. Otherwise, there's not enough room in the stack, so we'll just return false. So for example, if this was 4 and we tried to pass in 2 and the maximum stack size was 5, then 4 plus 2, 6, that's bigger than the maximum stack size, so there's not enough room left in the stack for this amount. So for this version, we can just return our other version of the method, passing in the amount to add, but we also need to pass back out the amount remaining. And the way we can do that is we can say amount remaining is equal to the item data dot max stack size minus stack size. And we'll need this later on for splitting stacks and combining stacks. For example, using this as an example again, if the maximum stack size was 5, the current stack size was 4, and we were trying to add 2 to it, which would take it to 6, we want to combine the items and leave one item kind of on the mouse. So just to explain that from our test project, if I pick up some items here, so the maximum stack size for these hearts is 5, and I've got 3 here, and I'm going to pick up 3, and I want to combine them together. So I'm going to place 2 from the mouse and leave 1 on the mouse. So I'm going to go up to the maximum stack size. You can see that we've added 2, we've got 1 left. We put that back down, but I can put the 4 on the 1, which brings it to 5. And that's all done through checking whether there's room left in the stack. And then we'll work that out later. So it's good to have these here now, but we won't use them till a little bit later on. And there's one more method that needs to go into the inventory slot class, and that's about how to split stacks, but we'll come back to that when we actually need that one. So with that done, let's go back over to Unity, and we're going to create another script. So now we've defined what exactly a slot is, and that we can clear them and manipulate them in some way. We can right click, create a C# script, and we can start now working on our inventory system, as in the system that holds the slots. So again, this isn't going to be a mono behavior, so we can get rid of that, and we can get rid of the start and update. And again, we want this to be system.serializable, and then we can do serialize field. And this is going to be a private list of inventory slots. So this is going to hold the amount of inventory slots that we want. So inventory. So we can just call this inventory slots. And then we want a private int, which is going to be our inventory size, which we're going to pass in from our holder, which we'll set in the inspector. So just private int inventory size. And we just want to make a public getter for our public list of inventory slot. And I'll just call this inventory slots, and it will return our inventory slots. Actually, we can get rid of the private int inventory size, and what we could do is we can do a public int inventory size, and then we can pass back our inventory slots.count, which should be safe to do because when we make a new, because in the constructor, when we make a new inventory system, we will be taking in a size and that'll set up the inventory list as the very first thing it does, so that should be safe. We also need to add two using statements. So we're going to be using Unity engine.events. We can alert whoever cares that our inventory has changed. I'm going to be using system.link to do some stuff as well. So we'll include that in our using statement. So then we can make a public inventory system constructor, which is just going to take in a size. All this is going to do is it's going to create an inventory slot list, passing in the size that's come through it. Now lists, you know, they can grow and shrink, but we know we're going to need this many, so we may as well just do it now and construct the list with the size. And then we can just say for int I equals 0, I is less than size, I++, and then we can do inventory slots dot add new inventory slot, and we're going to make an empty one, which is going to be null and with a stack size of -1. So that's our inventory system done. So when we create a new inventory system, we're going to pass in the size of the system, and then that's going to make enough inventory slots to fill the system. Sorry, I forgot we didn't put our action in after I said we would. So we're doing a public Unity action, and we're going to pass in the slot that changed on inventory slot changed. So this is going to be an event that fires when we add an item to our inventory. So let's go back over to Unity again. And now we can define our inventory holder. So again, C# script, inventory holder. And I'm just going to mark this as system.serializable. This can be a mono behavior. Okay, so in our holder script, we just need to make a serialized field private int inventory size. So we're going to set that in the inspector. And again here, we need to be using Unity engine.events. And this is going to come into play later, but we're just going to make a public static Unity action, passing in an inventory system. And this is going to be on dynamic inventory display requested. So just ignore this for now. You know, it kind of says what it's going to do on the name of it, but we'll come back to that when we need it. So as well as the event, we want a public static. We can serialize another field here, and this will be a protected inventory system, which is going to be called inventory system. And again, I'm going to make a public getter for this so we can get it when we need to from other scripts. Inventory system, and this will pass this will get our inventory system. So then in our awake method, we can say the inventory system is equal to a new inventory system with our inventory size. So other scripts are going to inherit from this. This is why this is protected, not private. And by default, all inventory holders will have one inventory system on them. For example, chests will have one inventory system on them. But we're going to make a player inventory holder, which will have two inventory systems. It'll have its backpack and it'll have a... but for now, this will do fine. So we've got inventory holder with one inventory system. So let's just see this, how this looks now in the inspector. So if I make just an empty object, and we'll call this player. We'll build up on this as we go along. So I can add our inventory holder script to this, and I can give it an inventory size of 10. So our inventory system in a minute is it's 0 size, it's empty. But with our inventory size of 10, when I hit play, you can see that that's created 10 slots, and each slot on our inventory takes in an item data with a stack size. So the way this looks in our test project, if I go over to my player, top-down player with inventory, I've got my player inventory. We have an inventory system here. If I just hit play, we walk over some items. You can see that now there's 5 items, which is represented here with our item data, which is our test item, and we can pick it up and move it between different slots. So that's what we're building towards. That's the visual representation of the system. So that's how that looks. Obviously it's a bit boring and plain here. So the last thing to do in this video, let's just make it so our player can actually pick something up from the ground. So I'm just going to make a capsule underneath our player object that we've just made here. And I'll just call this graphics because it's the player kind of graphic. And I'm just going to move it up so it's sat on the floor. I'm going to remove its capsule collider. I'm going to put the collider on our player. The actual player object. And I'll put box collider. Why not? And we'll move this up and make it bigger. I'm just going to right click, create an empty, and I'll call this test item 1. Reset the transform on this. I'm going to create a 3D object and I'll create a sphere. And I'll just move that up. Move our item. Well, I use the term item lightly here. Just going to come over to our assets folder and create a material. I'll just say red. Just pick a nice kind of pale red color. So here's an item. Here's our player. So what we need for our player to actually pick up this is we need a mono behavior to sit on our test item. So go back over to your item scripts folder under scripts. I'm going to create a new C# script and I'm just going to call this item pickup. So in our item pickup script, it's going to need a sphere collider or some sort of collider for our player to kind of hit and collide with. I'm just going to require component type of sphere collider, and I'm going to do a public float pickup radius, which I'll just set to 1 for now. We can always change it in the inspector if it's too much or not enough. And then it's going to need some public, it's going to need some item data to show which kind of item it's actually representing. And then we just need a reference to our sphere collider called, let's say my collider. In an awake function, let's get a reference to our sphere collider. So get component sphere collider. And I'm going to say my collider dot is trigger is equal to true. My collider dot radius is equal to our pickup radius. Now in our on trigger enter function, so on trigger enter, I'm going to create a variable called inventory. So just var inventory, and we're going to say this is equal to other dot transform dot get component, and it's going to look for an inventory holder on the thing that hit it. If it finds an inventory holder, so if inventory is not equal to null, so if we could just say if, what we could do is say if inventory, that we could just return. So if there's no inventory, if this is null, if it hasn't found an inventory holder script, we'll just return out of this. We don't care about what's next. But if inventory isn't null, then we can just say if inventory dot inventory system, then we're going to want to add it to the inventory. So add to inventory, which doesn't exist. We need to define that. We need to make that. So we've got to go back over to our inventory system.cs file. we can just make a public void, public bool add to inventory. And this is going to take in the item, so the inventory item data, and we'll just call this item to add. And it's going to take in an int, which will be the amount to add. And for now, I'm just going to directly, and this isn't how it's going to work, obviously, but I'm just going to add this directly to to the first item slot in the list, just so we can see this all working. We'll just set this equal to a new inventory slot, and I'm going to pass in the item to add and the amount to add. And then I'm just going to return true. This is not how we're going to be doing it properly. We need to, when we actually do this properly, we're going to be checking whether the inventory already contains the item, and if it does, add it to the stack, and if the stack's full, we'll get a free slot that isn't full, etc. But just to see this kind of working, I'm just botching it to kind of overwrite that first slot. So we can say add to inventory, we can pass in our item data, and we'll just say 1 for the amount to add, because there's one item in the world. With the physical representation, you may want it so, for example, in Minecraft, if you drop 10 torches, all 10 are represented in that one item pickup, so this could be 10, but for me, I'm just going to have 1 in the inventory there. I'm just going to destroy this object. If I've successfully added myself to the inventory, which is indicated by whatever we return. So in this case, I'm just returning true by default because we're overwriting the slot. Then I'm going to destroy this item. If we don't add ourselves to the inventory, we won't do anything. So we'll just come back over to our project, and then we just need to add, to test this, a rigid body to our player. Turn off use gravity, check is kinematic. Now if we select our player, we've got our inventory system here, we've got our test item here, we can drag our item pickup on it, and then we can say the item data, this is test item 1. Put the pickup radius here, and also our sphere collider is dropped down because we moved our sphere up. So instead I'm going to put our sphere center, and then we'll just bring up our test item. I'm going to remove the sphere collider from our 3D object. And actually, we need to say destroy this .game object as well, not just this. So if we've got our player selected, you can see the inventory holder script there. If we hit play, so we've got 10 slots, the first slot's empty. If we go forward, we pick up the item, it deletes from the world, and we add one of that item to our test inventory. And we add that item to the very first inventory slot. And again, I've just hard coded that to always go into that first slot and overwrite it and make a new slot. This isn't how we're going to be doing it properly. In the next video, we're going to search our inventory slots and see if we can find the item that we want to pass in. And if we can, we're going to add the amount to it. If we can't find it, we'll get a free slot and add it to the next free slot that's available. And by free slot, I mean a slot with no data in it. And if it can't find a free slot and it can't add it to an already existing item, then obviously our inventory is full, so it would return false, and then the item pickup wouldn't destroy itself from the world. But for now, I think that's quite a good place to leave this first video. If you're watching these as they go out, the full series is currently up over on my Patreon, which is patreon.com/danposs. You can also get the files for each lesson, so I'm going to export this script as it is currently now out as a package, and so you can download the packages in stages as you go. And again, they're all over on Patreon. If you need help with anything in this video that we've covered, feel free to leave a comment below, or better yet, go over to the Discord, which again is linked in the description. Over on the Discord, either me or someone else on the Discord could jump in and try and help you. That's probably the best way to get help other than YouTube comments, because you can actually share links to your code, etc. Watching these on YouTube as they go out, the next video will be up in 1 week. But in the meantime, thanks for watching, and I'll catch you in the next video. Bye! Okay, so welcome to episode 2 of our inventory system tutorial series. In the last episode, we left it where we've got our test item here, we have a player, we can move the player over the item, and the item data gets added to our inventory, and we've got a stack size of 1. But I hard-coded it to just directly add itself to inventory slot 0. This isn't the correct implementation. This was just so we could see it working. So in this video, we're going to be working on checking whether we can, the inventory already contains the item. If it does, add itself to the stack of the item. If it doesn't, it'll search for a free slot in the inventory and add itself there. And if it can't do that, then obviously the backpack's full. So it will return false and nothing will happen. The item will stay on the ground and it won't destroy itself, because this only happens if we return true in our add to inventory script. So in our item pickup, we're saying if the add to inventory was successful, then destroy the object from the world. If it wasn't, just do nothing. So let's go back over to our inventory system.cs file. So the two functions that I've mentioned so far, we need to check whether our inventory contains an item. And if it does, we need to add it to that stack. And if not, we need to see whether there's a free slot. So the first thing we're going to do is we're going to make a public void. Sorry, we're going to make a public bool called contains item. And this is going to take in the and this is going to take in some inventory item data, which is the item to add, and it's going to pass back out an inventory slot if one exists. It's going to pass back out the slot that the item is contained within if we do actually contain the item. So I'm just going to, at the moment, just to get rid of the red squiggly line, I'm just going to set inventory slot to null and return false. And this is what we'll do at the end of the function anyway. And so the next method we need to make is a public bool has free slot. And this is just going to pass back out the very first free slot that it comes across. So out inventory slot free slot. And again, if it can't find a free slot, then we'll just we'll null out the inventory slot and we'll return false. And we'll implement these properly in just a second. Let's go back to our add to inventory script. We're going to say here if contains item, and we're going to pass in the item to add, and we're going to get back out the inventory slot that the item is contained in if it does contain the item. So if it contains the item, we're going to add to the stack of that slot. So add to stack amount. Well, amount to add, I've called it. So amount to add. And then we're going to say, hey, the inventory slot has been changed. So on inventory slot changed. And we're going to say if that's been subscribed to, if there's listeners of that event, if it's not null, then invoke it and pass through the inventory slot that has changed. And then in our UI, we can find the corresponding actual square slot of the UI, and we can update just that slot. And then we just want to return true. Now, if it doesn't contain the item, we're going to want to check whether it's got a free slot. So else if has free slot, and it's going to pass back out an inventory slot, which will be our free slot. So I'm just going to put a note here. So check whether item exists in inventory. Gets the first available slot. So here we can say free slot is equal to new slot inventory slot, and then we can pass in the item to add and the amount to add as well. And then we could just say on inventory slot changed dot invoke, pass in our free slot. And actually, so instead of making a new slot here, we can just manipulate the free slot itself directly. So let's go over to our inventory slot, and let's actually make a public void update inventory slot, and this can take in an inventory item data called data and an amount. So here we can just say item data is equal to data and stack size is equal to amount. So that way we don't have to destroy and make a new inventory slot. We can just call free slot dot update inventory slot, and we can pass in the item to add and the amount to add as well. Then again, we can check whether our inventory slot changed event has anything subscribed to it, and if it does, we can invoke that event, and we can just return true because again we were successful at adding it to our inventory. And then if it doesn't contain the item and it doesn't have a free slot, then we just return false. And actually, if we go back to our contains item script, we don't want to just get the slot that has the item. We want to get a list of slots. So we just want to type in list, and then we're going to get back out an inventory slot list. I'm just going to copy this. I'm just going to put that here as well, because in this contains item method, we're actually going to use a link function. So we're going to say that inv slot is equal to inventory slots where, and we'll open up some brackets and we'll say I, so for item, i.data is equal to our item to add, and then we can send that to a list. So if you haven't used the system.link namespace before, there's a lot of helpful stuff you can do in inventory slots with system.link. So for example, we could get inventory slots first, and we could say the first slot. So I could be anything. So we could say slot. So we could say first slot where the slot dot item data dot max stack size is greater than 5. As an example. So there's a lot of stuff you can do with system.link. I highly recommend looking more into it if you haven't come across it before. So just to make this more human readable, so we've got inventory slots dot where. So this is going to check all of our inventory slots, and it's going to create a list of inventory slots and fill it where the item or I slot, this could be anything. So where our inventory slots item data is equal to the item that we want to add, then just put that in a list. So, and this is going to be our out list here. And then when we're checking whether it contains the item, we can say return, and then we can say that does the inventory slot dot count, or is the count greater than 1? If the inventory slot dot count is greater than 1, then we can return true because it obviously contains the item. And if it's less than 1, we can return false because it doesn't contain the item. The item count size would be 0. So now we're getting a list back out, not an individual slot. So now we need to check those slots to see whether there is room left in the stack, which is that method that we made earlier on our inventory slot. So we can now say for each variable slot in this inv slot list, we're going to check, does that slot have room left in its slot? We're going to check, does that slot have room left in stack? So we say room left in stack. And you can see we've got one of two here. These are the two overloaded methods that we've made. We don't need to know how many are remaining. We just need to know if we add this amount to the stack, will it fit this amount to add here? So say amount to add. If there is room left in the stack, then we're going to get this. I'm going to pop it in here, but this is going to be called slot. So it's going to be the slot that we're looking at in our inventory slot list, which we've got from our contains item. So our item pickup is going to get hit by our player, and we're going to try and add itself to the inventory. In our add to inventory script, we're going to pass through the data that we want to add to our inventory and the amount of that data, or the amount of the item that we want to add. We're going to check with whether the inventory system contains this item. And if it does contain it, then we're going to get a list of all of the slots that have the item in it. And then we're going to check that list, and we're going to check for a slot that actually has room left in the stack. If the stack's full, or there's not enough room to add, so if, say, the maximum stack size was 5, we had 4 in the stack already, and we were trying to add 2, there wouldn't be enough room for the 2 to go into the stack. So we'd check the next slot and the next and the next. And we need to get rid of the else if here, because I found that it didn't work as intended when it was an else if. So we're going to see whether we contain the item. If it doesn't, it'll move on anyway, and it'll check, do we have a free slot? If it does contain the item, it's going to look for the item and see whether one of the slots can take the amount. If it can, it'll return true and call our inventory slot changed.invoke. If it can't, then that's fine. It'll move on and it'll check for a free slot. So this should be all working. Let's go back to the editor and check it works. And if it doesn't work, let's debug it. So I'm just going to come back to play here. Got our test item. I'm just going to make multiples of this test item now. We've got 3, 4, 5, 6. I believe we had test item, so a max stack size of 5. So if we click on our play here, and we keep a track of the inventory system over here, and we hit play. So we're going to go over this first item, and nothing happens. Why would it work first time? Let's see what the problem is here. I feel like it might be this issue we're having here. I feel like it might be this here, this condition. So let's just debug.log inslot.count. I feel like it might be because if there isn't anything in it, the count would be 0. Then that list isn't going to be initialized. Okay, so we're getting count as 0 back out. What we could do instead, let's check whether this is null. So is our inventory slot list null? If it is null, then it'll be false. We're going to return false because we haven't found anything. And if it isn't false, and if it has found something, some data in our inventory that equals this item, then it'll return true because this won't be null. So let's just leave that debug.log in for now. Let's just see if this works. We'll hit play and we'll drag our player over. Oh, you know what our mistake is? We haven't set up the free slot method. That's why. Well, we're always returning false, so we can't find a free slot to add it to. That was my mistake. So let's just finish this method before we get ahead of ourselves. So here we're going to say free slot equals inventory slot dot slots dot first or default, which is another system link method. And we're just going to say the first inventory slot I, where the data in that slot is null. So if it's null, that inventory slot is obviously empty. And we're just going to get the first slot that meets this criteria here. And then just like our contains item, we can just return free slot. Is free slot null? So has it found a empty slot? If it has found an empty slot, free slot would not be null, so it would be true. If it hasn't found one, then free slot would be null, so it would be false, and we wouldn't have found a free slot. So let's go back over to Unity and try this now. We can add our items as we drag our player. We can see that it's stack size 4, stack size 5. So our maximum stack size is 5. As we go over this next item, we should go to the next free slot, which is this one here. And there you go. So stack size 1, this is our new slot. If we made another copy of this item here, but instead we called this test item 2, and let's just make this, let's make another material, and we'll just call this green. Set it to a green color, assign that here. I'm just going to swap these places round. So our test item 2 here, this green one, let's set that to test item 2. I'm just going to make another copy of it here. And in our test item 2, we set the data, the max stack size, to 1. So as our player goes over, we're going to pick up 5, then we're going to pick up one of our test item 2, and then we're going to check our inventory for this, see that we're at the maximum stack. So we'll get the next free slot, which won't be slot 2 because this is going to be in it. So we'll get the next one after that. So let's hit play and we can see that all working. So let's drag our player forward. So we've got our 5 test item 1s. Test item 2 goes into the first free slot that it found. Test item 1 again, but our stack size is full, so it's going to go into the next free slot that was available. It won't go over this one or overwrite that one. And then as we go over this, so the stack size was 1, that's the maximum for test item 2, so we've gone into the next free slot. So if I copy these and we make another row, if I get a player and fill up our inventory, will that have filled up the inventory? No. Let's just set the stack size of test item 1 to 1 also. As we pick up these items, so our inventory is full now. When we go over these items, our inventory will be full. We won't successfully add it to our inventory, so they won't delete. So you see that as we go through them, they're not coming up off the ground because they can't successfully add themselves to our inventory. If we deleted an item and made it back to its null state, we could add another item to our inventory and it'd go into that free slot. Okay, so that's part 2 done of our inventory system. It was a bit shorter than part 1, but we had kind of, we'd set up quite a good framework in the first video to just build upon in this second one. And you can see that the functionality is kind of now working as you would expect. So going forward, we are going to build on the system a little bit in the back end, but we're going to start putting the UI elements together and showing how we can update the UI based on what is actually in our inventory. Again, I hope this is all making sense so far. If it's not, or you'd like anything kind of clarified, feel free to join the Discord server, which is linked in the description, or leave a comment below. If you're watching these live as they come out, the whole series of this is over up on Patreon, which is patreon.com/danposs. You'll get the access to the full series and all of the project files as well, so the scripts that we're building. I'm organising the scripts by lesson in packages, so you'll be able to get the package for the lesson that you're following. The Patreon is linked in the description below as well. But that's everything for this video. Thanks for watching, and I'll see you in the next one. Bye. Okay, welcome to episode 3 of our inventory system series. So in this episode, we're going to be covering setting up this kind of scene to make it a bit more like playable. I want to be able to move around as the character properly instead of dragging the bean around like this. And I'm going to put some chests in the scene so when we start working on the UI, we can have things to go and interact with. And we'll start putting the UI together as well. So let's just jump straight into it. Where I left off in the last episode, our player's got an inventory list here, a list of slots, and as we go over the slots, they fill up, and eventually once the inventory is full, stuff won't pick up off the ground, and items can have different stack sizes. So if we set test item 1, which is the red spheres, to a stack size of 5 and we hit play, then we click the player, as we go over we can pick up 5 of test item 1. Stack size of item 2 is 1, so we'll pick up them, and then we can start a new stack here of 5 more test item 1s. That stack's full, so we'll start to put so the other 2 went into the next free slot there. So that's where we are, that's where we're at. The first thing I want to do then is I just want to make it so we can actually move around with WASD. And to do that in this series, we're going to be using the new input system. So I'm going to go up to Window, Package Manager. I'm going to go to Unity, Registry. Select Input System and then hit Install. This is going to install and it'll ask us to restart the editor once it's installed. You just need to hit yes to that and it'll restart our project. So I'll catch back up with you after that's done. Okay, so we're back in Unity here after it's reset. After the project is restarted, so you can see that the input system is now in our project. So I'm just going to close this down and we'll come back to moving the character in a sec, but let's just make a bit of a scene to actually move around. I'm just going to delete all of these test items apart from the original test item 1 and 2, just because I want them a bit more organized. I'm going to right click, create 3D object and make a plane. I'll center this in the world. I'm just going to scale it up. We'll make a new material, make this kind of a grayish color. Gray. I'm going to create an empty object. I'm going to call this small chest. And again, center that in the scene. I'm going to right click, 3D object, make a cube. Bring this up. Going to make another material called brown. While I'm here, I'm just going to make another one called gold. So to represent our chest, I'm going to just duplicate this cube, bring it forward, move it up, and then let's scale it down and make this gold. So that's our small chest, and then let's make, oh, what have I done? And then we'll make big chest. And we'll make that slightly bigger, so we've got small chest and big chest. Let's move our small chest just back over there. Big chest, back. Just rotate. We might make more chests later on. Well, in fact, we will make more chests later on. So we've got our bean here. I'm just going to add another, I'm going to add a 3D cylinder. Oh. And I'm just going to give him some eyes, just so we can see which direction they're pointing. Now let's add a script called player movement. This, I'm just going to get the character controller.move script. If you just search for Unity character controller script, and it's this one. Let's just steal this up from the bottom up to there, and then we can come back to our script. Let's just paste that in. So we've got our character controller. Here, because we're using the new input system, instead of this get axis horizontal, get axis vertical. For now, let's just remove these. I'll just put 0 because we're using the new input system. I'm just going to get rid of this, the jumping stuff, because it doesn't seem to work ever anyway for this character controller. So we can get rid of jump height, whatever. Let's go back to our project. I'm just going to drag this player movement script over into scripts. Make a new folder for materials. Pop our materials over there to keep organized. I'm going to create a new folder called input. And in input, I'm going to create a new input actions called player controls. And I'm going to open this up. I'm going to call our action map player here. And I'm going to choose pass through, vector 2, under binding. Under add binding, I'm going to add a 2D vector composite. And I'm just going to delete this binding that was made already. So for up, I'm going to have the W key. For down's the S key. Left is the A key. Right is the D key. And I'm going to save the asset. And then I'm going to close this. Click generate C# assets. I'm going to click the player controls and click generate C# class and hit apply. Over in our player movement script, I'm just going to say private player controls called player controls. And in start, we can say player controls is equal to new player controls. And then in our onEnable function, we want to say player controls.enable. And in our onDisable function, we just want to say player controls.disable. And then in update, so this X was the horizontal axis. So we can say player controls dot player dot new action. Okay, we don't want it to be called new action. We need to go back to our player control input action asset, and I should have called this movement. Hit save. X out of this. Back to our script. So this is movement dot read value vector 2 X. Then we can do control C, control V, and we'll do Y for the Z axis. Okay, so if you don't understand the input system, if you've not used it before, I'll explain these in just a second. But the first thing actually is I've changed the start method to awake. I'm going to change this to get component instead of add component. And then I'm going to come up here and I'm going to say require component type of character controller. And I've also put the kind of null operator here. So player controls question mark dot enable. So if player controls isn't null, then we'll enable them. And if it's not null and we disable, we'll disable them as well. So back in our project, let's add the player movement script to our character controller, and you'll see that it's in the ground there, the capsule collider. We just need to raise this up by 1. So our character controller is now on the ground. So the way the input action asset is working, so we called it player controls. That's the input action asset, which is also the name of the script that was generated when we clicked generate C# class. Inside there we have an action map called player. We created an action called movement, and then under that we put a 2D vector which is controlled by up and down U and S, and then left and right is A and D. And if you think of this as like a 2D kind of sort of a unit circle. So we've got our circle. Again, I'm on my mouse here, so it's not going to be perfect. This is our y-axis. This is our x-axis. We've got A and D control our x-axis. W and S control our y-axis. So if I'm holding W down, we're going to be up here. So that's going to be 1. If I'm holding S down, this will be -1, A, it'll be -1 on the X, and then D, sorry, it'll be +1 on the X. So in our script, when we're reading the value, we've got player controls, which again was the name of the input action. This is the actual action map, player. Movement was the action that we made, and then we're reading the vector2 value of that. And we're taking the X value for the X of our movement vector, and we're taking the Y value for the Z of our vector3. So the Y is going to be forward, so that was W and S, and then the X is A and D for left and right. So all things working as they should be. Let's just move our camera into a better position. So just so we can see our objects and chest. As we start moving, we can walk around and pick up the items. We're going very slowly. So I'm just going to go back to our player movement script, and I'm going to, I'll just make this public because we could serialize the field, but I'm just going to make it public. So we'll go back to our player, player speed. Let's set that to 5. Let's see if that's better. There we go. We're moving around a lot better now. So we can move around. We've got our chests, which we can bump into. We can't interact with them yet, but we will work on that. Okay, so we've got our bean. I don't like the colors I've chosen. There we go. I've got a blue bean, we've got our test items, we've got a chest which we'll interact with later. Okay, so now we need to start working on our actual UI. So let's right click, create a UI canvas, and we'll just call this, we'll just leave that called canvas. Because we're using the new input system, on our event system, we just need to click this here, replace the input system with the new input system module. We can do that, that's all working fine. So we go to our canvas and we want to say screen space overlay, that's fine. But we want to come down to UI scale mode and change to scale with screen size. And I'm just going to put in 1920 by 1080. And the first thing I'm going to do under this is I'm going to come to our canvas, I'm going to right click, create empty, and I'm just going to call this mouse object. And our mouse object is going to have an image. And it's also going to have some text. I'm going to use text mesh pro. We just need to import TMP essentials. So I'll just hit that. We'll close this window, and I'm going to hit the 2D button up here, select our mouse object, and then press F just so we fly over to that. And then I'm going to just position this. So I'm just going to type in 10 just so I can get kind of what it looks like. Let's center it. I'm going to make it black. I'm just going to put this in the corner here of our image. So actually, we don't want to center it on the alignment. We want to right align it. Bring this up here, and let's resize this box. Because obviously, if we had 100 items, we want it to come out from that right-hand side. We don't want it to be centered. So we'll do, let's put 99 as a default. I'm going to bring it away from that corner and check auto size. That'll fill the box nicely. I might actually reduce the maximum size a little bit. And I'll just place that there. So this is our mouse object. For our mouse object, we're going to add a script. I'm going to come over to inventory scripts. I'm going to right click, create C# script, and we're going to say inventory. I'm just going to call this mouse item data. We'll open this up. And for now, let's just get a reference to the image. So we need to be using Unity engine.ui, and we need to use TM Pro. And let's get a public image reference to our item sprite, and we'll get a public TM Pro UGUI text mesh pro UGUI, and we'll say item count. So we'll go to our mouse object, and let's just add the mouse item data script, and then we'll just drag in image and drag in text for now. And then on void awake, I'm just going to set the item sprite dot color equal to color dot clear to make it invisible, and I'm going to say item count dot text equal to just a null string. So when we hit play, that'll disappear. So that's great. We don't need to see that if we're not currently actively holding an item. So that's our mouse object, which we will come back to later. Now let's create a panel. So create UI panel, and we're going to start making the hotbar. So I'm just going to call this hot player hotbar, and let's check the whole thing. I'm going to click here, the anchor presets button. I'm going to hold down Alt. You can see that we changed the pivot in the snap-in. So I'm going to hold down Alt. I'm going to change the anchor pivot to the bottom center. See that moved there. So now as we start to like scale, so you'll see now that that kind of snaps to the bottom. So if I start to resize this, it's kind of anchored at the bottom of the screen. So let's just drag that down there. For our panel here, I'm just going to add a content size fitter, and we can set that to preferred size for both of those. And I'm going to have a horizontal layout group. In that, I'm going to give some padding of 15 with a spacing of 10. Child alignment, I'll leave at upper left, and child force expand, that's fine. So now I'm going to make a inventory slot to go on our hotbar. And this is going to be kind of, it's going to match the slots on the back end. Like we're going to pair it with a slot on the back end. So to our hotbar, I'm just going to right click, create empty. And I'm just going to call this inventory slot underscore UI. And then underneath this game object, I'm going to right click and I'm going to go to UI and choose image. And it's just going to be like just like the mouse slot. So we're going to have an image and we're going to have UI text for Text Mesh Pro. And in fact, let's just copy, let's make a duplicate. I'm going to rename this to item count. Control D to duplicate it, and then I'm just going to drag it under our inventory slot UI, and then reset the position on the X and Y. Rename it to remove the 1 there. Let's just zoom in and position it where we want it. We want it down at the bottom of our inventory slot. And to the actual top level parent of inventory slot, I'm just going to add a component. I'm going to add a button component, and this is how we're going to interact with the screen. So it's not going to be a drag and drop kind of style interface. It's going to be you click on the slot to pick it up, and then you click on another slot to place it down. The reason for that is because I want this to be able to work on game controllers, and you can't drag and drop on a game controller unless you were manipulating the mouse with a joystick, and I don't really like that. This is going to be more Minecraft style or Stardew Valley style. You can highlight a slot, click it, go to a different slot, place it. So we're going to put a button on our inventory slot UI. For the target graphic, we need to add an image. So I'm just going to choose image. We drag our image under the graphic of the button. That's fine for now. We can put a source image in there in a second. But I'm now going to come back over to our assets, right click, create folder, prefabs. And under our prefab folder, I'm going to drag our inventory slot UI. I'm going to make a prefab out of it. And then I'm just going to duplicate this 9 times. So we've got 10 slots on our hotbar. So Control D until we've got 10 inventory slots, and you can see our hotbar here. I'm just going to remove gizmos out of this scene. So you can see that we've got our inventory slots here on our hotbar. And then we've got a placeholder for our mouse slot. So on our inventory slot UI prefab, we're going to add a script to it. So I'm going to go back to our scripts folder, and I'm going to make a folder called UI scripts. I'm just going to go in here, right click, create C# script. I'm going to call this inventory slot underscore UI. And I'll open that up in Visual Studio. So this is obviously a mono behavior. We don't need these two using statements, but we will need using Unity engine.ui. We'll need to use Text Mesh Pro again, so using TM Pro. And we can get rid of start and update for now. And instead what we're going to do is we're going to serialize field, private image sprite, item sprite. We can do a serialize field for the private Text Mesh Pro UGUI, which is our item count. Serialize field, private inventory slot, our assigned inventory slot, which is our backend slot that's represented by the actual UI elements. So we can make a private button called button. I'm going to make a public property, so a public inventory slot, assigned inventory slot with a getter for our private variable. Then over in our void awake function, I'm going to say item sprite.sprite is equal to null. Item sprite.color is equal to color.clear. item count dot text is equal to a blank string. We're going to get our button component, so button dot get component button, and then if button isn't null, we're going to subscribe to its on click event. So we're going to add a listener, and we're going to add a method called on UI slot click, which we can make here, public void on UI slot click. So in here, we're going to, in a second, make a display, another class, which we're going to access. We're going to access that class. So access display class function. So the relevant function on that display class, which we'll make. And I'm going to make a public void clear slot function, which is actually just going to do this. But I'm also going to check the assigned inventory slot is, if it's null, then we're going to clear the slot there as well. So if we're clearing the slot on the UI, we want to make sure that that's reflected in the system as well. So we'll just do clear slot here, and then we can actually just get rid of this. We can call clear slot in the awake function as well. And then I'm going to make a public void init function for like initialized. And I'm just going to pass in a slot when we initialize this slot. So inventory slot slot. I'm going to say assigned inventory slot equals inventory slot. Slot, I've just called it, not inv slot. So assigned inventory slot is equal to the slot that we've passed in. And then I'm going to update the UI slot. So this is going to be the graphics. So it's going to pass in, it's going to pass the slot on. So public void update UI slot, which takes in an inventory slot called slot. In here, we can say if inventory slot dot data, if slot dot data item data is not equal to null, then we will set our item sprite dot sprite equal to the slot dot item data dot icon. And we'll make the sprite visible by setting the color back to color.white. If the data is null, then we just want to clear the slot. So if for some reason we've passed in a slot that has no data in it, we just want to clear that slot anyway, just to make sure that that's reflected properly. So that's the icon. And then we also want to check the stack size. So if slot.stack size is greater than 1, we'll say item count dot text is equal to slot dot stack size dot toString. So if we've only got one of the item, we won't display the number. That's down to you. Maybe you want it to display it when there is only one, but I prefer it so if there's only one item, we just don't have a number next to it. So then we can say else item count dot text is equal to a null string. So we can actually put this inside here. And I want a version of this method that we can call without passing in a slot, so we can just refresh it directly. So I'm just going to say update UI slot, which won't take in any kind of arguments, and I can just say that if our assigned inventory slot isn't null, then we'll update the UI slot by passing in our assigned inventory slot. So the reason for this is we may just want to refresh the slot without passing in an inventory slot, so this is a good way to do that. We'll just refresh it based on the assigned inventory slot that we've given it anyway when we set up the slots. Okay, so let's just pop back over to the editor and set this up. So if we go over to our prefab, let's add our inventory slot UI script to our prefab. Then we can say item sprite is that, item count is that. Our assigned inventory slot, it starts as null, that's fine. So let's go back, and then we can see that our slot UI is here. They've all been updated to have a reference to their own images and item counts, so that's grand. So now we need our inventory display class. So again, let's go back to our scripts folder, UI scripts, and let's go over to, so let's right click, create C# script, and we're going to call this inventory display. And we'll double click and open that. So this is going to be an abstract class. We're not going to use this class directly. And we're going to want to get rid of start and update. And we don't need system.collections. We will be using .generic though. And we want using Unity engine.events and also using Unity engine.input system. Okay, so this is going to need a few different variables. So we're going to need a protected inventory system. So this is going to be the inventory system that we want to display. So inventory system. And again, we'll make a getter for this. So public inventory system, we get inventory system. I want a protected, I'm going to keep all my getters down at the bottom. So we want a protected dictionary, and this is going to take in an inventory slot UI and inventory slots. And we'll just call this the slot dictionary. So you see now that we basically marry up a UI slot against its like actual slot in the inventory system. So we go back to our little graphic here. You can see that we've got the system and we've got the UI. These UI slots are the physical kind of in-game representations of these system slots. So you can see that this is how it's going to look. It's going to, when it's got an item, it's going to display the item's graphic. When it's got an item and there's a stack size greater than 1, it'll display a number of that to represent the stack size. So this is the representation of the actual slots in the data sort of system in the back end of it. So by using a dictionary, if we pass in a UI slot, we can get out the slot that it's sort of married to, which is great. That's exactly what we need to be doing. And I'm going to make this publicly accessible as well. So public dictionary inventory slot UI is the key, inventory slot as the value, and I'll say slot dictionary, and then we'll get the slot dictionary. And I'm going to also serialize field mouse item data. I'll call this mouse inventory item, and we can set this in the inspector. Another option would be to use to make a singleton out of this. We could get it that way. That's the way I did it in my test project, but to not have to go through what a singleton is and all that, we're just going to call this, we're just going to set this in the inspector and make sure that we do. So we're going to need a public abstract void function that our derived classes are going to use. So that's going to be public abstract void assign slots. And this is going to take in the inventory system, which is the inv to display. So when we assign the slots, we're going to create this dictionary. So we need to know which slots to marry up with the actual inventory slot UI kind of representations. I'm going to make a protected void, protected virtual void, called update slots, update slot. And then this is going to take in an inventory slot called updated slot. And this isn't abstract because it's going to be the same. It's going to be the same no matter which kind of variation of this class we make. So we can just define it here. So we can say for each slot, so variable slot in the slot dictionary, if slot.value is equal to the updated slot that we've passed in, then let's update the UI slot of the corresponding inventory slot. So now this is getting quite confusing because I've, stuff's kind of called the same thing. So on our inventory display class, we've got this function update slot, and we're going to pass in a system slot. So this is this script where it's got all of the actual system elements to it. We're going to pass that slot in, and then we're going to check for every slot in our slot dictionary. We're going to loop through them, and if that slot that we're looking at, if the value of that entry is the slot that we've passed in, then we're going to update the UI slot that corresponds to the inventory system slot. And here that's the key, because you'll see that the inventory slot UI is our key. The inventory slot system isn't the key, it's the value. So we can update the UI slot there. So this is the slot value, the under the hood inventory slot. This is the slot key, the UI representation of the value. This will have another function called slot clicked, which we're not going to do in this episode because it's quite a long script. That's probably going to be an episode all on its own. But this is going to take in a clicked slot. For now, we'll just say debug.log slot clicked. So this function is what we're going to use on our actual inventory slot. So if I go back to inventory slot, I'm going to make a public property of inventory display. And we don't need to set this in the inspector, so I don't need a private version of this. I can just say get private set. I need to call it something, so parent display. And here in the awake function, we can just set parent display equal to transform.parent.getComponent inventory display. So in our onUI slot click function, this is where we can say parent display dot on slot. So that's where we can say parent display slot clicked this, which will go through to the inventory display function, and it'll debug.log slot clicked. So the last thing I want to do is I just want to make the first kind of derived script from this, the first kind of instance of this script. So in our UI scripts folder, I'm going to create C# script. I'm going to call this static inventory display. And we'll open this up. So the first thing this is going to do is going to implement, it's going to inherit from inventory display. And you see that we've got a squiggle here. If we press Alt and Enter, we can implement the abstract class, which is this assign slots function. We can get rid of start and update from here. What we actually need to do is in inventory display, I want to make a public virtual void start, just in case we need to do stuff in there later. And then in our static inventory display, I can do public override void start And this doesn't need to be public, actually. Sorry, that needs to be protected. So protected, override, void start. We can call our base start. So at the top of our static inventory display, I'm going to need two fields. So I want a serialized field, private inventory holder, called inventory holder, and serialized field, private inventory slot UI array called slots. Now in our start function, I can say if inventory holder is not equal to null. So if we've actually assigned it in the inspector, then we can say the inventory system is equal to the inventory holder dot inventory system. We can subscribe to the inventory systems on inventory changed function, and we're going to subscribe our update slots function to that event. The update slot function to the event. So that's the method that we've got on our inventory display here. That event is this on slot changed. So when we do something and add something to the inventory, we call on inventory slot changed, and we invoke that. Here, I'm just going to else, and I'll do debug.log warning, no inventory assigned to this.game object, just so we know if something's gone wrong. And then after all of that, we can say assign slots inventory system. So we can assign our slots and pass in our inventory holders inventory system. Again, inventory system is over on our inventory display class. It's this protected inventory system variable here. And what we're going to do here is we're going to get rid of this throw new exception, and we're going to say slot dictionary is equal to a new dictionary of inventory slot UIs and inventory slots. And then we're going to say for int I, whilst I is less than the inventory system dot inventory size, which, because this is a static display, we've set this up in the inspector to have 10 slots. So we need to make sure that the inventory system that we're pairing it with also has 10 slots. We could check for that and debug it, but I know, I'm looking for the hotbar, which is, I've said for my game has 10 slots. So I've represented that over on the UI. Once that's set up, that should not change. You could, obviously, you would implement a check if you wanted to. So you could check your array size versus the inventory size. And if it's not the same, then do an error. I mean, I suppose for good practice, let's just do that quickly. So if slots.length is not equal to inventory system.inventory size, then again, debug.log inventory slots out of sync on this.game object. So for int I equals 0, whilst it's less than the inventory size, we're going to add to our slot dictionary dot add, and we're going to pass in the key, which is the slots I. So it'll be 0, 1, 2, 3. So it's the corresponding slot in our array. So slots I, and then the value is going to be the inventory system dot inventory I, and I can't seem to get inventory, so I've obviously not made a getter for it. So let's just go to inventory holder, inventory system. Oh, I called it inventory slots here, that's why. So inventory slots I. So that's our value. This is our key. So this is the UI slot, and this is the value of the actual like system slot. So we've added that to our dictionary, and then we just want to initialize the UI slot. So we can say inventory slot. So we can say inventory system dot inventory slots I. Because remember, the init function takes in an inventory slot, an assigned inventory slot, and then it updates the slot as well. So let's just go back into Unity. I'm going to click on player hotbar. I'm going to add our static inventory script, or static inventory display. For the inventory holder, I'm just going to drag in our player. And for slots, I'm going to open up our hotbar. I'm going to click the lock up here to lock the inspector, and I'm going to get all of our inventory slots, and I'm going to drag them into our slots array. Now I want them to be, they need to be in the correct order. So, you know, slot 0, which is this one, is element 0, slot 9, or slot 10, sorry, is this one. So, and this is the size 10. And while we're here, I'm just going to drag the mouse object into the mouse inventory item. I just had an error. I've put button.getComponent button. I need to say button equals getComponent button. So now we need to get some assets. So I'm going to go create folder, and I'm going to call this graphics. Okay, so that's on our inventory slot prefab. I'm going to change. We have this image here. I'm just going to make this like a brown kind of color to kind of indicate the slot being empty. And then we have an image here, which if I disable that, we can see that the slot's now brown. This image that's currently white should go clear when we hit play, because that's the actual item sprite. So let's even, you know, reduce the width and height of this. So 85, 85. So this is the actual slot, which is brown. And then there's the item image, which is white in this case. And let's go back to our inventory slot, go to overrides, hit apply all. So now here's our slots with an item sprite in it. And when we hit play, we're going to clear them out, and we've got our slots now. So when we hit play, they go clear because they've been assigned a blank inventory slot. We can walk around. When we pick up an item, so we've got our test item here. There's currently no sprite icon attached to it, but it will go white. So when we go over an item, it'll go white, and we'll see that we've got an item in that slot. Go over another item, that slot now has an item in it. If we've got multiples of this item, so test item 2 can be stacked. So let's just make a couple of these, hit play. When we go over, you can see that we've now got 3 of these test items in the slot, but there's no icon. So in the next episode, we're going to build upon this system. We'll add in some icons for these. And then we're going to work on the actual click functionality. So at the minute, when I click the slots, nothing happens. Like you can see that I haven't picked it up. I've not done anything. So that's what we're going to work on next. As always, if you're watching these kind of as they're coming out, the full series is already out and over on my Patreon, which is patreon.com/danposs. When you support on Patreon, you'll also get access to the project file packages for each episode as well. So even if you're watching and they're all out, it's worth heading over there anyway. If you want to compare your code to mine, you can do that by downloading the project files. If this episode didn't make sense, if there was something that was unclear, please do let me know in the comments below, or join the Discord server, which is linked in the description. Me or someone else may be able to help you if you're having trouble there. For now, thanks for watching, and I'll see you in the next one. Bye. Okay, so welcome to episode 4 of our inventory system tutorial series. Where we left it off is if we go down here and if we hit play, you can see that we've got our empty inventory slots here, and as we go over the slots, we pick up these two sort of different items. Some of them can stack, the green one can't. There was only one of them anyway. You can see that they've just got these ugly white sprites in them at the minute. So let's get some sprites downloaded so we can actually start to see stuff appear in our inventory. There's this Cozy Farm asset pack, which is a really nice pack. It includes a lot if you pay for it, but you can get it for free. There is a free version. So if you click no thanks, just take me to the downloads, you get this free version .zip and just hit download on that. What you'll get is you'll get this PNG with just some basic tiles. So if we just drag this into our project, so I'm going to go over to our assets folder. I'm going to right click, create folder. Let's type graphics. So I'm just going to drag this PNG in, and we're going to need to do a couple of things first. So the first thing is we want to mark this as a sprite. We want to set the sprite mode to multiple. Filter mode, we want to change to no filter, point. Compression, we can choose none, and then we need to hit apply. This is one image with lots of sprites on it, so we need to slice the image up into its multiple parts. And to do that, we need to access the sprite editor. But if you've just started a normal 3D project in Unity, you won't have the 2D sprite package installed and you'll get this error. So we just need to go up to Window, Package Manager, go over to Unity Registry, and then choose 2D Sprite and just install the 2D Sprite package. So with that installed, we can just close out the Package Manager, select our image again, choose the Sprite Editor, and then we just for what we need, we just want these two sprites here, the potato and the tomato. So if we hit slice, and then just choose automatic, it's going to slice up all of the, it's going to try and detect things to slice. So where you've got a PNG, it'll do a cut around them. It's not worked perfectly for this whole image, but we just wanted these two sprites. So we've got those sprites there. So we can, we've hit slice, so we can just click apply. And now if we expand this out, you can see that what it's done is it's, sliced them up kind of wrongly. But here's our potato and our tomato. So now if we go back over to our scriptable objects and go to test item, and I'm just going to rename this to tomato. I'm going to select tomato, and let's type tomato there. This is a tomato. I'm going to have a maximum stack size of 5 still, and I'm just going to choose the tomato from for the icon. And then I'm just going to do this, and I will say potato. And I say potato and tomato because I won't say tomato. So with potato, when you will choose the icon, and we'll pick the potato icon, and we'll say the display name is potato. And this is a potato. So now we've got our two test items. So now with our test item 1, this is the tomato, which is it's worked out well because it's red. So I'm just going to rename this to tomato. I'm just going to delete the other ones so I don't have to rename all of them. For the test item 3, let's call it potato. And I might actually just change the color of it to be more potato color, because why not? So rename this to potato. Let's pick more of a potato color, which kind of that color, I suppose. So now we've got a potato and a tomato. The potato won't stack. It's got a maximum stack size of 1, so it's not going to carry on stacking. So now we've got our tomato and our potato. We can just, I'm just going to select them both and drag them down to the bottom. I'm just going to duplicate them a couple of times. So I'm going to get the move tool, Control D, let's duplicate them. Control D, duplicate them again. Duplicate them some more. Then I'm going to get all of the tomatoes. Because these stack, we want a few of these so we can actually pick them up. And actually, why don't I do that with the potatoes as well, just so we've got multiple things to work with. So if we now hit, actually let's select all of these and just bring them down to the bottom, and then I'm going to group all of these together under a object just called items, just to keep the hierarchy organized. So let's drag that in. We can just collapse that. So we've got our items here now, and you'll see that as we go over them, now the icons that we've set should appear in our inventory when we pick them up. So there's our tomato. You can see that we've got 5 tomatoes are stacking. And then the potatoes don't stack and they fill up our inventory. Now our inventory's full, we can't pick up any more. And I don't like the font here being black, so let's just go over to the canvas, play a hotbar, get one of our slots and just open it up. And I'm going to change the item count to white. And we can maybe give it an outline, so just check the outline, just so we can definitely see it over the images. So there you go, we've got five tomatoes, so we just need to choose our prefab and then hit apply all, and that'll apply it to the rest of them. So as we hit play, you see that when we've got more than one item, it comes up and shows us the item in our inventory. So now the next thing we want to do is we want to start being able to click on the items and actually do stuff. Because at the moment nothing happens when we click on the items. We want to be able to pick it up and manipulate this mouse item to show the item that we've got selected, and we want to remove it from the slot and do lots of interesting stuff with it. Just to show how that's going to work, we're going to run over these items and then we can pick them up, move them around and place them down. So this is what we're going to be working towards in this episode, moving them between the slots. So let's go back over to our scripts folder, and we've got our UI scripts, and I believe we need to open up the inventory display script. So here's our inventory display here's our inventory display script. In the last episode, you know, we set this up and we set up the static inventory display as a that inherits from this class, but all displays are gonna have slots that can be clicked, and at the minute it just prints out slot clicked when we click it. What we want to do is we want to start picking up items and moving them around. So let's just get to work on that straight away. So first thing we want to do, we're going to need a few different checks because there's a lot of different things that need to happen based on a few different contexts. So if the clicked slot has an item and the mouse doesn't have an item, then we will need to pick up that item, because there's nothing currently on the mouse. We also need to account for if the clicked slot doesn't have an item, but the mouse does have an item, then we need to place the mouse item, place mouse item into the empty slot. We also want to check to see whether both slots have an item. And if they do, we need to decide what we want to do there. For example, are both items the same? If so, we want to combine the stacks if we can. So if we've got, you know, 3 tomatoes on our inventory bar and we're holding 4 from a different slot, can we combine them? And if they're if different items, then we want to swap them. Then swap the items. And actually this one has a bit of an extra step. We want to see that is the slot plus is the slot stack size plus the mouse stack size greater than the slot's maximum stack size that it can take? If so, we need to account for that. So we need to, if so, take from mouse. So we need to take, so if the maximum stack size for tomatoes is 5, and we've currently got 3 in the stack, but we've got 4 on our mouse, then when we click on the item, we're going to take 2 from the mouse to fill the stack, and then we're going to leave 2 on the mouse. Bad math. I'll just show what I mean here. So if we've got you know, so these hearts, they stack to a maximum of 5. We've got 3 in this stack. If I split this, and let's just get 4. So this 3, it can only go up to 5. But I've got 4 on my mouse. If I click here, it's going to fill this stack with 2, because 3 plus 2 is 5, so it's going to take 2 from the 4 that I'm currently holding. So as I click, I've now got 2 left on the mouse. That stack's full. And when it is, and we're also accounting for, if this stack's full and we're trying to place this on top of it, it's just going to swap them. I'll just swap them over. So that's what we're kind of building up towards as well. And I'm not sure if we'll get there in this episode, but we also need to check if the player is holding shift key. And if they are, we want to split the stack. So we want to separate the stack into 2 different stacks. So we want to leave some in the slot and put some onto the mouse. So there's quite a lot to get through here, a lot of functionality to build. We'll try and do it in one episode. We'll see how we get on. So the first thing we'll tackle is this. If the click slot has an item and the mouse doesn't, let's pick it up. Let's put it onto the mouse. So if we make some room here. So this slot clicks. When we click on the button that's attached to the slot, it's going to reach up to the parent display. We look at the inventory slot UI. We've got on slot clicked, which we've added as a listener to the button's on click event. And it's going to reach up to the parent display and it's going to say call slot clicked, and it's going to pass in itself so we know which slot exactly was clicked. So here we can say if this clicked slot, and just so we know exactly what's going on, I'm going to rename this to clicked UI slot. So if clicked UI slot dot inventory assigned inventory slot dot data item data is not equal to null. So if the clicked UI slot has an item in it, so it's not null, and the mouse inventory item dot inventory slot. So why is that not working? Why can't I get that? Oh, because I've not actually added an inventory slot to the mouse. So let's go back to the mouse. We just need to add an inventory slot to the mouse. So we can do a public inventory slot called inventory slot. So we're going to be coming back to this in a second. So I'm just going to move them, and I'm just going to close all these other ones that we don't need. So let's go back to our inventory display class. So we've got click slot item data, and then mouse inventory item dot inventory slot dot item data is not equal to null, is equal to null. So if the slot has an item in it and the mouse doesn't, then we can pick up the item and assign it to the mouse. So it'll be in here that we split the stack if they're holding the shift key. So that's if that, and then we'll do an else. But for now, let's just do mouse inventory item data dot, and then we're going to need to make a function on our mouse inventory item called update mouse slot. And then we're just going to pass in the clicked UI slot's assigned inventory slot. And then we're going to call clicked UI slot clear slot, because there won't be an item in that slot anymore because we'll have picked it up. So let's go make this function. So it's update mouse slot. I'm just going to copy it so we know it's called exactly what we want it to be called. And I'm going to make a public void and then paste our update mouse slot. And this is going to take in an inventory slot, and it's going to be called just inv slot. So here we're going to take our inventory slot, and just to match this up with the clicked UI slot, I'm going to right click and let's rename this to assigned inventory slot, so it matches, just so it matches this, so we know kind of what we're working with. So assigned inventory slot dot assign item inv slot, which is another function we need to make on our inventory slot. And I'm just going to call this inv slot. And we'll do that in a second. So the next thing we want to do is we want to set our item sprite dot sprite equal to the inventory slot dot item data dot icon. So the item that's in the slot that we're putting onto our mouse, we need to set our mouse's sprite to the icon. We want to set the item count dot text equal to the inventory slot dot stack size dot toString, and we need to set the item sprite dot color equal to color dot white, so it becomes visible again. So obviously we set it to clear initially. So now we need to make this assign item on our inventory slot class. Let's go over there. Here we can say public void assign item, and we can pass in inventory slot inv slot, and we can just say here if the item data that that's currently on this slot is equal to the item data that we're picking up. So the inventory slots item data. So if this inventory slot has some item data in it and we're trying to add more of that item to it, then we can just call add to stack and pass in the inventory slot dot stack size. So this is going to combine the items. And we can say else item data is equal to the inventory slot data that we're passing in. So inv slot dot item data. We're going to set our stack size back to 0, and then we're going to add the inventory slot dot stack size to that. So this is going to completely override the item that was in the slot if they're different. So we're basically swapping them. Well, we're not swapping them, we're completely overriding it. So if the mouse's assigned inventory slot had a potato on it, and we passed in an inventory slot with a tomato on it, we're going to assign the tomato to the assigned inventory slot of the mouse. So hopefully that all makes sense. So let's go back over to our inventory display class. So if we've done this, then we can just return, because we won't need to check any of the other stuff because we've already accounted for what we're doing here. So let's just hit save and go back over to Unity. So if we hit play and we walk over our tomatoes and we click the slot, so I'm going to set it on our mouse inventory slot item, which doesn't follow our mouse, which will fix that. I'm also going to do what I did with the text down here as well. I'm just going to set the mouse slot text to white with a slight outline. So now when we hit play, pick up an item. So we've got 5 tomatoes on our mouse slot. So let's let it actually follow the mouse around now. So to do that, we go over to our mouse item data. And because this is a mono behavior, it can get a update function. So we can do void update. And what we want to do here, we want to say if our assigned inventory slot dot item data is not equal to null, So remember, this is the way we check whether the mouse has an item actually on it. So if that's not equal to null, then we want to say transform.position is equal to mouse. We need to be using Unity Engine.input system for this. So using Unity Engine.input system, we want to say mouse.current.position.read value. So if we have an item, set the item's object position to the mouse's current position. So it'll follow the mouse around. And we can go further here to actually delete the item. So if we click outside of the inventory, we can delete an item. So to do that, we can get this function here, which I found on, I think it was Stack Overflow, which to use this, we need to be using Unity Engine.event systems. And we say pointer event data current position equals new pointer event data event system.current. We're going to get the event data's position and set that equal to the mouse's position. And we're doing a raycast, and this will return a list of items that it hits, and it'll hit UI elements. It won't hit stuff in the game world. So if that list is greater than 0, then we've obviously hit UI, so it'd return true. If it doesn't hit any UI, it'd be false. So we can say under here, if the mouse.current.left button was pressed this frame, and we're not is pointer over UI object, so we're not currently hovering over an object, then we can say clear slot, which is a function we just need to make down here. We can say private void, no, public void, because we'll need this later on. So public void clear slot. And this is going to get our assigned inventory slot and call clear slot on that. So we're going to empty out the inventory slot. And then we need to reset our item count.text to display nothing. We want to set the item sprite.color equal to color.clear. And we can actually just null out the item sprite. So item sprite.sprite is equal to null as well. So now we go back to our mouse object and we hit play. You see that if we pick up an item, it will now follow the mouse. You might not want it directly under the mouse, you might want it slightly offset, so we can do that. So we can do that easily. So if we hit 2D and look at our mouse, so the mouse object is sort of anchored here, and this position in the center will be what follows the mouse. So we just want to offset the image by 50, and then we can do -50. So the left corner is now at the pivot. And then we can just drag the text into place. So if we go to item count and drag this down. And one thing you'll notice is that it was behind the UI. When we click it, it goes behind the UI. What we want is we want to get our mouse object and just drag that to it. It needs to be at the bottom of the canvas, which will draw it on top of everything else. We can hit play and you'll see that it appears on top of the UI now. One thing you'll notice is if we pick it up, it doesn't actually fully work when we click to delete the item unless we get away from the mouse quite quickly. The reason for that is that we need to make the mouse image not be a raycast target, otherwise when we click we'll always be over a UI element because it's following the mouse around obviously. And under the item count text as well, we can come to raycast target, and let's just uncheck that. So now when we go back and hit play and we pick up an item, you see that we pick it up and we can click off our UI and it'll delete the item, and that slot is now empty. It's not just the kind of representation of the slot, that the actual inventory slot has been emptied as well. So we can pick up our tomato, it's out of the slot because it's now on the mouse, and we click and it's gone. There's nothing on the mouse and there's nothing in the hotbar, and we can pick it up. We've now got the potato on the mouse. We can delete that, so that's gone out of the game. And we can carry on picking stuff up. So now we could pick up items and we could delete them, but now we need to be able to pick them up and place them back in slots so we can move them between our inventory slots and keep stuff organized. So let's go and work on that. Done that, that's all working. So let's go back over to our inventory display. So we've achieved this. Let's just go up. Okay, so let's have a look. So the next thing is the click slot doesn't have an item, but the mouse does. So let's place the mouse item into the empty slots. Let's move them around. So here we're basically doing this, but in reverse. We're doing the kind of flip of that. So let's make a new if statement. So we can say if, and let's just bring this up so we know what we're working on. So if the clicked UI slot dot assigned inventory slot dot item data is equal to null, so the click slot doesn't have an item in it, and the mouse inventory item dot assigned inventory slot dot item data is not equal to null, so the mouse does have an item. Let's place the mouse item into the empty slot in the same way that we do here. So here we just need to say clicked slot UI dot assigned inventory slot, and then here we need to assign the item directly. So we can say mouse inventory item dot assigned inventory slot dot item data. So after that we need to call clicked UI slot dot update UI slot because we've put a new item in it. So let's just refresh it. Now we could put it in this one and pass in the slot, but this is also called when we pick up an item from the ground, and if we reassign the item when we pick it up, it causes some weird issues and it adds multiple to it for some reason. I'm not 100% sure why that bug was occurring, but so this is the way around it though. You just assign the item directly and then you just refresh the slot, and then we need to do what we're doing here but for the mouse item. So we just need to say mouse inventory item dot clear slot. So if we go back over to Unity, let's just hit play. So as we go over, we can pick up items, we can pick them up on our mouse and we can delete them. We can carry on picking up items. It'll fill up the stack when we pick them up, and then it started a new stack once that stack was full. And we can pick up the items, move them and drop them into the different slots now. And if we look at our player on our inventory, we're actually moving them, we're actually moving the slots to their corresponding slot here. So we can move it and put it into the second slot, we can put it into the last slot. See, this is kind of working as we intended now. So we can pick up these potatoes and we can place them in this slot. And you see that if we pick up the potato and try and place it somewhere else, nothing happens. It has to go kind of into a blank slot. So the next thing we need to work on is swapping slots and splitting stacks. And we will do that in the next video. And I think that will be enough for this video. So we'll do that next time. So in the next video, we'll finish up our thing here. So we'll swap the items and we'll set up stack splitting as well. And we'll also set it up so we'll be able to combine the stacks once we've split them as well, because it's kind of using the similar sort of functionality. So that's it for this video. If you're watching this as they go live, as always, the full series is up on my Patreon already. That's patreon.com/danposs. If you've struggled with anything in the video, need some help, or something's not quite working, either leave a comment below, or better yet, come join the Discord server. An invite for that is in the description of this video, and either me or maybe someone else would be able to help you. It's probably a quicker way of getting a response than here on YouTube. Meantime, thanks for watching, and I'll see you in the next one. Bye! Hello and welcome to episode 5 of our inventory tutorial series. In this series, we're working on building an inventory system, but just to show you where we're at the minute, we can currently walk over items and we can pick up items. They can stack, and once the stack's full, so the tomato's got a maximum stack size of 5, It then goes over to the next free slot, and we can pick up slots and we can move them. As we walk over an item, it'll add itself to the first stack that has some free space in it. And if the stack's full, it'll just get the first free slot on the inventory, so it'll go here when we pick up a tomato. And we can move them around, and we can pick up these potatoes which don't stack, and we can, change the position, and they're actually changing in our inventory here. So I'll place that down, pick it up, and we can also pick them up and drop them out of our inventory to delete the items. But what we can't do at the minute is combine the stacks, swap items, or split the stacks, which is what we're going to work towards in this video. So let's just get started with that straight away. So if we go back over to our inventory system, inventory display class script, you can see that here's the two methods that here's the two kind of cases that we had for what happens when a slot is clicked on. And now we need to see what happens when we take into account some different kind of options. So for example, what happens when both slots have an item? We need to decide what to do, because are both items the same? If so, we want to be able to combine them. If they're not, we'll swap them. Can we actually combine the stacks? Is that possible? Is the stack full? And how full is the stack? So we need to start working on this. So the first thing I'm going to do is we'll account for swapping items, because that's the easiest to do first. So this is all kind of this all kind of flows into each other. So we'll actually work on this first. To do this, I'm going to just come out of this function, and I'm going to make a private void swap slots. And this is going to take in the clicked slot. So inventory slot UI clicked slot. I'm doing this here because we're going to use this function twice up here, so we may as well put it into its own function so we're not repeating stuff. Now to swap a slot, we need to clone the mouse slot first, because we need to make a copy of the mouse slot, so then when we move what's on our hotbar to the mouse, we'll obviously lose what's on the mouse, then we couldn't put the mouse in the empty slot. So we need to make a cloned kind of inventory slot of the mouse's data. So let's just do variable var cloned slot or duplicate slot, and this is just going to make a new inventory slot, and it's going to take the mouse inventory item dot inventory slot dot data, and it's going to hold the inventory slot dot stack size. So we're just making a temporary inventory slot that's not part of any system. It's just a sort of temporary slot in this one function, then it'll be disposed of once we've used it. So now we can say mouse inventory item dot clear slot, because we've got a copy of it, so we can clear it. And now we can pass in the clicked slots item, so we can update the mouse slot, and we can do clicked UI slot dot assigned inventory slot. So this is what we're doing up here when we pick up an item. So we've copied what was on the mouse, and then we're picking up the item that was currently in the slot. And then we want to clear the clicked slot because it's now on the mouse, so we've emptied the slot. And then we're doing what we did here. So we can actually just copy this, paste it here, but instead of the mouse inventory slot, we're going to pass in the cloned slot. And let's just rename this to clicked UI slot. Clicked UI slot. So that's swapping items. So we have an item on the mouse, we make a copy of it, then we clear the mouse off, put the click slot on the mouse, and then put the cloned then we put the copy of what was on the mouse into the UI slot, and then this is disposed of once it goes out of scope. It's not used anymore, so we don't need it. So let's just go back up here So the first thing we want to do is we need to account for both items, both the click slot and the mouse having an item on it. So we can just copy this, paste it here, and we'll say not equal to null and not equal to null. So if the click slot has an item and the mouse slot have an item, we now need to decide what to do. So both slots have an item, decide what to do. So we need to see whether both slots, both items are the same. Like, are we trying to place a tomato on a tomato or potato on a potato, etc.? Or are we placing a potato on a tomato? For now, let's just say if clicked UI slot dot assigned inventory slot dot item data is not equal to the mouse's inventory item data. So if they're not the same item, then we can just say swap slots. And we can pass in the clicked UI slot. So call that there. So now we should be able to swap our potatoes and our tomatoes. So let's hit play. So we can go over, pick up some items, and we can pick up a potato, and we'll swap it for the tomato, and we can put it back down. Now currently nothing happens with the potatoes. We're not adding it. So eventually, you know, there's one potato here. We have one potato on the mouse. We'll click and it'll become two potatoes in that slot. But for now, we can now swap items. So we know our swap item method is working. So let's go back over to our script. So we're back over in our inventory display script. So let's start accounting for what happens if the items are the same. So let's just copy this. So we want to say if the clicked slots item is equal to the mouse's inventory item, and we want to check whether the clicked UI slot dot inventory slot, whether there's room left in the stack. And to check that, we're going to pass in the mouse inventory item dot assigned inventory slot dot stack size. So if we've got 3 potatoes on the mouse and we're trying to place them on top of a potato that's in the clicked UI slot, the slot that we click on, is there room in that stack for the amount of potatoes that we have on our mouse? And remember, this is this bool here. So all it's doing is it's checking whether the stack size plus the amount to add is less than or equal to the maximum that that item can hold. So if we've got a stack size of 3 in our inventory slot on our hotbar, and we're trying to add 2 that are held on the mouse, 3 plus 2 is equal to 5, which is less than or equal to the maximum stack size, which in this case is 5. If we tried to add 3 to a stack size of 3, this would return false, because obviously 3 plus 3 is 6, which is greater than the maximum stack size, so it would return false. We can update our stack sizes, so we can say clicked UI slot dot assigned inventory slot, and we can assign item, assign item, and let's assign the mouse inventory items inventory slot. And let's just remind ourselves what this function's doing. If we assign an item and the slot already has that item, it's going to add the stack to the stack size. If it's not the same item, it'll just overwrite the item, so it'll swap the items around. So in this case, we've already checked whether they're the same item and that the stack size won't go over the maximum stack size. So we can just basically add to the stack that's already there with this item. So we're assigning like a tomato to the tomato, so they're the same, so we're just going to add them to the stack. So then now they've been assigned, we can call update UI slot on our clicked UI slot. And then we need to clear our mouse inventory item because we've combined the items now. So now we need to check whether there isn't room left in the stack, and if there isn't, we need to know how much is actually left in the stack so we can take it from our mouse. So we'll do else if, we'll get this again. And what I'm actually going to do is I'm going to get this and cut it. And then up here I'm going to say bool same item, or is same item. And we'll just put that there, and then we can just say here is same item, and then we can maybe bring this back up to this line because it is quite a long function. And the reason I've done that is because we need this again here. So else if it's the same item and there isn't room left in the stack, so this one is going to have to come down because it's a long one. So if the click slot, if there's no room left in the stack, we need to get out how much is left in the stack. So left in stack. So again, let's just remind ourselves. So we've got two versions of this. We've got one where it doesn't pass it out because we don't need to know. But when it returns false, we probably do want to know how much is remaining. So we can say here, item max data stack size, item data maximum stack size minus the current stack size. So if the max stack size is 5 and we have 3 currently, this is going to return 2. So here, let's open up our curly braces. So if it is the same item and there's not room left in the stack, let's get out how much is actually left in the stack. And we can actually just say if left in stack is less than 1, we can just swap the slots, passing in the clicked UI slot. So, you know, if we have so here we've got a full stack. So as we try and combine them, there's nothing left in the stack. So that'll be less than 1 because it'll be 0, and they swap. And that's just to account for, so here we've got our 2 and we can place 5 on there. So instead of adding 3 to this and leaving 2 on the mouse, it just swaps them, because there's no point, you know, messing around and adding it to that stack just to leave them when we're going to get the same result from swapping them. So we can just swap them directly. So if left in stack is 0, which is essentially saying is the stack full. So let's just leave some notes here so we're fully aware of what's going on. So the stack is full, so swap the items. And we'll do else. So else the slot is not at max, so slot is not at max. So take what's needed from the mouse inventory. So let's do int remaining on mouse, and we're going to say equals the mouse inventory item dot inventory slot assigned inventory slot dot stack size minus left in stack. So if we've got 5 on the mouse and there's left in the stack is on the clicked slot is 2, this remaining on mouse int would be 3 because we've taken 2 from the mouse to fill up the stack. So then we can say clicked UI slot dot inventory slot dot add to stack. And we're just going to pass in the amount we want to add this time, not just because we already know that this is the same item. We don't need to call assign item. We can just add to the stack directly. We can just pass in left in stack. And then clicked UI slot dot update UI slot. And then let's update the mouse with how much is left remaining. So we can say variable new item is equal to new inventory slot with the assigned inventory slots data and our new amount, so remaining on mouse. Then we'll clear the mouse slot, and then we'll update the mouse slot with our new item. Then we can turn this if into an else and attach it to this whole statement. So If the item's the same and there's room left in the stack, let's combine them. If the item's the same and there's not room left in the stack to take the full amount, how much can it take? We're just checking whether it can take less than 1, so the stack's full, and we'll swap them. Think about it, I don't know if that would ever get called, but you know, it works, so I'll check that in a second. Well, let's check that in a second, but we're saying else. Let's calculate how much would be remaining on the mouse when we fill up the clicked UI slot stack. Let's fill up the UI slot stack, and then let's make the mouse inventory item have the new amount. And else, if they're not the same, so else if not is same, let's just swap the slots. Okay, so back in Unity, we can't currently split the stack, so it's kind of hard to show this off. But what I can do is if I click our player and I go over, you can see that we've got 5, 5, and 1. These are these tomatoes. I can change the inventory amount directly. So I can say there's 3 in this one, 2 in this one. And then if I, that won't update the UI because I've manipulated them directly. So I'm going to have to just pick them up and put them back down to get the correct amounts in there. So now we'll be able to see the combining of the items. So we've got 3 tomato stacks here with all different sizes. I'm going to add the 2 to the 1. So now there's 3 slots. We've combined them. 3 plus 3 will be 6, and the maximum stack size is 5. So I'm going to pick up the 3, place 2 into this stack. So now there's 5 in that stack, which is the maximum amount. And then we can put our 1 back down. And if we click, it'll just swap them around because the stacks are full. Like one of the stacks is full, so they won't combine. So the last kind of implementation of this is splitting the stacks, and then we'll be able to work on the chests and etc. in the next episode. So let's get the stack splitting working. Let's go back over to our inventory system in Visual Studio. Okay, so let's just come up here and type in bool is shift pressed, and we'll say this is equal to keyboard.current.left shift key .is pressed. So if the left shift key is pressed when we click on a slot, this would be true, and if it's not, it'll be false. This is using the new input system, and it's using it directly. If you wanted to use your input action asset and have it so players can change which key is the split stack key, you'd have to do that through the input action asset and like maybe use like an input manager. We're just going to read it directly here because this isn't an input system tutorial, it's a inventory system tutorial. If you want me to go over and cover that in some more detail and actually do some input system stuff, let me know in the comments below. But for now, we'll just check it directly and hard code it, so it'll always be the left shift key. And it's here that we're going to check this and split the stack if possible. So for now, I'm just going to say if is shift pressed, and then we're going to and if it is, then we'll split the stack. So we'll and split stack. And we'll say else. So if the shift key isn't pressed, then we'll just pick up the item as we have been doing. So to actually split the stack, we're going to make a method on our inventory slot. So we'll say if shift is pressed and clicked UI slot dot inventory slot dot split stack, which is a method that we're going to make in a second. So let's go and make that. So let's go over to our inventory slot class, and let's just let's come down here and we'll do a public, and this is going to be a bool because it's going to return false if we can't actually split the stack. For example, if there's just one item, we won't be able to split it. So we're going to say public bool split stack, and this is going to pass out a new inventory slot because it's going to have a new inventory slot with the split amount already in it. So we can say out inventory slot split stack. So let's just start defining this. So if stack size is less than or equal to 1, then we're just going to return null. So we're just going to return false, and split stack will be equal to null. But if it is greater than 1, so if there's multiple items in the stack and we can successfully split them, let's just calculate how much half the stack actually is. So we'll do half stack equals, and I'm going to do mathf.round to int, and we'll do stack size divided by 2. Then we'll take half the stack size off this amount. So let's just use our remove from stack function, and we'll pass in the half stack size. So we're going to take half the stack off the current stack. We're then going to set the split stack equal to a new inventory slot with the item data and the half stack amount in. So if we have 4 and we've held down shift and clicked, we're going to split the stack. It's going to split the stack from 4 divided by 2, so the half stack would be 2. We'll remove 2 from the 4 that we currently have in the stack, and then we'll make a new inventory slot with 2 of the same item in it, and we'll pass that back out to our inventory display. So we can say out inventory slot, and this is the half stack slot. So we can put so here we know there's nothing on the mouse, so we can just update the mouse slot with our half stack. And because we've changed the slot directly on the clicked slot, we can just update the UI, and this will check for its new amount and it'll refresh it. And then we can just return, because we're done, we don't need to carry on. And just to be kind of consistent, we can put our returns in elsewhere. It won't matter too much, but let's just return once we get to those kind of key points, because there's no point trying to process the rest of the code, because we have separate if statements. So it'd return and then it'd try and do this, and it'd be confusing, so we just need to return out of them. That should be our split stack. Oh, we're not. We need to return true here. Return true there because we successfully split the stack. So let's go back over to Unity. Make sure we've cleared the log. Make sure there's no errors. Let's hit play. So we can now pick up loads of tomatoes. And we've got 2 here. We can hold down shift and click, and we can pick up 1, place the 1 down. We can combine them back together. We can hold down shift, split the stack, so we'll take 2 from it because we've rounded up. We can click again. We can add 2 to 2, 4 to 1. They'll swap. There's 2 there. Let's split them again. So let's pick up the potatoes. If we hold down shift, it'll just pick up the slot, because it'll just pick up the potato because we can't split one, so it'll just pick it up, place it back down. We can't combine these items because the maximum stack size is 1. And then once the inventory is full, it won't pick up any more items unless it can add them to an existing stack. And we can clear our inventory of all of the potatoes and start picking more up. So I think that's a good place to leave this video. All of the core functionality of manipulating the inventory is now done. What we're going to work on in the next video is the ability to access the chests. So you see in my test project, as I walk up to a chest, I can press a button on the keyboard and the inventory window pops up. I can place items in it. I can close the inventory, come over to this chest. It's a smaller chest, there's less inventory slots assigned to it. We can put in 5 hearts there. We can go back to this chest, and this chest has its inventory system all set up and ready to go. We can take them back out. And we've got the same sort of functionality as well, so we can put them in and we can split them here, and then we can take one out, leave one in, come pick up this item, you know, try and put them in, it'll swap, and we can put them back over here. So yeah, that's what we'll work towards in the next video. As always, if you're watching these videos as they go out, the full series is already up over on Patreon, which is patreon.com/danposs. As well as all of the videos, I'm exporting packages at the end of each episode with the scripts. So if you need to follow along and you want the code to check against yours, you can get that by subscribing over on Patreon. If you do have kind of any issues and you want some help, let me know in the comments below. The best place for help is probably the Discord, though. There is an invite to the Discord in the description box, because you can post code snippets there, and it's a bit easier to share links to stuff than a YouTube comment, and it's a bit more real time. So if you do need any help, I recommend going over to the Discord. But in the meantime, thanks for watching, and I'll see you in the next one. Bye. Hello and welcome to episode 5.5, I'm calling this one, because I said in the last episode that the next episode would be looking at the chests in the chest system. But before I do that, I just want to go back through the code and do a bit of a code review and just start commenting it. So hopefully going forward, if anyone has any issues, they can, you know, the code will make a bit more sense. And I'm going to release this kind of mid-week, so it's this isn't going to replace the chest video that will come out when it was supposed to come out, and that will be episode 6. So if we go over to our inventory item data script, I'm just going to type 3 slashes and do a summary at the top of this script. So this is a scriptable object that defines what an item is in our game. It could be inherited from, to have branched versions of items. For example, potions and equipment. Because they would all have different stats. So, you know, we've defined that an inventory item data at the very top level, it'll have an ID, a display name, a description, an icon, and a maximum stack size. You could have like a monetary value as well, so you could do public int like gold value, so how much it's worth, and then you could derive a new script from this and have a potion object or have a sword object or some armor. So you could have multiple classes that inherit from inventory item data, and they would still all plug in to our inventory system because it'd have the kind of base stuff that we need, for example the icon and the max stack size. I mean, this is all self-explanatory, these are all named kind of self-explanatory, so I think that's fine. So let's kind of move up to inventory slot. So this is a reference to the data of what makes up an item. This is the current stack size of the slot, so how many of the data do we have? These are the public getters for these. So this is a constructor to make a slot with stuff in it. So constructor to make a occupied inventory slot. This is the constructor that makes a blank slot. So constructor to make an empty inventory slot. I mean, it's self-explanatory, but clears the slot. So this one assigns an item to an inventory slot that's already been made, because all inventory slots are created at the start and they're empty. So we can actually assign an item directly to the slot. So it assigns an item to the slot. So here we're seeing does the slot already contain the item we're trying to assign to it? So does the slot contain the same item? And we can add to the stack if so. So add to stack if so. And else, if it's not the same item, we're trying to assign a different item to the slot, then let's overwrite the data, reset the stack size, and add how many of the item that we're trying to assign to the new slot. So else overwrite slot with the inventory slot that we're passing in. We've also got update inventory slot, which assigns the data and the amount directly. It doesn't reset them. I can't remember exactly where we're using this, but I'm pretty sure we are. But just updates slot directly. Now this code, some of this may end up being redundant, and we can always go through at the end and try and like do a bit of refactoring and tidy everything up, because I do think I've doubled up on some kind of code systems here, but it works at the minute, so that's fine. We've got our room left in stack function, so this is checking, would there be enough room in the stack for the amount we're trying to add? So if we're trying to add 2 to the stack, if the current stack size plus the 2 that we're trying to add is less than or equal to the maximum stack size, then there is enough room left in stack. And if there's not, we can return false. So actually, maybe we could rename this to enough room left in stack, because that's what we're actually checking. We're not, room left in stack makes it seem like we are trying to get the amount remaining, but we're not always trying to do that. We're just checking, is there enough room left in the stack to take this amount? Let's just call that enough room left in stack. I mean, this is self-explanatory. You can add to the stack and remove to the stack. Here, we're not taking into account the item data's maximum stack size, which could be a bad thing, but in the inventory system, we're taking that into account before we actually add it to the stack. So that's why we don't ever go over the maximum stack size, because we are checking that here before we add it to the inventory in the inventory system. So, we could check and return a bool if it can't, but that's kind of what's happening here. We're doing enough room left in stack, and then if there is enough room, we're adding it to the stack, and we're checking that here. So this is fine, stack size plus amount, like it won't ever go above the maximum stack size. So here with split stack, again, it's kind of self-explanatory, but we're saying here, is there enough to split? Is there enough to actually split? Because we can't have 0.5 of something, we can only have 1 of something as the maximum. So we need to make sure that the stack size is more than 1. So if not, we'll return false and nothing will happen. But if there is, we'll just half the stack. Get half the stack. We'll remove from stack. That's this. We'll minus the half stack from this current inventory slot. And then we'll just return a new inventory slot with the half stack, so we can assign that where we need to assign it. So creates a copy of this slot with half the stack size. So hopefully that kind of makes sense. So the next kind of thing up in our kind of hierarchy is the inventory system, which it contains all of the slots. So let's go over to our inventory system. So this is the list of inventory slots that kind of, makes sense itself, which will have a size that we pass in here. So this is the constructor. That sets the amount of slots. And then depending what size we pass in, we just do a loop and add to this list empty slots. Like So if we pass in 10, we're going to make 10 empty slots and add it to our list. Then we've got our add to inventory, which is going to check, which again is kind of self-explanatory. It checks whether the item exists in the inventory, so does it contain the item? And it will pass back out a list of all of the slots that contain that item. And then for each of the slots in that list, we're going to check, is there enough room left in the stack for the amount that we want to add? And then if there is enough room left in the stack, then we add it to the stack, and we just return true and invoke our event on inventory slot change so the UI can update. If there isn't enough room left in the stack, nothing happens. So if there isn't enough room left in the stack, then we come out of this if loop and we check, do we have a free slot? So an empty slot. If we do have a free slot and we pass back out the slot that is empty, then we update that UI, the free slots inventory slot with the amount that we want to add. And then we call our on inventory slot changed event. So actually here, we probably will need to check for the maximum stack size, because realistically, we shouldn't ever pick up more than, you know, the stack size's amount, but we do need to check for that. So what we can do is we can just check this. So if free slot, enough room left in stack with the amount to add, then if there is, we'll update the inventory slot of the free slot and then call our on slot changed event, and we'll just return false if neither of these are true, so the inventory is full. Okay, so we actually need to rename this to enough room left in stack. There's a bit of an issue there. Let's just see, will that get rid of that? Yeah, that should get rid of that error. So let's just make sure this free slot system works now we've changed it. Which it didn't, so let's just double check what's going on there. So we need to check that item data is actually valid. So if item data is not equal to null, actually we can just get rid of that and say if item data is not equal to null and stack size plus amount to add is less than or equal to the item data's max stack size, return true. Actually, if it's null, we want to say it has enough room in the stack as well. So if it's either null or it's not null, and the stack size is, you know, this meets the requirement, then return true, else return false. So let's just try that. So there you go, that's still working. So this gets the first available slot, checks whether that slot has enough room in it, and if it does, it'll add it to the inventory. It's just a bit of a fail-safe to make sure it never goes over the stack size. And we could also, you know, here in the future, add implementation to only take what can fill the stack and check for another free slot to put the remainder in. For example, in Minecraft, you can put multiple items on the ground. You can have like a stack of, you can have multiple apples and you'll pick them up, it'll fill up the stack, then it'll put whatever's left into a new stack. So we can add, that's where we can add the implementation there if we want to. Currently, we'll just check the free slot, and if the free slot doesn't have enough room left in its stack, nothing will happen, it'll just stay on the ground and we won't pick up the item. So here we're checking, do any of our slots have the item to add in them? If they do, get a list of all of them. And if they do, return true. If not, return false. Creating a list of all of the slots that equal the item data that we're trying to add to our inventory. I'm going to put them in a list. If that list isn't null, so if it has found them, then return true, and if it is null, we'll just return false. And this is just get the first free slot. So the first slot that has no data in it, the data is null. So just get the first free slot. Okay, so that's the inventory slot looked at. Let's go up to inventory holder. And this is very simple. All it does is it creates a new inventory system based on the size that we've given it. And in the next few videos, we're going to spin this out into a player inventory and a chest inventory. And they'll inherit from inventory holder and they'll have their own kind of systems in place. But for now, I think this is kind of, self-explanatory. So let's look at our mouse item data script, which is the one that when we click on a slot, we update this mouse slot. So the item sprite count is all kind of self-explanatory. The assigned inventory slot, that's fine as well. To be safe, we can do get and private sets on these, because we don't need to set them externally. We'll always set them by updating the slot on. We'll actually use this method to update the slot. So this is going to assign the item to our inventory slot. It's going to set the sprite, text, and color to whatever we've assigned. If it has an item, follow the mouse. So if has an item, follow the mouse position. As a bit of a to-do here, we're going to add the ability to use a controller, and it'll follow the controller around the screen instead of the mouse, and it'll go from slot to slot. So to do add controller support, we'll do that towards the end though. So if we do have some item data, we're going to set the current position to the mouse's current position. And if we press the left button and we're not over any UI, we'll clear the slot. Here we can have a to-do, and this is going to drop the item on the ground instead of deleting it. If you want to do that, we can go ahead and do that. But for now, we'll just delete the item. We'll click outside and it'll disappear and be deleted. All this clear slot is doing is it's just clearing our assigned inventory slot and then resetting the values to kind of their defaults and hiding it so that the mouse item data won't be seen. And here's that code that I got off Stack Overflow to just show whether the mouse position is currently over UI. So when we click, we're doing a raycast from the mouse position, and we'll create a list of everything that we hit that's on the UI layer, because we're using the event system, which responds to the UI. And if this list is greater than 0, then we've obviously hit some UI elements, so we won't delete the item that's on the mouse. But if it is 0, then we haven't hit any UI, so we're clicking into the world, so let's delete the item on the mouse. We've already looked at our inventory item data. Let's go and look at the pickup. So this has got a pickup radius and some item data. That's all self-explanatory. Collider, self-explanatory. We're getting a collider, we're setting its trigger to true and setting the radius to pickup radius. Now on our trigger enter, we're just looking whether the thing that hit us has an inventory script. If it doesn't, we're just going to return, nothing will happen. If it does, we'll try and add ourselves to the system's inventory. If that's successful, we add it to the inventory and that happens, then we'll destroy the object. And if not, nothing will happen and we'll just stay on the ground waiting for onTriggerEnter to be called again to check again. Once we implement the player inventory and chest inventory scripts, we'll have to change this up slightly, but for now this is fine. So over on our inventory display script, so this is just a reference to our mouse item data. This is the object in the game world. This inventory system is the inventory system that we are trying to display. We set this in our static inventory display by getting it from the inventory holder. We make a dictionary of inventory slot UI elements and their kind of system counterparts in our slot dictionary. So pair up the UI slots with the system slots in a dictionary. And then we've got a getter for the inventory system and this slot dictionary in case we need them. We've got a protected virtual void start in case we need to do anything later on in the start method, and we can override that in our static inventory display, which inherits from this class. We've got an abstract void assign slots, which we don't do here because it's going to be different based on the kind of child classes. So this is implemented in child classes. Update slot is a method that's called on our inventory system when something changes on the inventory. We pass in the slot that's updated, and then we search the slot dictionary for that inventory slot. And if it is that slot, we update the key, which is the UI slot. We'll update that slot's UI. And we've said here, so slot.value is the under the hood system slot. The key is the UI representation. So if the system says in system slot 3, we've updated and we've picked something up, it will update the UI slot that's paired with the system slot in our dictionary. Okay, slot clicked. I think I covered this quite well in the last video we did when we built this out, 'cause this is already all commented, but I'll just go through it again. So if the player is holding the shift key, which we've hard coded here, if you wanted to allow the player to change this, you'd have to use the input system to do that and create like an input action asset, for example. And here we're saying, does the clicked UI slot have some data on it? We're checking to see whether the item doesn't. So does the clicked slot have item data? And does the mouse have no item data? If the player is holding the shift key, then we'll split the stack. Else, we will pick up the item in the clicked slot. If we're not trying to split the stack, and if we can't split the stack because there's only one item in the stack, then we'll just pick up the item instead. Now here we're checking, does the click slot not have an item in it, and does the mouse have an item in it? Because if it does, then we can just place that item into the click slot. And then we're going to check, so both slots have an item, so we need to decide what to do. So here we're checking, is it the same item? And is there enough room in the stack to take everything from the mouse? If there is, both items are the same. So we're going to combine the stacks. We're going to place the mouse item onto the click slot. Here we're seeing, is it the same item? And if it is, and there's not enough room left in the stack, so if there was enough, it'd do this. If it's not enough room left in the stack, then we need to find out how much room there is left and kind of account for that. So if it's less than 1, we'll swap the items because the stack's full. And if the slot isn't at max, then we'll take what we need from the mouse inventory and add that to the click slot and just leave however much we haven't taken still on the mouse. And if it's not the same item, so if we're trying to put a potato on a tomato, it's not the same item, we can't combine the stacks, so let's just swap them. So we'll assign the tomato to the mouse and put the potato where the tomato was. And then swap slots, we are cloning our inventory slot from the mouse because we're going to overwrite it and we need a copy of it so we can put it back in. So here we need to make a copy of the mouse's inventory item because we're then going to clear it and update it with what's on the click slot. And then we need, because it's cleared, that's why we've cloned it, so then we can put that information back into the clicked UI slot. So we'll make sure the UI slot's being cleared, we'll assign the new cloned slot, and then we'll update the UI slot's elements to kind of show the system slot now on the front end. We'll come back to inventory slot UI. Let's just stick with the inventory display. So this inherits from our inventory display class, which we've just been through. We're going to call base start on an overrided start, just in case, like I said, we want to call anything in the inventory display start. And now here we're saying if our inventory holder isn't equal to null, then let's get the inventory system of our inventory holder and subscribe to the on inventory slot changed event and assign our update slot function to that, which is on our inventory display. So that's this here, which is called when we add in an item to our inventory from the ground. So we're going to subscribe to that method. I'm going to debug.log a warning here if this isn't the case, just so we know what the problem is, that there was no inventory assigned to the object. And then we can just assign our inventory slot systems, which is this abstract method, which I've said is implemented in the child classes. So that's implemented here. So it's public override void assign slot. It takes in an inventory to display, which is our inventory system. It creates a new dictionary in memory from that slot dictionary that we've said we need. And because this is a static display, it needs the right amount of slots for the inventory size. So here we're saying if the slots.length, which is an array of our prefab UI slots, if that's not the same as the inventory size, then we'll just debug.log to say that the slots are out of sync. But if that's not the case, then we will go into a loop and we'll add to our dictionary that we've just made, we'll add the slot and its corresponding system slot. And we'll initialize this, and we'll initialize the UI slot with its counterpart inventory slot from the system. So in our init function, you can see that that just assigns the inventory slot and then updates the UI slot, just in case, you know, if we're loading the game and something's already in our inventory system, then it'll update. It'll show that straight away. It won't just be a blank UI slot. So then finally, over on our inventory slot UI, we've got that init function, like I just mentioned. But this is kind of like the mouse item data. So there's the sprite, the count, and an inventory slot, which has been assigned. It's also got a button element on it. And then here we're just getting that button. We're subscribing our onUI slot click event to that. And we've also got a variable called parent display, which gets the inventory display component on our transform.parent. So the inventory slot UIs are childed to the parent display, which is inventory display. That could be static or it could be the dynamic inventory display, but we're just getting the top level inventory display because that's all we kind of care about. And the reason that we only care about that is because when the slot's clicked, all we're gonna do is access our parent display slot clicked method and pass ourselves into it. And that's on inventory display.cs. That's not on the static inventory display. So other than in it, we've just got update UI slot, and then we're gonna update the UI slot and pass in a inventory slot to display. So we're going to say if slot.itemData isn't equal to null, then we're going to set our sprite and the color to white, and then we're going to set the stack size. And if it's over 1, we'll set that, and if it's 0, we won't display any number in the stack size. And if the data is null, if the inventory slot is empty, then we'll set the item count.text to blank, the sprite invisible, and we'll null out the sprite. Then we've also just got a version of that method that doesn't take in an inventory slot. And we call this when our assigned inventory slot isn't equal to null. So we call this method and pass in our assigned inventory slot. And then we've got clear slot, which just clears out our assigned inventory slot. So it empties it, clear slot, it just sets it to null, stack size -1. And it sets our item sprite to null, our color to null, and our text to just blank. I mean, that's all pretty self-explanatory, so I've not bothered to leave comments on that. Okay, the problem, I just noticed a problem. We can't do get private set here, because if we do that, we can't set them in the inspector. So let's just get rid of that. We didn't need to do that anyway. It's fine that these are public. If we wanted to have a getter, we could make them private and serialize, so we can set them in inspector, and then do what we're doing here and just make a public property. But let's just reset that to not be get and private set. And then actually in our mouse object, we'll have to reassign our image and our item count. That was a silly mistake on my part. But yeah, so this is where we are at. That's all of the code in review. We can pick up everything. It'll add itself to a stack. If we move this to the end and pick up more tomatoes, it'll add it to that one because it'll find it. That's full, so it'll find the first free slot. So that's where we are. That's the end of episode 5.5, which was the code review, which was an extra kind of lesson to go through, just to kind of recap on all the code. I hope that all makes sense. And I hope if you were confused about anything previously, that's kind of cleared up and you kind of get it now. As always, leave a comment below or join the Discord server if you want to, if you want help with anything. If you're watching these videos as they're going up live, the full series all the way through to the end is currently available over on patreon.com/danposs. And so are packages from the end of every lesson. I save out a package with the scripts in that current state so you can compare your code with the code from that lesson if you want to. Again, they're over on Patreon, which is linked in the description. But for now, thanks for watching, and I'll catch you in the next one. Bye. Hello, welcome to episode 6 of the inventory tutorial series. In this episode, we are going to be covering the dynamic display. So at the minute, we've got our static display, so there's always 10 slots. And these slots fill up with our tomatoes and our potatoes, or so these fill up, and these are static. These are always the same. But we have a small chest here and a big chest, and we want to be able to access the small chest and the big chest, and we're going to have a window that pops up and displays their own individual inventories. But, we don't want to have to make a different screen based on every sort of inventory size that we want, because we may want something to only have one inventory slot, something to have 30. We want a bit more of a flexible system. We could do that by making a script that derives from our inventory display class. So just like our static inventory display inherits from inventory display, we're going to make a dynamic inventory display script. So let's just right click, create C# script, and we'll call this the dynamic inventory display. And let's just have a look at how this is going to work. So this is the test project here. So if we hit play, so I've got my hotbar here. I can press tab. I can press B on the keyboard, and my backpack inventory comes up. And I can go over here and I can access the small chest, which, here has, I think that's 10 slots. Or we can go across to our big chest, then this has got 20 slots. And our backpack has 50 slots, I believe. Yeah, so there we go. We've got 50 slots in our backpack. So you can see how that's scaled up. I need to play with the anchoring because it's gone up to the top of the screen. But we can do that. We can sort that. So let's go back to the project that we're currently actually working through. And let's just open up our dynamic inventory script. So again, our dynamic inventory display is going to inherit from inventory display, which is the kind of base class. So let's replace mono behavior with inventory display, and let's just get rid of the update function and get rid of this comment, and we can just say protected override void start, and we want to say base dot start. But before we do the base start, what we can do is we can subscribe to our inventory holders on dynamic inventory display requested event. So we can say inventory holder dot on dynamic inventory display requested, and I'm going to subscribe a method that we've not created yet called refresh dynamic inventory display. No, just let's call it refresh dynamic inventory. And we can even make this just public void refresh dynamic inventory. And this needs to take in an inventory system. And I'm just going to call this the inv2 display. And here we can say our inventory system is equal to the inv2 display. So inventory system is the inventory system here. This is the inventory system on our inventory display. And we're just setting that to the inventory to display that we're bringing in. And we're bringing that in from our inventory holder script. On our inventory holder script, we've got this Unity action, which is static, so we can access it from anywhere like we've just done. And it's called on dynamic inventory display requested. And it passes in an inventory system. And we're not currently invoking this anywhere yet. We will do in a second. We'll work on getting the player's backpack working first. And then if we have time in this video, we'll work on the chests. If not, we'll do the chests in the next video. Let's just see how far along we get. So let's go back over to our dynamic inventory display class, and let's just finish implementing this. So we have a red squiggle. That's because we aren't implementing the abstract class, the abstract method that we made in our abstract inventory display class, and that's our assign slots function. So let's just get rid of our system not implemented error. But the first thing that we want to do on assign slots for our dynamic inventory displays, we want to clear all of the slots that were there from the last time that we looked at an inventory. So you can see that when we were accessing the chests in the project, my test project that I've already got set up, the actual slots delete when we close the we'll close the panel, and then when we go to open up the panel of a different chest, it'll clear all the slots, it'll just delete all of the prefabs, and then it'll spawn them back in. It'll spawn the correct amount back in. So instead of 20 slots, there'll be 10 or 5 or however many the inventory display has or needs to actually request. So the first thing we'll do here is we'll do private void, and let's make a method called clear slots. And we need to be using system.link here. So what we're going to do here is we're going to say for each variable item in transform.cast transform. So this is going to get all of the children on our transform. So this is going to sit on the top level object, and it's going to have UI slots underneath it. So it's going to get all of those. And we just need to say destroy item.gameObject. Now, a more efficient way of doing this would be to use object pooling. So instead of destroying and instantiating new slots, we could just disable them and clear them and add them back to a pool. This isn't an object pooling tutorial, so we're not going to do that here. We're just going to directly destroy them, but just know that that is an option. If you want to go and look into object pooling, you can do so, and that'd be a better way to do this. But for now, for what we need, this works fine. So as well as this and destroying the actual objects, we want to clear out the slot dictionary. So we can say if slot dictionary is not equal to null, then slot dictionary dot clear. And again, just to remind ourselves, the slot dictionary is the dictionary that pairs a UI slot with an inventory system slot. So we clear that out when we clear the slots. So in our assign slot function, we can just say clear slots. And then we're going to do a similar thing to what we do here in our static inventory display when we assign our slots. We're going to pair a slot with our inventory system's inventory slots array. So first thing we're going to do is, because we've cleared the slots and we've cleared this, we can just make a new dictionary over the top to make sure that it is definitely clear. So new dictionary inventory slot UI inventory slot is the key and value, and we can say that if inv to display equals null, then let's just return out of this because we don't want to start accessing it if it's null. So it's just a good way of checking to make sure that we're not going to get any null reference exceptions. And then we can say for int equals I, whilst I is less than the inv2display dot inventory size, we're going to make a new reference to a UI slot, which we are going to instantiate. So instantiate, and I'm just going to say slot prefab, which is a variable we'll set up in just a second. And then I'm going to put the parent as this transform. And let's come up to the top and let's just make a serialized field protected inventory slot UI slot prefab. And I'm just making this protected just in case down the line we want to inherit from this class. For example, we may want dynamic inventory displays to. We may want some of the functionality that this provides, but expand on it a bit more. For example, NPCs with a shop. They would have multiple probably dynamic inventory displays, or they'd have some custom functionality that chests, for example, wouldn't need. So we're just making that protected just in case down the line we want to access it. We don't need to come back here. Something I forgot to do, because we're subscribing to this event here, we just want to unsubscribe from it if we need to. So I'm just going to say on destroy. I'm just going to say minus equals refresh dynamic inventory. That's something that we need to do. But let's come back to our assign slot. So we're going to get a variable called UI slot, and it's going to instantiate this slot prefab and then just store a reference to the specific slot prefab that has been created. And then we're going to add it to our slot dictionary. And this UI slot is going to be the key. And the value is going to be the inventory to display dot inventory slots I. Because, you know, we're in this loop. And it'll go for, this is going to create the exact amount of slots that it needs, and it'll pair the slot with the current index that we're on in the for loop. And then we can say UI slot dot init for initialize. We can pass in the inventory to display inventory slots I, and then we can just call UI slot update UI slot here. So this is just like our static inventory display. So we're doing a loop, we are adding the slots, but we just, because the slots haven't been defined here. And up under our base.start, I'm just going to assign slot inventory system. And pass in our inventory system. I'm just going to do that once, so it clears it out and it sets up anything that it needs to set up. I found that not doing that here, when we access it the first time in game, it wouldn't actually show anything that was already in the inventory. So we just need to run this method just once here, and that sorts that out. So if we press Control S to save that. Now let's just go back over into Unity, and let's go to our canvas, and underneath our canvas, let's just open this up. So here, I'm just going to make an empty object. I'm going to create empty, and I'm going to call this the inventory UI controller. And I'm just going to make our hotbar and our mouse object a parent of the inventory UI. And then for our inventory, and then underneath our inventory UI controller, I'm going to right click create UI, and I'm going to choose panel. I'm just going to call this dynamic inventory. And I'll bring this just up above the mouse object, just so the mouse object renders on top of the UI element that we're going to make. And I'm just going to add component, and we're going to add our dynamic inventory display. And I'm just going to drag in our mouse object item to our dynamic inventory display. And I'm going to go over to our prefabs, and I'm going to drag in our slot prefab over to it. So now let's get a content size fitter added to this. And we can set this to preferred size. And then we want a grid layout group. So we've got our grid layout group, and under padding, I'm just going to put some padding in. So 10, 10, 10. For cell size, I'll have that at 100, and I'll just put some spacing in as well. For child alignment, I'm going to choose upper center. And constraint, I'm going to have a fixed column count. And I'm just going to have 10 columns as our fixed column count. So if we just drag our prefab directly under our dynamic inventory, we can see kind of what that's going to look like. So let's just add them in. So you can see that how that's going to look when we add sort of more and more. So that's with 51 slots, which is probably too many anyway. So let's just delete all of those out. Press Ctrl S to save. So we've got our dynamic inventory here. Let's go up to our inventory UI controller and let's try and get this set up and working. So we need to make a script on our inventory controller. So let's go back to our UI scripts folder and let's right click, create C# script, and we'll call this the inventory UI controller. And let's open this up in Visual Studio. So here for the inventory UI controller, I'm going to keep the update method, and I'm just going to get a public dynamic inventory display, and I'll call this the inventory panel, which is what we've just made. And here I'm going to make a onEnable function, and onEnable I'm going to say inventory holder dot on dynamic inventory display requested, and I will put a display inventory method which we're going to create, and then on disable we'll just want to unsubscribe that method from it as well, just to be safe. So we can minus equals display inventory, and then in our display inventory function, which we'll make here, void display inventory, which will take in the inventory system inv to display. So this is going to say inventory panel dot game object dot set active to true, and inventory panel dot refresh dynamic inventory, and pass in the inv to display. Which actually, thinking about it, that makes this redundant. We don't need to do this, so let's just comment that out. And we can actually get rid of this as well. We don't actually need to call it on start. So let's get rid of those. The reason that we don't need to call it on start is because in our inventory UI controller, when we set it to active, we're refreshing it anyway, passing in the inventory display. So now we're only subscribing to this event in one kind of place, which is fine. Which is a bit cleaner than subscribing here and calling it twice. And we can actually say here in our refresh dynamic inventory, we can call clear slots here, take it out of assign slot, and we can call assign slot here. So a little bit of refactoring. So now on our UI, on our inventory UI controller, this is going to receive this request to display an inventory. It's going to set the panel to active, and then it's going to refresh the dynamic inventory, which is going to clear out any old slots. It's going to update the inventory to display, and then it's going to assign slots, which will do all this. So let's save that, go back over to our inventory UI controller. So let's just test this is all working now. So let's say using Unity engine dot input system. In our update function on the UI controller, we can say if keyboard dot current dot, and I'm going to say B key for like bags. So if the B key dot is dot was pressed this frame, then we're going to bypass this method, and we're just going to display inventory, and we'll make a new inventory system with a size of, let's say, 30. So we'll just, we're just making a new inventory system here when we press the B key, and we're displaying that. And actually, let's just see this working. So we can actually say random.range, and we'll say between 20 and 30. So if the B key was pressed, display the inventory and create a new inventory system to display with a random size of between 20 and 30. And then we can say if the inventory panel.gameObject.is .active in hierarchy. So if it's set as active, and keyboard.current.escape key was pressed this frame, then let's set the panel back to false. Let's close our bags. So let's just check this is working. So we can go over to hit play. We need to add the inventory UI script to our controller. We need to assign our dynamic inventory display. And what we can do is we can set it to false in the awake method. So we know that it's going to be closed already when we first start. So let's just set it to false if it's not already. So you can see that the dynamic inventory is enabled at the minute. When we hit play, it'll disappear. So we've got our inventory here. We can press B to open our bags, and you can see that it's created our inventory slots. If I press escape, it'll close the panel, and they are still there. But when I press B again, it'll delete them and it'll make another one of a different size. We can press escape, B. So you can see that here we're now getting a panel that responds dynamically to different inventory sizes. Now obviously if I put something in this, when I press escape, it's getting deleted, the inventory system we're making, so those items will just disappear. So let's work on doing this so it's actually permanent. So let's make a chest now. So let's go back over to our inventory system project, and we'll get rid of this. We don't need that. Let's keep this one though, so we can press the escape panel to close any sort of chests that we're looking at. We'll bring that down so we can actually see that, so it's a bit more neat. So we've got let's make our chest script now. So here, let's go over to our project again. Let's go into our inventory scripts, and let's make a new C# script called chest inventory. Let's open that up, and this is going to inherit from inventory holder, and we're going to get rid of the start and update function, and we're actually going to use using Unity engine.events, because we're going to need to implement a Unity action, which will pass in the type of interactable, which is an interface we're going to make in just a second. And this is going to be called on interaction complete, which we can put get and set. We won't actually use this in this tutorial, but it's going to be enforced by this interactable, which we're going to make now. So let's go back over to our project, and I'm going to make a new folder in our scripts folder called interfaces. And we need to make an interface for all of our interactable items in the game. So C# script, and let's call this interactable. So let's open up that script, and this again is going to be using Unity engine.events. It's going to be an interface, so let's get rid of mono behavior and public interface interactable. So it's going to need a public Unity action which passes in a type of iInteractable called onInteractionComplete with a get and set. We're going to have a method called public void interact, which will take in an interactor, which is another script we're going to have to make. I'm just going to call that interactor, and it'll pass out a bool of whether the interaction was successful. And we also want a public void end interaction. So let's just copy this. Let's go over to Unity, and in our scripts folder, let's right click, create C# script, and let's call it interactor. So now that's fine, that's filled in. Let's just line that back up. I'll work on the interactor script in just a second. Let's go back over to our chest inventory and make sure this is inheriting that interface, so iInteractable, and we should get a squiggle in a second. Yep. So we press Alt and Enter. It'll add those the interface's methods. Let's get rid of them. And I'm actually going to move interact up above the end interaction, just because it's a bit neater like that way. So interact is going to be a method that's called when we try and interact with the chest. So when we open the chest. So obviously here we need to say on dynamic inventory display dot requested. Is anyone listening out for this event? And if it is, let's invoke it and pass in our inventory system. So again, this is deriving from inventory holder. This event is on our inventory holder, and so is our inventory system. So we're going to call that event when we are interacted with, and we're going to we're going to invoke that and pass in our inventory system. And then we can say interact successful is equal to true. So we're not actually going to use end interaction here. This is just enforced by the iInteractable interface. Stand line, maybe you want a event on interaction complete to fire when something happens, then you'll call that in the end interaction function. And for example, if your player moves away from the chest, that you could call on interaction complete and be listening out for that on the UI controller. And then, so instead of pressing escape, you'd be listening out for that event, and that would set the panel to false instead. But I'm just going to try and keep it simple. So we're just going to interact with the chest, and we'll call the on dynamic inventory display requested, and we'll just pass in our inventory system. So now we need to be able to actually interact with the chest, and that's what this interactor component is going to be. This is going to sit on our player. So let's go build that quickly. But there's lots of different ways to do this. The way I'm going to do it is I'm going to make a public transform and call this interaction point. I'm going to have a public layer mask called interaction layer. I'll have a public float, which is the interaction point radius, and I'll set this equal to 1f. And I want a public bool called is interacting with a get and private set. And in our private void update function, we're going to make a variable called colliders, and we're going to equal this to physics.overlap sphere, and we're going to pass in the interact point dot position as well as the interaction point radius as our radius. So as we're walking around, if we interact with anything on the, and then we need to pass in our interaction layer as well as the third parameter. So as we're walking around, if we overlap anything that is on that interaction layer, at that position, and within this sphere that we're making, it'll store it in a collider array, which you can see there. So collider array physics.overlap sphere, that's what it returns. So this will be a collider array called colliders. And now we can say that if and we'll say keyboard dot we need to be using Unity engine dot input system. So here we can say if keyboard dot current dot and then whatever key you want. I'm going to use the E key dot was pressed this frame. Then we're going to loop over all of the colliders that we are currently overlapping. So colliders.length I++. I'm going to say var interactable is equal to colliders I dot get component I interactable. So we're going to check every collider that we're interacting with to see whether it's got the interactable interface on it. If that's successful, interactable won't be null. So we can say if interactable is not equal to null, then we've successfully found an interactable item, which is what this interface indicates. So we can just say start interaction, and we can pass in the interactable. And all I'm going to do there is this is going to be a void start interaction, which takes in an I interactable called interactable. And it's just going to say interactable.interact, and it's going to pass itself in and get back out the interact successful bool. The reason I've spanned this out as its own method is because in your movement script, for example, you may want to be checking the interactor component to see whether the isInteracting bool is set to true. And if it is true, you may want to disable movement. So here you could say isInteracting is set to true. And then at some point, you could have an end interaction, an end interaction method that sets isInteracting back to false, and you'll call this somewhere in your script depending on your code. So for example, we could say here, if colliders.length is 0, then we're not interacting. Or if we move a certain distance away from the thing that we collided with, we could choose this. This is just a way of keeping track of what the interactor is doing. It's not going to have any effect on what we're doing, but hopefully this is just something extra that you can expand upon. Again, this is a tutorial on an inventory system, not an interaction system or something like that. If you want me to cover this more in detail, let me know in the comments below. But just know that all we need is this interactable.interact. So if we're overlapping anything here and the E key was pressed this frame, then we're going to search through the overlaps. We're going to try and find the interactable component on all of these colliders. And if we find one, we'll start our interaction, which we'll call interact on our iInteractable, which in this case would hopefully be our chest inventory, which will just say on dynamic inventory display requested, passing in its inventory system, and then our dynamic inventory display would show that. So let's get this all set up so we can get that working, and I think that would make a good point to end the video. So we've got our player movement script on our player. Let's just add our interactor script, and we need an interaction point. So under our player, let's make an empty, and that's 0, 0. Let's just call that interaction point. Let's move it forward, and I'm actually just gonna give it a little gizmo so we can see it in the scene, and we can assign the interaction point on our player script. On our interaction layer, we can make a new layer and we'll call it interactable. And then we'll go back to our player and we'll choose the interactable layer as our interaction layer. And our radius, let's set it to, let's just leave it at 1 for now. And let's go over to our small chest. Let's add a chest inventory component to it. And we'll say the small chest can have an inventory size of 10. And we'll make sure that it's got a box collider on the actual inventory on the chest. So let's bring this up. 1.5 maybe. There we go. And let's remove the colliders from the cubes underneath it. So we'll just remove components. Set our small chest onto the interactable layer. And we can change the children as well. It doesn't really matter. For our big chest, let's again add a box collider. Let's bring it up 0.5. Increase the scale on the X to just match the shape of our chest. Get our cubes, remove the box collider. Go back to big chest. Set its layer to the interactable layer. Yes, change children. Let's give this a chest inventory script. And let's say the chest inventory has a size of 20. So our small one's got a size of 10. So let's see if this works. And if it doesn't, let's debug it. So we'll hit play. We'll pick up some items on the way. So you can see here that our little yellow point, let's fly over here. Our yellow point is inside our chest. And you can see that I've pressed the button and the panel has come up. We can press escape to get rid of it. We can press E. So I opened up the big chest. So we press E, the big chest with 20 slots opens. Press escape to close it. We can come over here, press E. The small chest opens, press escape to close it. We can open it back up with E. We can put our tomatoes in it. We can press escape to close it. We can pick up some potatoes, open up our big chest. We can store our potatoes. Press escape, go back over to our tomatoes. Press E to open it, our tomatoes are there. Press shift, split them. We can do all of the same stuff. We can, leave our stacks there like this. Press escape, walk over, press E on our big chest. Get a potato back out, maybe leave 3 in, put a tomato in, press escape, walk back over here, access this chest. All of our tomatoes are there. And this is because obviously over on our chest inventory system, when we close the panel, all of our inventory slots stay there. So if we press escape, obviously the chest inventory script has its inventory system on it, and that's now full of those items. So they exist in memory even when we're not actively viewing them. So that kind of works exactly as you would expect it. And we can move them again, get them here. You'll see that we've got 1 tomato in slot 1. Let's combine these. So now we've got 4 tomatoes. These are all null now because they're empty. And we can pick them up, put them back in our inventory, hit escape, pick up some more stuff. So everything is working as we would expect. So hopefully I explained the interaction system okay. I did very much gloss over it. If you have any problems or would like to see another series on the interaction sort of script and how we can get that working in a bit more detail, do let me know in the comments below. But I think that will do us for now. I think that's a good place to leave it. We've got the chests set up and working. It all came together quite quickly at the end. As always, if you're watching this as the videos go up weekly, the full series is complete and already up over on Patreon, which is patreon.com/danposh, and you can find a link for that in the description. As well as the full series, you'll also find the project files. So at the end of each episode, I'm exporting the scripts kind of as is, like this project where we are now. I'm saving that out as a package, so you'll be able to compare your So you'll be able to compare your scripts with my scripts to see if anything's going wrong. If you do want any help with anything, if you've got any questions, either leave a comment below or better yet, join the Discord server. Because over on Discord, it's a bit easier to get real-time feedback and you can share your scripts easily, you can share code excerpts. A link for the Discord is in the description below as well. In the next episode, we'll work on the player's backpack system. So they've got the hotbar and if we press B, it'll open up a dynamic backpack display. And when we walk over the items, if the hotbar's full, they'll go into the player's backpack instead. So that'll be in episode 7, which is the next episode, which will air in a week if you're watching these as they go out. But in the meantime, thanks for watching, and I'll see you in the next one. Bye! Okay, so welcome to episode 7 of the inventory tutorial series. Where we left off in the last episode, we got chest inventories working. So you see that as we play the game, we can walk around and pick up these objects. Then we can come over here and access our chests and put objects in the chests. We've got all the same functionality where we can split up all of our items. We can back out of the chests, pick up some more stuff, go over here, access this chest, put our items in the chest, back out, walk away, and, just as you'd expect it to work. So the one thing that's missing really is that the player doesn't have a backpack. We've only got the hotbar and then that's it. We can't, once the hotbar's full, we can't pick up any more items. So the next thing I'm going to work on is giving the player a backpack. So when we press B, a similar panel to this will pop up. So we can put things from our hotbar into our backpack and then walk away and close it and carry on going about our business. And one thing that I want to add is the ability. So now once we pick up inventory items, it'll check the hotbar first, and if this is full, it'll move on and it'll check for a player inventory, and then it'll add themselves to that. And this will help solve another issue as well. So if I give this item a rigid body and then hit play, all that's happening with this pickup script is it's just looking for an inventory holder component. It's not looking for specifically a player. It's just looking for the chest. It's just looking for an inventory holder script, which a chest is. It does have the inventory holder script on it. So if there was a character walking around and they accidentally walked through the item, they'd pick up the item. You may only want it so it picks up the player, and there are a couple of ways we can solve for that. One of those is the fact that only the player has a rigid body. So if they were the only character in your game to use a rigid body, then it wouldn't go into the chest if something with a rigid body collided with it. Whereas if it collided with the player, it would. We could also check to make sure the thing that hits us is tagged with the player tag. That's one way of doing it. But because we're going to be doing a player inventory holder anyway, we can just make our item pickup look for the player script, not any other kind of inventory holder script. So let's just get started on that. So the first thing we want to do is we want to come over to our inventory scripts, and then we can right click, create C# script, and we'll just call this player inventory holder. So let's just open up this script in Visual Studio. So just like our chest inventory script, this is going to inherit from inventory holder. So inventory holder. I'm going to keep the update so I can listen out for a keyboard press. And for that, I'm going to want to use Unity Engine.input system, and we'll look for when we press the B key, and I'll do that in just a second. The first thing we want to, we can get rid of the start function, and we just need to serialize a field and make a protected int backpack size. So on our inventory holder script, we've got our inventory system, which has an inventory size, and I might actually want to rename this. I'm going to double click, right click, rename, and I'm going to call this the primary inventory system. And I'll do the same for this, rename primary inventory system. So in our player inventory holder script, I can actually rename this to secondary inventory size. Oh. And we can have a serialized field protected inventory system. We can call this the secondary inventory system. And then we can have a public inventory system called secondary inventory system, which just returns that. And we need to override our awake function. So we've got private void awake. Let's just change this to a protected virtual void awake. So our protected virtual void awake, we're going to make our primary inventory system, but on our player system, we can do protected override awake, which calls the base awake, so that'll set up the primary inventory system. And then we can say secondary inventory system is equal to a new inventory system with our secondary inventory size. So we're going to use this event, this on dynamic inventory display requested, just like our chest does. And I'm going to listen out for the B key. So if keyboard.current .b key was pressed this frame, then we'll just call the on dynamic inventory display requested, and we'll invoke that and pass through the the secondary inventory system. So let's just hit save there and close this down. So we can go over to our player script, and instead of our inventory holder script, let's remove this and let's add in our new player inventory holder. And we can give our primary inventory system, which is our hotbar in this case, 10. And our secondary inventory system, let's give it a size of 30. Let's just hit play. So we've got a error here, and it's because we need to reset our player hotbar needs a reference to our inventory holder. So now if we hit play, so that's all working. We've got our hotbar, that works. We can press B and it'll open up our backpack. We can pick up some more items. So you see at the moment, as we go over it, the items aren't adding themselves to our inventory backpack. They're staying on the ground. So that'll be the next thing we work on. So let's go back over to our inventory system script and back over to our inventory holder script. So in here on our player inventory holder, similar to our inventory system script, we're going to want a public bool add to inventory. And this is going to take in the same parameters as our inventory systems add to inventory method. So this is going to take in an inventory item data called data and an amount. So the first thing we'll do is when we pick up an item, we'll add it to our primary inventory system, which is our hotbar in this case. So add to inventory and pass in the data and the amount. And remember, this returns true or false depending on whether it was successful in adding it to it. So if it was successful, then let's just return true because it was successfully added to our hotbar. If it returns false, then let's try and add it to our secondary inventory system, passing in the data and the amount. And we can just return true if it manages to go into our backpack. And then we can just return false if that wasn't successful. So let's go back over to our script here. And what we're going to need to do now is we need to refactor very slightly the item script. So let's choose an item and we'll open up our item pickup script. So here, instead of saying get component inventory holder, we can just get component player inventory holder. And because this is a var, it doesn't matter, we don't need to make a new type, this still works. And then instead of saying primary inventory system dot add to inventory, we can just call add to inventory directly on our inventory holder. And that should just work as is. So let's go back into Unity and we'll hit play. So now as we go over, we'll see our backpack fills up with potato, our hotbar fills up with a potato, and then they start to go into our inventory. You'll notice though that they don't refresh while we go over it. We have to open up our backpack again. So let's solve that next. To do that, let's just go back over to our dynamic inventory display. And because this works in the same way as our static inventory display, where we make a new dictionary and pair up a UI slot with one of our system slots, we can subscribe to our inventory system method event on inventory slot changed. And where we want to do that is we can subscribe to it in our assign slot function. So underneath inventory to display, actually we can do that in the refresh dynamic inventory where we assign our inventory system here. What we can then say is inventory system dot on inventory slot changed, and then just subscribe our update slot method to it. And just to remind ourselves, when that's called, it'll look through the slot dictionary, and if the system slot exists, then we'll update the UI slot for that UI element. So we can come back over to our dynamic inventory display, and we just want to make sure that this is valid first, otherwise we may get an error. So we can just say if inventory system is not equal to null, then let's subscribe to its on inventory slot changed event. And let's just copy this. And then when we close the panel with the escape key, we can call on disable, and we can just unsubscribe from the event. So let's hit save, go back over to Unity. So we can pick up all these potatoes, and you'll see that as they start to go into the inventory, they get, as if it's open while we walk over them, it fills up the inventory. And press escape and close that. We'll come over to our chest, put in the potatoes, and pick up some tomatoes, put them in there, and close that. You can see they're all still there. We haven't got any errors in our console log, and that's not filling up this panel because this is a different inventory system. So we can close that and open up our bag, and there's the tomato that just got picked up. So that was all working. That's a very simple little change, but that allows you to kind of carry on walking around with your bags open. So instead of having the backpack be a dynamic inventory system, you could set it up as a static inventory system. If you know that your backpack's never going to change throughout the game, in terms of size, you could set it up obviously as a static system, just like the player hotbar, and then that would allow for, you know, positioning, say your backpack up here. Then you could redesign the inventory, the chest system to come over here, and you may want to move stuff from your backpack over to your inventory system. So what you could do there is, if we go over to our dynamic inventory display, and then let's set the constraint count to 5 columns instead of 10, so it's not as long, it's like half the width. And let's anchor it to the right side of the screen, and we can drag over the X column so it's positioned kind of over here on the right hand side. Let's do 450, why not? So we know this is going to be the width of it, so let's just see what that looks like when we actually open it up. So we've got our dynamic inventory display there. So that was when I pressed B on the keyboard, it opened up that. We could probably move it up a bit as well. So now let's just Control D and copy this dynamic inventory, and let's rename this to player backpack And again, make sure mouse object is at the bottom of the hierarchy so it appears above all of the elements. And let's go over to our inventory UI controller and open up this. And we need to copy this and rename it to like player backpack panel. We can just call this the chest panel instead. And actually I'll right click rename so it changes throughout the code, so chest panel. And then what I'm going to do is I'm going to go over to our player inventory holder script and then go through to our inventory holder script, and I'm just going to copy this action and go back to our player inventory holder script. And then down here, let's just say using Unity engine.events. So we can get a Unity action that passes in an inventory system. And I'm going to say on player backpack display requested. So on player backpack display requested. So it's a public static Unity action that passes in inventory system, and it's called on player backpack display requested. And I'll copy this, and I'll just swap out that event, the on dynamic display, to the on player backpack display requested. And we'll go back over to our inventory UI controller. And here we can say player inventory holder dot on player backpack requested. And we can plus equal, and I'll say display player backpack. Copy that. Unsubscribe for it on the on disable function. Let's copy this method, and we'll say display player backpack. And what I've done here is I've said display player backpack, which isn't what we want. So let's just copy this back up so it's spelled exactly the same. And instead of chest panel, this is going to set the player backpack panel, player backpack panel. And then again, we can copy this and say player backpack panel. So we'll close it if we press the escape key. So let's now minimize this and go back into Unity. We've got our player backpack, which is in the exact same place as our dynamic backpack. So let's now snap this over to the left-hand side. Put the anchor over the left-hand side, and we'll drag this across to the left of the screen. And I'll mirror the y-axis, so we'll just completely mirror this. So minus 450, and then our dynamic inventory is at, I'll say 115. Player backpack 115. So they're at the same sort of size and height now. So if we press play now, nothing happens, and I think that's because we need to go to our inventory UI controller and drag in our backpacks. So player backpack panel goes into the player backpack panel. Dynamic inventory can go into the chest panel. Is that what the issue was? Object reference not set. Yeah. And actually, let's duplicate this, and we'll do the same. We'll close the player backpack panel as well. And we hit play. See, now we can open our bags. That's going to come up on the left-hand side. We can pick up all of our items. They'll go into the player backpack. Then we can come over here, and we can open up a chest panel. So these are the two different chest panels, and our backpacks are still open, and we can move stuff from our backpack into the chests, and then we can close out of them, go back into the game. We can pick up the tomatoes off the ground. They've of course gone into our backpack, and then we can come over, we can open our chests, we can combine these items, we can split the stack actually and take two back out, come over here, open up this next panel, bring in our tomatoes here. Take a couple of potatoes from our hotbar, put them in the small chest, exit out, take more out. So that's all working kind of as intended. So that's going to be it for this, for the initial kind of batch of videos of this series. If the series does well and it has a lot of interest and people actually watch it and want to see more, I do have some ideas of where I'd like to take it. I'd like to introduce an NPC that you can sell items to from your backpack, because obviously the NPC will need their own inventory system with a sell button that you know, it'll check all the value of everything that you're trying to sell them, and then it'll give you that amount of gold back. So that's something I'd like to kind of do in the future if this series works and it's well responded to. I'm currently looking into kind of the best method to save the backpack system. So obviously this video doesn't tell you how to save and load, so if we go back and hit play, obviously everything resets. So I'm currently prototyping how I personally go about saving this inventory using JSON, so that'll be kind of an update to the series as well down the line, if I can figure out that and get it in a concise way to pass that over. One very simple and easy way to do that is instead of our inventory system just being a normal class, this could be a scriptable object. So instead of adding on the inventory holder, creating a new inventory system here, what we could do is, if the inventory system was a scriptable object like our items, you could have it so you could right click, create inventory system, and instead of inventory item, you could have an inventory like underneath it. You could create a new inventory, put its size in, and then assign that in our player holder script. Because the data in a scriptable object, if you change it, that's just how it is. It doesn't reset. So if I hit play, and if I come over to the potato and I set its gold size to 10, so for example, if this was a scriptable object and it was an inventory system, and I had loads of inventory items and I changed how many I had, when you stop playing, this data stays the same, and that works even when you build the project as well. So a kind of easy-ish way of saving your inventory systems is to go the scriptable object route. But because I know I do want to build a save load system anyway, I've gone for the kind of normal class route. So that'll be kind of an expansion, if you will, to this series, if that's what people want. If there's anything else specific that you want to see in an expansion to this course, let me know in the comments. As always, the project files for this entire course, including all of the scripts from each individual episode, I've exported each episode's script at the end of that episode. If you want to compare your script to what I've done, then come over to patreon.com/danposs and you can get access to them there if you support me on Patreon. If you want to discuss the course or get help with any kind of elements of this course or this episode in particular, then again, leave a comment below or join the Discord server, which is linked in the description. But in the meantime, thanks for watching, and I'll see you in the next one. Bye. Hello, welcome to today's video, which is episode 8 of the inventory tutorial series. In this video, we're going to work on creating a save load system, which you can see here. So I'm going to say walk over these tomatoes and we can get some of these potatoes. In this chest, I'm going to place our 4 tomatoes. In this chest, I'm going to place our 2 potatoes. Actually, I'm going to put 1 potato there, and I'll put a potato here. And I'm going to walk away, hit save. You can see here that we've got our save game file. I'm just going to open this. And you can see we've got some collective items, some active items, we've got values. So this is our chest and our inventory. And how that actually looks in game is if we come out and hit play. So those items that I picked up are back. The chest will be empty. If I hit load, the items that we'd already picked up are going to disappear. We can go back over and we can see that our 1 potato is here in the chest, our 4 tomatoes, and our other potato. So if you want to see how I did this, stay tuned and make sure to pay the course fee, which is 1 like or 1 subscribe. And for bonus points, why not hit the bell notification? But with that said, let's just jump into this and see how it all works. Now, as a prerequisite, I guess, for this video, I recommend you watch this save data video I did. I explained the concept kind of behind what we're going to be doing here, so I'm not going to cover over them. I'm just going to go quickly through kind of the code. So I do recommend using watching through this video first. That said, obviously if you are a Patreon, you can download the files and use the code or just follow along as I type the code out. I'm not going to be explaining kind of every little thing I'm doing with the save system because I went into a lot more detail with that here. And of course you can find that linked in the description below. Okay, so with that said, let's just jump straight into doing it with our little project here. So the first thing we're going to do is I'm going to right click, create, and I'm going to create a folder here. And we're just going to call this save load, and this is where our save load scripts are going to live. So we'll open up that folder there, and then we'll right click, create C# script, and we'll call this save load, because this is going to be a static class that we use to save and load. Just as a side note, I've upgraded to Rider. I've not been using Visual Studio, so that's why the IDE looks different than the rest of the videos, but the code obviously is all exactly the same. But yeah, just so you know, I'm using Rider now instead of Visual Studio. So we've got our save load script here. And as I said, this is going to be a static class, so we can call it from anywhere. So we can get rid of the start and update, get rid of mono behavior, and we'll just type in static there. So this is a public static class called save load. So the first thing I'm going to do is I'm going to add two public static Unity action events, and we're going to call this on save game, and we'll also do a public static Unity action, which is going to take in something that we're going to call save data, and we'll have to make that class in a second. And I'm just going to do on load game for that, and then we're going to want two public strings here as well. So public static string, and actually these could be private static string called directory. I'm going to set this equal to save data, and then we're going to have a private static string called file name. And I'm going to set this equal to savegame.sav. Now I'm going to create a public static bool method. So public static bool, and this is just going to be our save, which is going to take in some save data. So this is going to be the data that we want to save to file. And we're going to have a public static load function. And this is going to return our save data. So at this point, I think we need to make this save data. So go back into our scripts and into our save load folder. And I'm just going to, I'll do this within Unity actually. So if we go over here, I'm going to right click, create C# script, and we'll call this save data. So we'll let that compile and open up that in our IDE. So we've got our save data here. So you see that these have all stopped being red now. So for our save function, I'm going to call the onSaveGame Unity action, just so we know when the game is trying to save. And we can do string dir equals application.persistent data path plus our directory. And here we can say if directory dot exists. So if this directory doesn't exist, and this is using the system.io namespace, so you need to make sure you include that. So if directory doesn't exist, then obviously we need to make this directory, which we can do here by saying directory dot create directory dir. So just very quickly, we've got our string here, which is called directory. This is save data. We're making a dir, another string called dir, which is the application persistent data path, which if you've watched the other video, this is our local low folder on our C drive, plus the directory. So, and we're going to see if this directory exists. So have we saved the game before? Because if we have, this will exist. And if not, let's just create this directory here. So then we're going to make a new string, and we can just call this JSON. And this is equal to our JSON utility dot toJSON data and true. So this data here is the data that we're passing in, and we're going to convert that data to a string, which will then save to file. And this true here is just for pretty print, which I believe it organizes the file a bit easier so you can read it a bit better in a text editor instead of putting it all on one line. And then we can do file.write all text and set this equal to dir plus our file name. And the text that we're writing out is our JSON string. Again, if you don't understand any of this, and this is the last time I'll say this, but just watch the other video I did that I showed at the start of the video and you'll fully understand what I'm doing here. So here I'm going to debug.log, save in game, and then we can just return true. Now, the reason this is a bool is because we may want to return false if some of the parameters don't get met. So for example, if we're already saving, you could check to see whether the file stream's open or if this file's being accessed. But for our basic case, we're just going to always return true if we save. For your game, you may want to do something differently, and then therefore it will return false. So there may be a path that you take that can return false. So the framework's there for you to use if you need to. So for our public static save data load, what we want to do here is we want to get our string, and this is going to be a full path, and this is going to be the application dot the persistent data path plus our directory, and then this time it's plus our file name. So we're going to try and load this savegame.sav file from our directory. And we need to make a new piece of save data just called data, and we'll set this equal to a new save data, which is going to be a new instance of our save data class. And we need to get rid of mono behavior because it's not actually going to live anywhere kind of on an object. We create a new one, and then we need to check now whether our file name exists, like whether the save game actually exists. So we can just say if file.exists, and we're going to pass in the full path. If the file does exist, then we're going to get the file and turn it back into a JSON string. So we can do file.readAllText. So we used write all text here. We're going to do read all text here. And we're going to read all the text from the full path. And then we can use the JSON utility to turn that back into our save data. So we can do JSON utility dot from JSON. And we're going to turn that into a type of save data. And the string that we're going to turn back into some save data is our JSON. So there we go. And here we can say that on load game dot, and then we can invoke this, passing in the data that we've just loaded. If the file doesn't exist, then we're just going to do else, and we can do debug.log save file does not exist. And then regardless of whether we've, because we've already created some data, we can just return that data at the end. If it's got to this point, it'll just be the new save data that we've made. So for example, if we're starting a new game and the save game hadn't existed, we're just going to return some data to get started with. But if it did exist, then we're going to return our actual instance of the save data. So now let's actually start to build our save data, like what we're going to actually care about saving with our inventory system. And before we can do that, we actually need to serialize a dictionary. So the dictionary is going to be responsible for saving our chest inventory. But you can't serialize dictionaries kind of from the get-go. We're going to need to make our own version of a dictionary that's serializable. So let's just go back into Unity. That needs to recompile. So in our save load folder, I'm going to right click, create C# script. And this one is just going to be called serializable dictionary. So in our serializable dictionary class, I'm actually just going to copy this in. So this is the code for that. I've got a link in the description, but basically that's this script here. You don't need to know really the ins and outs of how it all works. But back in 2013, there was this question posted about saving out dictionaries and keys. And even though this was the accepted answer, this script here works really well. It says here that you need to derive a non-generic class from that one. I've not needed to do that here. Maybe it's because we're using JSON, but this just works as a serializable dictionary. So head to the link in the description. You can copy that script into our serializable dictionary.cs file. Make sure you've spelt the name of the file right compared to the name of it here. Otherwise, it won't work. So we can go back over to our save data CS file, and we're going to do a public. And this is going to be a serializable dictionary, which is the class we've just made. And it's going to be of type string and a type of chest save data, which isn't something we've made yet. We'll make that in a second. And I'm just going to call this our chest dictionary. And I'm going to make a constructor here and do a public save data constructor. And we can say our chest dictionary is equal to a new serializable dictionary of type string and chest save data. So now we're going to make our chest save data. This is going to be a struct, and we're actually going to put this into our chest inventory.cs file. So here we can come over to our chest inventory script, and outside of this class, I'm going to flag this as system.serializable so we can save it out. And we're going to do a public struct chest save data. And this is going to keep track of our inventory system. So public inventory system, inv system, a public vector 3 of our position, and a public quaternion of our rotation. And then we're going to make a constructor for this. So we'll do a public chest save data. This is going to take in an inventory system, which I'll just underscore inv system. We'll do a vector 3 underscore position and a quaternion, which is rotation. And then we can set our inv system equal to the underscore inv system position to our underscore position, and rotation equal to underscore rotation. So this is our chest save data put together. So now what we need is, so our framework is getting there quite nicely now. So just to have a quick run through. So we've got this action here on load game. That's going to be called when we load the game. And so it's going to get our chest inventory from file. And we can hook into that onload function and check the data and find the chest's inventory within our save data. So let's just go up to the top here. So I'm underneath the iInteractable. I'm just going to do a public, a protected override void awake, and we may need to make protected virtual void, protected override void awake. We can call base.awake, and here we can hook into the save load dot we can hook into our save load dot onload game, and we can make a new function called load inventory. and we'll create that function here. So this is, oh, sorry, I need to get rid of the brackets. So this is going to take in some save data, and this is going to check the save data for this specific chest's inventory, and if it exists, load it in. So how will our chests that are in the world, so how will this chest here differentiate itself from this chest here? They're going to need some sort of unique identifier that can say like, hey, I'm chest number 1. Does the save data that I've just got from the load game have a chest number 1? And if it does, like, can I get my inventory back, please? And it'll load it into this. This one can be chest number 2. So we're going to need another script called unique ID. If I click our chest here in our test project, you can see I've got all of these chests here. So I've got my small chest here. You can see that I've got this script, unique ID, and I've got a unique ID. This is our ID here. This is persistent between saves and states and scene loads. So we'll right click, create C# script, and we're going to make a unique ID and load this up in our IDE. Okay, so we've got our unique ID script here, and this is going to be a mono behavior because it's going to live on our object. Now we're going to need a couple of attributes above. So we're going to do a system.serializable as well as execute in edit mode. So we're going to have a serialize field, and this is going to be a private string, and we're going to call this ID. And this is going to be equal to a new GUID, and we can do .toString. Now we need this to be read-only, and we need to make our own read-only attribute. So I'm going to go back over to Unity, and I'm going to right-click, create C# script, and we're going to call this read-only attribute. And then we can open this up, and I'm just going to paste this one in. It's a very simple one-line class. It's just public class read-only attribute, and it inherits from property attribute. So now if we go back over to our unique ID, we can add this read-only tag here. And let's just add this to our chest. So I'm going to add our unique ID field to this chest here. And you can see that we've got our ID here. This is our unique ID. So we've got this property attribute, which we've called read-only. It's just this simple script. And this has to interact with a editor script as well. So back in our project, you need to make a folder called editor, and it has to be called editor. So right click, create folder, editor, spelled like that, like editor. And then here, we're going to create another script called our read-only draw. And this is the script for that. So we've got our public override void on GUI, which takes in a rect, position, serialized property, and our GUI content, which is label. And we're just setting the edit for the property to false. So if we go back over to our chest, and we add our unique ID script onto our chest, you can see that this ID has been generated, but we can't click in there or change anything about it, and that's perfect. We don't want to be able to change that code because it needs to persist kind of throughout our game. So I'm just going to save our scene there. So that's our unique ID generated, but we're also going to want a serialize field. It's going to be a private static serializable dictionary, and this is going to take in a string as well as a game object. And I'm going to call this our ID database, and we can set this equal to a new serializable dictionary of those types. And I'm going to do a public string ID, and this is going to return our private ID string here, so we can get this ID from other places in the project. And in the onValidate function, I'm just going to want to check whether our ID database already contains a key. If it does already contain our ID, let's generate a new one. And this is just going to make sure that we don't have any keys that are the same. This is going to be a new method called generate that we're going to create. And if it does exist, then we can do else ID database, and then we can add our ID as well as ourselves, so this .game object. So now the actual chest in the world is linked to its ID. So we'll be able to find this, we'll be able to use this information in lots of other places. I also want to make a onDestroy function, so private void onDestroy. And so if we delete the chest from the world and it contains, the database contains this key, then obviously we want to remove our ID from the ID database because it's not a thing anymore. So remove _ID. All generate's going to do is it's just going to do this again. So we can just copy that bit of code there. And once it's generated, we're just going to add it to the database. So this is just covering our backs to make sure no IDs are the same and that the ID database is filled with IDs and the relevant game objects. So that's our unique ID script and our read-only attribute and the read-only draw. So back to our chest inventory script. So we've hooked into this onload game. So now we can actually load the inventory. So what I'm going to say here is if data, so the save data, if the chest dictionary contains our ID, so get component unique ID, and from that component we're going to get the ID, then it's going to pass back out the chest save data, and we can just call this the chest data. So remember, our save data has this chest dictionary, which has got a string. This is going to be our chest's unique ID that we've just generated, and some save data. This save data is this data here. So it's the inventory system, the chest position, and its rotation. So from this chest data, all we need to do then is just this dot inventory primary inventory system is equal to the chest data dot inventory system. Because remember, our inventory holder, it's got a primary inventory system. So that's the first inventory system that all inventory holders will have. So primary inventory system is equal to the inventory system that's stored in our chest save data. We can say this dot transform dot position is equal to the chest data dot position, and this dot transform dot rotation is equal to the chest data dot rotation. The reason we're saving this is because in your game you may want to be able to craft a chest like in Minecraft and place it down in the world. And if you do that, it's going to know where it was, like what its position and rotation should be. So we're just covering ourselves if we want to do that there. Now, we're not going to do that in this tutorial series. It's not going to focus on crafting necessarily. Maybe that'll come down the line. Let me know in the Let me know in the comments below if you do want a crafting system that builds on top of the inventory system. But if we do get that far, then that's already there for us. We can just read from that. We can spawn in the chest at that position, rotation, and assign its inventory system as well if we need to. As a bit of a route, if you want to go down that on your own, you could have like a chest manager that loads in the data, spawns in a load of chests based on this chest dictionary. So for every entry in here, it will instantiate a new chest and it'll set it to that position and rotation and set its inventory system. So in that way, when you load the game first, there won't be any chests in the world, and they will be spawned in dynamically by like a chest manager based on the save data. But again, explore that on your own, or let me know in the comments below if you want me to do a video on that. Okay, so we're getting close to the end of being able to actually see this all working. I'm going to make a start function on this. So private void start. and we're going to make a instance of some chest save data. So chest save data. We'll set this equal to new chest save data, which will pass in our primary inventory system. We will pass in our transform.position as well as our transform.rotation. And then we're going to get in touch with our save game manager, which is another script we need to make. And we're going to hook into the data on the save game manager. And we're going to go to the chest dictionary, and we're going to add our unique ID as well as our save data. Now this is a reference, so we've assigned ourselves to this dictionary. As the chest gets updated, this chest dictionary will stay updated. We don't need to do it every time we request to save the game. Now our chest save data is a reference type, so we only need to assign this once, and it's the same kind of, it's pointing to the same place in memory. So we've assigned it to the chest dictionary, which is going to be on our save game manager. So it will always update no matter what we put in the chest. So let's have our save game manager. Let's create that. So right click, create C# script, save game manager. Now you may want this to just be part of your normal game manager. But basically we need an active piece of save data that everything is passing in its references to. So then when we hit a button to save the game, it can just save this one piece of save data. It's like your save file, essentially. It can save that to disk. And we could, in the save game manager, we could have a tick that saves it periodically. So like an autosave function. But for now, we're just going to have a public static save data, because we only want one piece of data to be working with. We don't want to have lots of different save files everywhere. We just want our one bit of save data. So that can be static, which means we can access it like this. We don't need a reference to the save game manager because we can just get this static variable. Now I'm going to do a private void awake. And also this save game manager class could be static. I want it to live on an object just so I can interact with it a bit more easily in the scene. So I'm going to keep it as a mono behavior, and it'll live kind of like a game manager, just on an object in our scene. So the first thing I'm going to do is in our awake function, I'm going to hook into the save load on load game unity action, just like we did in the chest. And I'm going to make a function called load data. And this will be called data. And in our awake function, I'm also going to set our data equal to a new bit of save data. So all that we need to do is when we load the game, we're just going to replace our data with the save data that we've just loaded. So we can do data is equal to underscore data, and I'll make sure I put the underscore there. So this static instance of data is going to be updated to this bit of data here, and we can make this a public static void load data. This is where we're going to be able to save our data as well. So we can make a public static void save data, and here we're going to make a copy of our data, and then I'm going to call our save load class. I'm going to do save, and we'll pass in our save data. And while we're at it, I'm going to make a public void delete data, and we can call save load dot delete save data. And let's make that method over on our save load file. So we've got a public static void delete save data, and all that's going to do is it's going to get the full path as it is up here, and if that exists, then we're going to delete that save file. So that's just an easy way of deleting our save just for testing purposes, or you might want to give the player that option to surface that option to the player. Okay, so let's actually implement this so we can test to make sure it's all working. Okay, so let's actually implement some buttons so we can actually save and load our inventory system. And the way I'm going to do that is I'm going to get our canvas here. I'm just going to right click, create an empty, and call this save load buttons. And I'm just going to add our save game manager to this object. You may want it somewhere different in your scene, but just to make it easier, I'm going to put it here, and I'm just going to put in, let's use Text Mesh Pro buttons, and we'll do save. We'll duplicate that and call this one load, and duplicate that and call it delete. So let's go to our UI and actually like sort these buttons out. So we're going to parent them all to the top left of the screen. So we've got our save button, which can go in the top left. We'll bring our load button down, and then below that we'll bring our delete button. And I'm just going to make these bigger just so we can see them a bit better. I'll do the same with the text. I'll just check auto size just to bring them up, and then we can name this button save, load, delete. So our save button, we can do on click, and I'm going to drag in our save game manager, and this is going to be save data. We've got our load button here. Oh, again, on click, save game manager. We need to be able to load the game. Why can't we load the data? Oh yeah, we need a function to actually try to load the data. So let's do public static void try load data, and this is going to call load on our save load system, which if it's successful, it'll fire off this event, and then this will actually do this method here. So let's go back to the game. So under our save game manager, we can now choose try load data. And then for delete, we can do on click, save button, save game manager, delete data. So for ease of trying to navigate to our save game like file on disk, I'm going to go over to our save load function, and in our save game, when I hit save game, I'm going to copy the directory to the clipboard. So I'm going to do GUI utility.system copy buffer, and I'm going to set this equal to our directory. So that means that when I hit save, it's just going to copy the persistent directory path to our clipboard so we can quickly get that in Explorer. So let's save our scene, hit play. So we've got a null reference. So what's that? That's because this chest, the big chest, doesn't have a unique ID component on it. So what we'd actually want to do for our chest inventory is put in a require component of type unique ID. Type of unique ID. So when we call get component, that's not going to throw that error. We may also want to cache our unique ID instead of calling get component, but I'll just leave it like that for now. Let's just make sure it's working first. So let's hit play. So let's go over some objects, come over here, press E, pick up our tomatoes, put them in that chest. We'll go get some potatoes, pick them up, put them in this chest. Let's close out of that, hit save. So we can stop playing. Let's come over to Explorer. I'm just going to paste in the directory. So tutorial, we've got our savegame.sav. We can open this up in any text editor. I'm just going to use Notepad. And we can see here that our chest dictionary, it had two chests. It had BFE 041A and OCC EC68A. 8E, and you can see that that corresponds with our chests here. So BFEA 041A, OCC EC68E. So that's our save game working. It's got our chest dictionary, it's saved our keys, it's got the value, so it's got item data, instance ID 2432, so that's referring to our tomatoes, and a stack size of 4. So that's all working. If we go back over to our chests and press E, you'll see that there's nothing in them. So we'll close that, we'll hit load, go back to our chest, and there's our 4 tomatoes. Now obviously there's a bit of a problem here that we loaded the game after we'd already picked up these tomatoes off the ground. So to solve that issue, what we can do is in our save data, we can make a list of items, and this is all of the items that we've picked up in the game. So we can do a public list of string type, and we'll call this collected items. And we can do here, collected items is equal to a new list of type string. We're going to need the unique ID on our items as well. So we can do require component, get type of unique ID. Sorry, that's not on our save data. That needs to go on our item pickup script. So require component type of sphere collider, require component type of unique ID. And just like the chest inventory, we're going to want to make a some item pickup save data. So system.serializable, and this is going to be a public struct of type item pick up save data. So again, this is there for if we want to implement, we've dropped an item on the ground and we want to save that position and rotation. We can do that by spawning in new items. We won't use that again in this script, but I'm doing it for you so it's there if you do want to use it. So let's do public inventory item data, and this is going to be our item data. We'll do public vector 3, and this is going to be our position. Public quaternion, our rotation. And we'll do a public item pickup save data constructor, which is going to take in some inventory item data called data vector 3 position quaternion rotation. And we'll do item data is equal to data position is equal to position, rotation equal to rotation. Okay, so we've got our save data there. And again, just like on the chest, on the save data for the chest, we need to hook into our save load onload game. So in our onAwake function, just above the colliders, I'm going to do save load dot onload game, and we're going to do load game. So here I'm going to do a private string ID, and we will cache our ID here because it is good practice. And I'm also going to do a serialized field private item pickup save data, just called item save data. So we can say our ID is equal to get component unique ID dot ID, and we can do item save data is equal to some new save data, which is going to take in our inventory item data. So item data, our position just like the chest, and our rotation just like the chest. And just like we had a start function here for our chest inventory that adds itself to the save game manager's data, we can do the same thing here. So we'll do void start, and we can do save data, save game manager dot data dot, and then we're going to make a list of our active items, which takes in our ID and our item save data. Go back to the save game manager. So we'll go back to our save data, and I'm going to make a public serializable dictionary of type string and item pickup save data called active items, and we'll do active items is equal to this. So when we make some save data, that dictionary is valid and active. In our load game function, we just want to see if this item has already been picked up, and we'll know that if it's contained within our collected items list. When we pick up an object, it's going to add itself to this collected items list, and then when we save our game, we'll keep track of the items that we've collected. So here we just want to say if data from our load game dot collected items dot contains our ID, then we just want to destroy this dot game object. And in our onDestroy method, so if we do get destroyed by getting picked up, we just want to remove ourselves from our active list. So save game manager dot data dot active items dot contains key ID, save game manager dot data dot active items dot remove our ID. So when we're picked up, we're going to be destroyed, and we're going to take ourselves out of the active list, and then we want to unsubscribe from the save load dot on load game action. We don't need to care about that anymore, so we can just unsubscribe from that there. And in our on trigger enter, before we are destroyed, we can do save game manager dot data dot collected items dot add ID. So we can, when we get picked up, this is where we will add ourselves to the save game manager. So let's just see that in action. So let's go back, hit play, creating missing unique ID. Let's just check that so that's on there now. So all of our items have a unique ID. So let's hit play. So we're going to go over, we're going to pick up these items and place them, these 4 tomatoes, in the chest. And we're going to walk away, hit save, come out of that, go back in. Now here we're going to manually load. In your game, when you start the game, when a player starts the game, you'll probably want to load then. So like when the application first starts, you'd call the load function, or you'd be in a main menu and you'd choose a load game. You wouldn't just spawn into the world and then load. But here we're going to have to manually press the load button. And you can see that those items have been deleted because they've got picked up. And we'd previously put them in the chest, so they're here in the chest. And we can take them back out, put them back in. So that's the basics of the save loading done. Player's hotbar doesn't currently save. So if I hit save, come back out, hit play, hit load, it's not working on our player's inventory bar. That'll come in the next video. If you want to see that, make sure you hit the subscribe button, hit the like button if you liked this video. As always, the project files for this video, plus early access to these videos, are on my Patreon, which is patreon.com/danposs. If you'd like anything kind of explaining in a bit more detail, I felt like I went quite quick because it was a lot to cover and I wanted to get this video out and to people because it's been a while since the last video. If you need anything explaining, let me know in the comments or head over to the Discord server, which is linked in the description. I'll be more than happy to help you and kind of debug your code with you. Thanks for watching, and I'll see you in the next one. Bye! Hello and welcome to part 9 of the inventory tutorial series. In this video, we're going to be working on saving the player inventory. So you can see here, if I hit load, the player hotbar now fills back up with their inventory. The backpack has the inventory in it as well. And if we go over to the chests, we can see that the chests have their inventory stored as well, which is what we did in the last video. So let's just get straight into doing this. Okay, so where we left it off last time is that we could walk around and pick up some tomatoes and potatoes, and then we could go over to our chests and we could access the inventory and we could put our tomatoes in it. Well, they were potatoes, but you know what I mean, and our tomatoes. We can hit save, come out, go back in and play. And then if we load, the items that we'd picked up get deleted. And then the potatoes and tomatoes are still there. But what we had left in our player inventory wasn't getting saved. And that's what we're going to work on in this video. Okay, so let's open up our chest inventory. And you can see in our chest inventory, we have this public struct, the serializable struct that we were using to save out in our save data. And we'd save the inventory system as well as a position and a rotation. And you can see that this derives from inventory holder. But so does our player inventory. This inherits from inventory holder as well. And we need to save the same thing. We need to save this inventory system. So what I'm actually going to do is I'm going to take this script, and instead of calling it a chest save data, I'm going to just rename it to inventory save data, and I'm going to put it onto the inventory holder parent script. So I'm just going to rename our struct here, inventory save data. And I'm going to cut this from our chest inventory, and I'm going to place it onto our inventory holder script. So underneath the public class here, let's just pop that there. So the good thing about this now, the inventory save data, is, for example, you may have other types of inventory holder. You may have a mailbox that just takes in mail. You may have like a cauldron, which is technically an inventory holder, but it could only hold like potions or something. And if each of these things are placeable and craftable in the world, then we can just use this public struct inventory save data. And we can even use this for our player's inventory as well. But with the player's inventory, we don't need to care about the position and rotation necessarily, because that piece of save data would be included in a different saving and loading for like the player stat. You'll have a separate player save system which will have the player's position and rotation, like their location in the world, saved into that. And realistically, you'd have their inventory system probably saved into that struct. So you'd have a public struct player save data, and it'd have their inventory system, position, rotation, any stats that they've got on them, other stuff about like who they've spoken to, where they've been, etc. But just for the sake of this tutorial, I'm just going to keep it all simple, and we're going to have this one struct, which is what we save inventories with. So what I'm going to do is I'm going to create another constructor that doesn't care about position and rotation. So we can go and start a public inventory save data. So this is a new constructor, and it's going to take in the inventory system, which we will call inv system. And here we can say that inv system is equal to underscore inv system. Position can just be set to vector 3.0, and rotation can equal quaternion.identity. So then over on our player inventory file, so we need to do what we did on the chest inventory. So we need to subscribe to the onload game function in our awake method, and we should probably unsubscribe from it in on destroy as well. Then over on our inventory holder, I'm going to implement a method called load inventory, which can take in a save data. But I'm actually going to make this abstract. So private abstract void load inventory. And we've got an error here, meaning that the class isn't flagged as abstract. So we need to do a public abstract class, which we've called inventory holder. And we can make this protected. So it's a protected abstract void load inventory, taking in some save data. On our chest inventory, we just need to do protected override void. And the reason that we're doing this instead of having it just be a virtual void is that on our chest we care about the position and rotation. On our inventory holder we don't. So what I can do now is I can copy this function from our chest inventory. We can go over to our player inventory holder. So here we're going to paste in our load inventory. What we're going to do here is instead of looking into a chest dictionary, we're going to say data dot our player inventory dot inv system is not equal to null. Then we're just going to set our primary inventory system to the data dot player inventory dot inv system. So this player inventory is going to sit on our save data script. So if we go over to save data.cs, you can see this is where we've got our string and our serializable dictionary for our chest dictionary. What we can actually do here is do a public inventory save data, and we'll call this player inventory. And then in our constructor, we'll have to say player inventory is equal to a new inventory save data. Okay, so let's go back over to our player inventory. And actually, it's not called inv system, is it? It's inv system with a lowercase I. That's my mistake. So we've called it inv system. Really, because they're public, they should be capital I's. We're sticking to proper naming conventions. Okay, so another thing that we're going to do is we are going to change how the player inventory holder actually works. So you can see here we've got a secondary inventory system, and this is essentially our hotbar. So it's the 10 slots that sit on the bottom of the screen, but that's just a bit clunky because we'd have to keep track of the player's hotbar and their backpack separately. So that's just creating two lots of data when there's not really a need to do that. So what we're actually going to do is we're going to get rid of the secondary inventory system just altogether, so we can get rid of all of this. I know it's daunting deleting lots of code. So with that done, we can get rid of our awake function, and instead of this Unity action here, we're going to say get rid of the parameter, and we're just going to call on player inventory changed. So when we load our save game, we're going to call this action. So all we need to do there is on player inventory changed. We can call this after we load in our inventory. And instead of this here, so if keyboard.current B key was pressed this frame, we're going to just swap this over to the on dynamic inventory display requested action, which sits on the inventory holder script. And this is going to take in a inventory system, which is just going to be our primary inventory system. And we're going to pass in an offset. So the offset for the player inventory is going to be 10. So basically, when we call the on dynamic inventory display requested panel, we're not going to show the first 10 items in the inventory because they're going to be the ones that are on our hotbar. And you can see that we're getting an error here, which means we need to change some things. So back on our inventory holder script, where we've got this on dynamic inventory display requested, we can also take in an int, which is the offset. So inv system to display amount to offset display by. And because we don't have this secondary inventory system anymore, we can get rid of this else if, and we can just have this add to inventory. And over on our inventory system, when we're calling the on dynamic inventory display requested, we don't want an offset, so we can just pass in 0. So now let's jump over to our UI script. You can see that the UI controller is having a bit of an issue because this backpack action isn't a thing anymore. And display inventory, we can get rid of this method. And inventory to display needs to take in an int offset. And we need to pass this offset through to the chest panel refresh dynamic inventory. I'm actually going to just rename this to inventory panel now because it can be a panel for anything. It doesn't have to be just a panel for the chests. So inventory panel. And I'm going to add formerly serialized as so it doesn't lose its reference. So you can see here it says formerly serialized as. Once we've recompiled the editor, we'll be able to remove that. If you want to know more about that, click the link up in the top right corner. I did a video on what this does. So passing through our offset here, we just need to go to this refresh dynamic inventory function method and actually implement the offset mechanic. So here we're taking in an int offset, and again we need to pass this along to its final destination, which is this assigned slot method here. So im to display offset, and that needs to take an int. Our inventory, because this is an override, we need to do the same on the assigned slot abstract method here. So we need to pass that inventory slot in. We need to pass that it offset into that. And now instead of starting at 0, we can start at the offset. So I equals offset. And then whilst the inventory to display is less than the inventory size, we'll do all of the other stuff. So basically we're missing, when we start to assign the slots, if we pass in an inventory size of 50, because our player inventory is a size of 50, 10 of which are for the hotbar, and we're passing in a offset of 10, it's going to skip the first 10 slots of the inventory, which I should be able to show you here. So that should all be working. It doesn't look like it is. There's something wrong with our static inventory. And that's because we need to pass in the offset here, even though we don't use it. Okay, so that should all be happy now. So let's go back over to Unity. That was a lot of changes without testing any of them. So hopefully that will all work. Let's recompile. No errors in the log. Always a good sign. So I'm going to walk over to this tomato. We've got our 2 potatoes, and they're coming into our hotbar. As we go over, you'll see that nothing happens, and that's because we probably forgot to do something. So our player inventory size was set to 10 because we only had the hotbar and we got rid of the secondary inventory system, which is our backpack. So let's put this up to 50. Okay, so that didn't work. We got an error. That's because silly old me forgot to do something on our static inventory display class. You can see that we were looking for the amount of slots and we'd put in 10 inventory slot UIs. So this is an array of the actual UI inventory slots, and we were checking its length and making sure that it was the same as our actual inventory size and logging an error if it wasn't, just as a failsafe. But we need to get rid of that now. And instead of doing int I equals 0, what we need to actually do is check I, say int equals 0, and whilst I is less than slots.length. So there is a potential issue here. And if you decide to have, say 5 inventory slots, you need to make sure you change that in the code on the player inventory holder, where we're passing in this offset. What you may want to do is to have a public, serialized field, private int offset, and we'll default that to 10. And let's, instead of hard coding that there, we'll just put in offset and we can change this in the inspector. If you change the hotbar, so if we look at the player hotbar, you can see that we have 10 inventory slots in the script. So slots 10, that's these here. If you decide to only have 5, you just need to make sure that you change that on your player, the player offset here. And actually, if you wanted, what you could probably do is if we go over to our player inventory holder script, I'm actually going to put this offset onto the inventory holder main class. So we'll do offset equals 10. Let's make this protected so we can access it from our player inventory holder script. And I'm going to do a public int offset, a capital O. And this can be a property that returns the offset field. So now over on our static inventory display, what we can say is instead of slots.length, we can actually check the inventory holder dot offset. Okay, so with those changes done, we just want to go back over to our player inventory holder CS script. And the last thing we need to do is in a start function, so private void start, we just want to add to the save game manager. We want to get the data, the player inventory, and we want to set a new inventory save data, just passing in our inventory system, which is the primary inventory system. Okay, so back in the project, what you want to do is, because we've changed the way the save file is actually set up and we've renamed some stuff, we just want to hit delete. You need to delete your old save file, which is important to get all of this stuff right now in the prototyping phase, because obviously you'd hate for players to have to delete their saves. Some games do have that in early access. You need to have save wipes and they get rid of your saves. So that's just something to keep in mind. That once you start changing the structure of what's actually saved out, you can't then load that back in. Or you can, but you'd have to, code for that and convert stuff. But let's just start walking over these tomatoes here and these potatoes here. So you can see that our hotbar got full. And as we go over the items on the ground, they start to fill up in the backpack. We can go over to the chest and let's put 5 tomatoes in here and some potatoes. Let's split that stack and put 2 in there and 1 in there. And then let's hit save. Let's come out, go back in. Let's load our game. So we'll hit load. So all of the items were collected, so they're now not on there. Over on this chest here, we've got the tomatoes and the potatoes that we put away. In our backpack, we've got them, but you can see our hotbar is missing. If we go over to our player, you can see on our actual inventory, they are there. We have those items, but they've not shown back up. And that's because the hotbar, unlike the dynamic inventory, it wasn't set to refresh when something changed. So when we load our save game, we just need to ask our hotbar to refresh, because obviously the data that's contained within our player inventory has changed. And that's quite simple. If we go back to the static inventory display class and in on enable, we can subscribe to player inventory holder dot on player inventory changed. And let's make a method called refresh static display. And let's just copy and paste that and we'll change this to disable. And we'll change that to on disable. And we'll unsubscribe from that method. So in our refresh static display method, all we're going to do is take this out of the start function. And we can get rid of that. We don't need to call base.start. No. So we're going to take that out of our start function. We'll place it into the refresh static display script. And then we can call refresh static display from our start function. So back in Unity, if we hit play, we should just be able to load the game and everything should now be working. So let's load. You see that all the items were picked up. Our player inventory is all intact. This is everything that we had. We have our chests, which have the tomatoes and the potatoes in them, just as you would expect. So I know code refactoring can sometimes make for a little bit of a hectic video. I hope you all followed along and it was okay. In the next video, we're going to be doing a bit more refactoring, unfortunately, and we're going to be looking at the way references to items within an inventory are stored. So what I mean by that is this is our save data, and you can see that the reference to the actual item data is we store how many of the item we have, but the actual reference to the data is this instance ID. Now you can see that if we build the game, so here we are in the built version of the game, and if I hit load, you can see that the items get deleted, and that's because they have a unique ID. It's not an instance ID. That's an ID that we've created and is unique. But you can see none of our inventories have any items in them. And that's because in a built version of the game, those instance IDs change between the built version and the editor version. And in patches down the line, they may change again. If you upgrade your engine, or sometimes just your project will reserialize and those instance IDs can change, and that means that the loading, whether that's in editor or in an inbuilt version of the game, would actually stop working and you'd break player saves. It's a bit of an oversight on my end. But after this comment from 322SS on the previous chest inventory save-in, they've kind of flagged this as an issue. I did a bit of researching and I've found a way to fix that by creating an item database using scriptable objects. So in the next video, we'll take a look at how to implement that fix. It's very simple, but again, it's just a little bit of refactoring. So that will be what happens in the next video. But in the meantime, I hope you're enjoying the inventory tutorial series. It's been very good fun working on this. If you'd like the project files for this video or any of the other videos in the series, you can head over to the Patreon, which is linked in the description below. That's patreon.com/danposs. If you've struggled with anything in this video or any of the videos so far, you can join the Discord server, which again is linked in the description below. I'd be more than happy to help you there. But for now, thanks for watching, and I'll see you in the next one. Bye! Hello and welcome to episode 9.5 of the inventory tutorial series. I'm actually recording this from way in the future. I've already filmed quite a lot of extra stuff. I think episode 11 is currently out, but I'm just going to slot this in between because I've had a question from Watcher on the Discord, which if you want to join the Discord, there's a link in the description below. And they were asking how when you go over to a chest and you pressed E, it'd bring up the chest, but then if you press B, it'd bring up the same panel. So you couldn't, for your player inventory, so you couldn't put things from your actual inventory into the chest. But by the end of this video, we'll have fixed that. So we can have our inventory panel up here. So this is our player inventory. So you can see we'll walk away from the chest. This is our backpack with our hotbar down here. And if we go over here and press E, we can then bring up our backpack, put some potions in there, split them, put them back in our inventory, split them, put them in our backpack, and walk away, come back over, press E, and we've got our chest and our backpack, and it's all separate. So let's just jump straight into this quick little fix video. Okay, so there's a bit of a glaring issue with the inventory project, which I haven't got around to fixing yet, but it should be quite a simple fix. So you can see here, we've got our backpack. If we press B, it uses the dynamic inventory panel. So we can put stuff in our backpack instead of on our hotbar. But if we go over to this chest and we open up the chest, and then we open up our backpack with the B button, you can see it uses the same panel. So we can't put stuff from our backpack into a chest. We'd have to put it on our hotbar, then use the chest, and then put it into the chest, which obviously is rubbish. We don't want it to do that. So let's just quickly fix that. And it's quite a simple fix. What we're going to do is we're going to drag our canvas. We're going to expand our canvas, go to our inventory UI controller, and we've got our dynamic inventory pack here. Now I'm just going to shut the shop UI controller. So you can see you've got the dynamic inventory display. We've also got this player backpack. I don't know when I made this, so let's just assume you don't have that, and let's start fresh. So I'm just going to open up this prefab and delete the player backpack, and we'll go back to our canvas here. So we've got our dynamic inventory panel. I'm going to Control D and duplicate this, and then just move this over to this side. And let's rename this to Player Inventory Panel. So we've got our dynamic inventory display here. I'm going to go over to our inventory UI controller. So it seems I started to set up this player backpack panel, and at some point, I don't know, maybe I didn't cover it, but that's no biggie. If I do cover it in a later video, just skip past that bit. Okay, so you can see I've already tried to do this here. So we've got a public dynamic inventory display, player backpack panel. and that's on our inventory UI controller. So let's just drag our player inventory panel over to the player backpack panel. And we can also see that in update, we've got a keyboard current key.escape key was press this frame. And if the player backpack panel is open, we'll just close it. And then here, we've got our inventory holder on dynamic inventory display requested. This is what's opening up the chest panel, and it's also opening up the player panel as well. So instead of doing that, let's I'm just going to duplicate this method. So we'll just Control C, Control V, and let's name this to display player inventory. And then on our player inventory holder script, so we've got player inventory holder. We've got here, if keyboard.current B key was pressed this frame on dynamic inventory display requested, and then we're just going to invoke our primary inventory system and pass in the offset. What I'm going to do, see, the version I'm working with here is from episode 11 of the backpack series. If you're jumping ahead to this one from episode 9, I'm not sure, I can't remember exactly when I implemented this offset. It may have been in a later video, but I'm responding to a question on Discord asking how we can do this. And I'm going to slot this kind of in between episode 9 and 11. So this will be like a episode 9.5, as it were. So yeah, you should be able to follow along, but there may just be some code that's not, you may see some code that's not kind of there yet, but it will be by episode 11. So we've got if keyboard.current B key was pressed this frame, and we've got this event here. What I'm actually going to do is I'm going to create a new public static unity action, and just like on our inventory holder, this on dynamic inventory display requested, just to make it easy, I'm just going to copy that. I'm going to go back to our player inventory holder, and let's just paste that in, and then we'll say on player inventory display requested. So now, when the B key is pressed, instead of doing on dynamic inventory display requested, we can say on player inventory display requested. And if it is, let's invoke it and pass in our inventory system along with the offset. Again, depending on when you're watching this video, you may have your backpack inventory system as a separate inventory system. I do rework it to just have one kind of system, but hopefully you can follow along. So we go back to our inventory controller. We just need to listen here, so we can do player inventory holder dot on player inventory display requested, and then we can plus equals the display player inventory, and we'll copy this and place it in our on disable function. So we've got our display player inventory system. We're going to call this. So now we just need to set our player backpack panel to true, and then we want to refresh the dynamic inventory of the player backpack panel, not the inventory panel. So now if we press play and we can press B, that'll bring up our bag. We can press escape and close that, and let's just pick up some stuff. We can press B and we can place this in our bag, and you can notice an issue here that the icons are going behind the bag. I'll solve that in just a second. But now when we go over to a chest and press E, and we can press B and we can bring up our bag and place them into the chest. And press escape and it'll close both panels. So now you've got your bag and the chest inventory are all separate panels. And then to fix the inventory UI controller with the player inventory being behind it, so to do that, let's come to our canvas and let's just apply all of our changes that we've just done. And then let's try and drag the mouse object below player inventory. It'll ask to open up the prefab. And then we just need to make sure this is at the bottom of the UI inventory controller window, because anything that's at the bottom renders on top of the stuff above it, which I've never really liked. I wish stuff at the top would render above. It's a bit more kind of like Photoshop then with different layers. But you can see that if we go over our backpack, if we go over, pick up some items, pick up an item, and now it's rendering on top of our backpack. Put our swords in, and then we can come over here to these chests, and then we can pop some stuff into the chests. And also, as a sneak peek, I've just finished recording all of the shop tutorial stuff, so that is coming up in the future, just as a little sneak peek. I'm actually working from like episode 15 of the inventory tutorial series, which includes these shops. So that's just a little sneak peek. But yeah, I hope that solves your issue. If you've been having that issue, I can't remember if I addressed this in a future video, If I do, just skip past that bit. Thanks for watching. Bye. Hello and welcome to episode 10 of the inventory tutorial series. In this video, we're going to rework how the items are stored in memory and how we save them out. So by the end of the video, not much will have changed in the editor. I'll be able to, go over here and put stuff into the chest just as we always have been able to. And we can hit save. But now, as kind of pointed out at the end of the last video, if I built and run this version of the game, I wouldn't be able to load that save in the built version of the game originally. But by the end of this video, we will be able to do that. So you can see here, we're in the built version of the game, and we can now hit load, and the save files are in sync between the actual built version of the game and the editor version as well. We'll be able to go over here, make some changes, go into this chest, put up this thing here, put some tomatoes in the player's backpack. We can hit save, we can go back into the editor, hit play, and our save files will be in sync. So you can see there's our tomatoes, and each of the chests has what we put in it. We'll be creating a database that controls all of our items and assigns the items an ID as well. So let's just get started with the video. Okay, so let's get started. Let's go over to our item scripts folder, right click, create C# script, and we'll call this database. And let's open up that in our IDE. So this is going to derive from scriptable object. So we'll get rid of start and update, and we'll replace monobehavior with scriptable object. Now we're going to need to be able to right click and create a database in the project. So let's do create asset menu. And we can say menu name is equal to inventory system / item database. Let's just zoom in a bit. So we've got our database object here. So the first thing I'm going to do is serialize field a private list of inventory item data. So these are the other scriptable objects that we have. And I'm just going to call this the item database. Also, since starting this project many months ago, I've upgraded kind of my naming conventions to fit more in with how C# should be coded. So you'll notice that here I've got privates without an underscore. And you can see Ryder is complaining, saying it should have an underscore. So it doesn't really matter, but that's why my naming conventions have changed. So I'm putting underscores under private variables, just so you're aware. So this is going to be a list. This is our database. This is the list of all of the items in our game. And this is kind of like the one sort of point of truth. So when we load in a game, we can look for an ID instead of the instance ID, which, as I said last time, can change between builds and the editor and patches and updates. Like, it's not very safe. This way, we can assign an ID to a item, say like 1, 2, 3, and then our save file can say that we've saved item 3, and item 3 will always be item 3. It won't change in between. It won't change in between sessions, and it'll go between the editor and the build will share the same item database. So we'll be able to load our save games that we've made in the editor in a built version of the game, and we'd be able to load the save file that's in a built version of the game back up in the editor, which would be great for debugging and stuff like that. So with that said, with that little bit more of an explanation out of the way, we're going to make a function to actually set these IDs. So I'm going to do a public void set item IDs. And I'm going to, above that, give it the context menu attribute with the set IDs name. So we can call this in the inspector if we need to. So the first thing I'm going to do when we set some item IDs is I'm going to create a new list of inventory item datas. This will just ensure that the database is never null when we start to try and do stuff with it. And the first thing I want to do is I'm going to make a variable called found items. And I'm going to search the resources folder by calling resources load all. And I'm going to get it to load all of the inventory item data that we have in our project. And this is going to be at the path of item data. And then I'm going to use system.link. So let's come up here. We'll do using system.link. And we're going to order all of our items by their ID. So if, say, apples is an ID of, so if tomatoes is an ID of 1 and potatoes are an ID of 2, it will put them into that order. So it'll put tomatoes first and then potatoes. So we could do order by. And the way the order by function works is quite easy. So we need a letter or a variable name, because this is almost like doing a for each loop. So we're saying for each I, or this can be anything. This could be for each item, but convention is to just have one letter. So ordered by I, so for item, for each item, let's order it by the item.id. And then finally, let's put this into a list called found items. So again, we're loading all of our item data scriptable objects that we've created that are going to be in a folder called item data. And then we're going to sort all of those inventory items. We're going to order them by their ID, and then we're going to put them into a list called found items. And now we need to filter these found items into 3 separate categories. We need to say, has ID in range? That's going to be one of the categories. We're going to has an ID not in range. I'll explain these all in a second. And we want no ID as well. So here we're seeing whether, say we found 10 items, but for some reason, tomatoes had an ID of 5, but then potatoes had an ID of 15. The one that has an ID of 5 would be in range because it's in the range of the amount of items that we found. The ones that had an ID of 15 or anything above how many found items we had, they would have a valid ID, but it wouldn't be in range. And then no ID are going to be all new items that we've never set an ID for before. And we're going to default them. And when we make a new inventory item data, we're going to make it so it always defaults to -1, which is what we can then check for. So let's focus on has ID in range first. So I'm going to set this variable equal to found items. So we're going to check this list and we're going to get all the ones where our item ID is not equal to -1 and the item's ID is less than the found items.count. And then we're going to order that list by their ID, so just the same as above, and then we're going to put them all into a list. Now this seems quite complex in terms of, memory usage. It might not be the most efficient, but this is only going to get called when we build the game. This is never going to happen like in-game where there's a player doing this. So for our purposes, as long as it's functional, I'm more than happy with that going into a built version of the game. So for the not in range, we're going to do the exact same thing, but we're going to change the check on the count. So we can say equals found items where their ID is not equal to -1 and the ID is greater than or equal to the found items.count. And then we'll put that into an ordered list. And then finally, we're going to copy our found items where. And we're going to say where the item ID is less than or equal to -1. And we'll put that into a list as well. So now we're going to loop over all of our lists and organize them into the item database in the correct order. The ones that don't have an ID, we're going to give an ID. And because they're scriptable objects, this ID will then be persistent. That data will stay. We don't need to save it out to a list, like to a JSON list or anything like that. So I'm going to make a temporary index variable, just called index, and we'll set that to 0. And then I'm going to go into a for loop. I'm going to say for int I, and while I is less than the found items.count, so all of the items in our game, I++, and I'm going to make a new inventory item data called item to add, because dependent on some different checks, this is going to decide what item that is that we're checking, and then we'll put this item into the list. So here, we're just checking the ID at I. We're going to check the found items.range, and we're going to see if the item that we're looking at has the same ID as the position that it's come through into the ordered list. So we're going to say item to add is equal to has ID in range dot find, and I'm going to say where the data, and I'm using D here instead of I because we've already got I here. I'm going to say where the data is equal to the data's ID equaling I. Sorry, that's not equal. It needs to be that. So when we've got to this index that we're on, we're going to assign it we're going to assign it an item from this list. This has ID in range list. So we're going to get the ID that matches the current iteration of the loop that we're in. If the item to add is not null at this point, then we are good. We can add that item to the database because it's the correct item in the correct position. So item to add can go into the database. If the item to add is null, so we've not found an item that's within the range that we're looking for, doesn't have a correct ID, then we're going to check, does the index, which is this variable here that we've made, is the index less than the ID, is less than the no ID dot count. So this is a separate index that we're keeping track of over here because we're only going to iterate this when we run this bit of code to make sure that we don't go out of range of this no ID list. So if there's no ID, what we're going to do is we're going to get the item that is at the index that we're looking at, and we're going to set its ID equal to I. And again, I is the current loop index. So essentially we're going to get, the first time around, if we get to here, we're going to go into this list of no IDs and we're going to get item 0 and we're going to set it to the relevant ID of this loop. And then we can say item to add is equal to no ID dot index. We will increase the index. So this is the sort of internal index to this no ID list. So we're going to increase the index and then we can add the item to add to our item database. So item to add goes into the database. And then once this has ran and we've gone completely through this loop, all we're going to do then is we're going to go through all of the items that have an ID but the aren't in range. So we'll say for each item in has ID not in range, we're just going to add them to the end of the list. So item.database.add item. So this will be a case of, say you had 15 swords in your game and you decided that's too many, I'm going to take out 5. But you're only going to take out kind of like the middle 5 and then the last sword, which was originally the 15th sword and had an ID of 15. Players have that, testers have that. You don't want to remove that ID from the database. because it might be referenced in a save file somewhere. Doing this ensures that those IDs don't have to change, they can still be valid. And if you add more items into the future, it's going to fit it into kind of the next available slot in our list. So that's the setID method complete. So now all we need is a method that returns some inventory item data, and we can call this getItem, and we can just pass in an ID. And all this is going to do is return the item database.find, and it's going to find the item that has the ID that we've just passed in. So find the item where the item.id is equal to ID, which is this ID here. Because once we run this set item IDs, because it's a scriptable object, the item database will just stay around until we call set item IDs again. So we don't need to run this at runtime. We can just run this the once when we build the game or while we're testing the game in the editor, and then that's all we need. That's all we need to do. So let's save our database and let's just go back to our project. So now you need to make a folder called resources. So I'm going to create a folder and let's call this resources. And I'm actually going to put this into our item scripts because you can have multiple resources folders. So remember, we were looking in a folder called item data. I'm going to put all of our scriptable objects, so the potato and the tomato, I'm going to put this into our item data folder. And in the root of our resources folder, I'm going to create inventory system item database, and I'll just call this database. So whatever you name this is what you're going to refer to it as in some code later. So make sure you name it appropriately. Call item database. I'm just going to leave it as database. So you can see here that our list of items is empty. We've got our item data here, and their ID is currently set to 0. Let's just set these to -1. And let's actually open up our inventory item data. And I'm going to set this equal to -1. So when we create a new inventory item, it will be automatically set to 1. So let's do inventory item, and I'll call this apple. So you can see ID is set to -1. And we'll just type in apple here. So if we go back to our database, so I'm going to set the potato. So these are all -1. So if we go to our database and we come up to the 3 dots here, you can see that it's got set IDs, and this is what we did with that context menu. If we hit that, you can see that it found all of the items in the item data folder. It found 3 items. It found apple first. So this is ID 0. ID 1 is the potato. ID 2 is the tomato. And that matches element 0, element 1, element 2 from the database list. If, for example, this was set to, this one was 0, we'll put this one back to -1. And I'll put this at 50. So it's going to find all of the items, but it's going to put them into their ID order. So this is ID 0, so it'll go into element 0 in the list. And then it'll find this one has -1, and element 1 doesn't have a matching ID, so it's basically a free. So it's basically an ID that is free to be assigned to another item. So it'll set apple to 1, and it'll leave ID as for the tomato as 50, and it'll just put it at the end of the list. So let's go back to our database, and let's just set the database back to 0. So if I click set IDs, so you can see element 0 is the potato, which had an ID of 0. It set the apple to ID of 1, and tomato has been left at an ID of 50. So if I create another inventory item, and I'll call this pear, we'll do display name pear, and I'll leave the ID for now at -1. So what we need to do now is we need to load our items back into the game based on their ID, not their instance ID. So let's go back over into our IDE, and we're actually going to go over to the inventory slot.cs file. And here we're going to implement the iSerialization callback receiver, which is an interface that allows us to get a callback when the game is being serialized, that we can get a callback. So just before it's serialized and then after it's serialized. And we'll implement the missing members, which are these two scripts here, which are these two methods here: is public void on before serialize, public void on after deserialize. And we don't care about on before serialize. We don't need to use that, but we have to keep it around though. So I'm going to get rid of the throw exception. The method that we're going to use is on after deserialize. But first we need to go back up and we need to assign an inventory ID to our slot. So serialize field, private int, and we'll call this item ID, and we'll default this to -1. So when we save out our inventory system and all of the inventory slots, we're not actually going to be saving out the items contained within the slot anymore. We're just going to be saving out this int, which will correspond to an item in the item database. So this can be private, but it has to be serialized with serialize field. 1, so we can see in the inspector, and 2, so it saves out into our JSON save data. So let's go back to on after deserialize. So here, I'm going to check whether the item ID is equal to -1. If it is, the slot's empty, so we don't need to get the item data. And instead, what we can do is I'm going to make a temporary variable called database. And I'm going to set this equal to resources.load. I'm going to load the database from our resources folder. And it's going to be called database, because it's called database and it's in the root of our resources folder. What you may want to do is load this database into memory on your game manager or on some sort of singleton somewhere, just so you can always access it. You're not having to load it each time the game deserializes. But for the purposes of this is fine. And then all we're going to do is say item data is equal to the database.getItem, and we'll pass in our item ID. So now let's go up to the assign item method here. So this is when we pick up an item and we're assigning an item to the slot. What we want to say is, so the data is equal to the data, and our item ID is equal to the item data's ID, which is the ID that was set to it by the database. In clear slot, we just want to set the item ID back to -1, because the slot will be empty. And when we create a slot in the constructor, we just want to set the item ID to the ID there as well. And we just want to put item ID into the update inventory slot as well. So that should be that. Let's go back over to Unity and just check that that's all working. So let's hit play. Let's pick up some tomatoes and potatoes, go over to the player, and you can see here that we've got the tomato and it's got an item ID of 50, Got the potato, item ID of 0. And then the slots that are empty have an item ID of -1. So I'm going to delete my old save file because again we've done some structural changes to the way stuff is saved. And I'm actually going to hit save here. And let's load up that save data. So here you can see that item data instance ID is still being saved out. We don't need it to. In fact, it's confusing that it is, so let's just mark that as non-serialized. So in our inventory slot, instead of serialized field, we can do non-serialized. But you can see that the rest of it, we've got the item ID and the stack size, so it's loading it in by item ID and not by the item data's instance ID. So this will never change, this could change. So let's just check that again. Let's delete our save. Let's pick up some stuff. Let's put it in a chest over here. And we'll hit save. Let's check that save. So here we've got our chest inventory, and you can see that it's just saving out the item ID and the stack size. It's not got any of the instance ID stuff now. So we've saved that. Let's come back out of the game, go back in. Let's hit load game. So there's our potatoes, everything deleted off the floor. We've got our chest, which is where we put the tomatoes originally. Just going to split that stack, put it over here, put them in there. So I'm going to save the game, and let's just check that it all works in the build version of the game as well. So I'm going to come over to our database and make sure we set the IDs. If you want to see how you can automate this and get the database to set when you hit build, click the little icon in the top of the video now. I covered that a couple of days ago. I covered that in a previous video. Just follow through with that and you should be able to see how I got the database to save when I hit build. It will search for and add all the items to the database that I may have forgot to put in myself. And you can see that if we've hit build and run, we're in the game, we hit load, and now our save files are kind of in sync between the actual player and the editor. And you can see that there's our tomatoes. Got these tomatoes here. Let's put a potato in. Come out of that. Let's just save our game again. Alt F4 to quit. We can press play here. Hit load. And the save files are now in sync, which is great for debugging. So later on as your game progresses and you start to get beta testers, if they say, oh, I've got this weird bug with my game, they can now send you the save files. You'll be able to load it up in the editor and start to debug what exactly is going on. So I hope that was useful for you. I'm glad I caught that bug, and thanks again to the commenter for letting me know about it. For the future of this inventory tutorial series, I'm currently prototyping a shopkeeper system, so you'll be able to sell items at a shop to make some gold. That's currently in the prototyping phase. It depends when this video comes out and how far I've got with that and what else has gone on in life, when that will be. But subscribe if that is something that you'd like to see. If you want the project files for this tutorial or any of the other tutorials on my channel, you can get them over on patreon.com/danposs. There's a link for that in the description below. If you need any help with this tutorial or any of my other tutorials, you can come over to the Discord again, which is linked in the description below. But in the meantime, thanks for watching, and I'll see you in the next one. Bye. Hello and welcome to today's video. In today's video, I'm going to be showing you how we can give our scene a bit of a refresh, just to take away those boring old spheres and put in these nice 3D objects, which is a free asset pack from Itch. See, we've got them rotating to make them just look a bit more visually appealing. We've got a Cinemachine camera that's following our little bean around, and we can come over here and we can pick up the items. And the requested feature, and kind of the main sort of point of this video, is that we can now drop them onto the ground. And we can pick them back up. And all the same stuff, so we can still save our game and load our game. the stuff that we've already picked up will be deleted and it'll go back into our inventory. And very importantly, we are going to fix a bug that I found while recording the video with our unique ID script. There was a bit of a kind of glaring issue with that, which I've since fixed, I hope, fingers crossed. But let's just get straight into the video. Okay, let's just get started. So we're here with our scene, you know, we've got our kind of boring blobs on the ground. If you go to the links in the description, there's a free low poly 3D and pixel 2D pack, which we can use here. Just click download now. And then you can tip them, or you can just say, no thanks, take me to the downloads, and you can get a load of models for free, and you can see some of the models here. So we're going to use a couple of these to kind of jazz up our scene. Once we've got that all set up, we will add drop-in items out of the inventory, putting them back on the ground. So once you've downloaded the Unity asset package, this Unity package, we can just drag and drop that into our assets folder, and it's quite a big package, so it'll take a little bit of time. So you see that it's importing now, and then once it's imported, it will bring up this Unity import package. If I just make this a bit bigger, there's quite a lot of stuff in here. You can import the whole package if you want. It's a bit unnecessary because some of the stuff we're not going to be using, but I'll leave that up to you. So I'm just going to collapse everything. When a list is open like that and it's expanded, if you hold Alt and click the top level, it will collapse everything inside it as well. So I don't need the README and I don't need the reference. Under here, I'm just going to get the ortho images. And then under 3D, we'll bring all of the 3D in. Because there is a series of prefabs and we don't want to have to go through and uncheck the ones that we don't want. We can just delete the ones we don't want back out of our project if that's the case. And you can see that in the images here for the ortho view, there's just little renders of the images of the items inside, and this is what we'll use to display in our inventory. So just go ahead and hit import. And again, depending on how many objects you've picked in that menu, it'll take a while to bring all of these in. Okay, so they're all in now. You can see that we've got this new folder, Assets Devil Workshop, and we've got our 3D folder, and then in prefabs, we can see our prefabs here, and we can drag in the chests, for example, and we can see them here. There's different eggs and stuff, but let's just undo that. So what I'm actually going to do first, I'm going to come down here and I'm going to delete all of our items, and I'll leave just one of them. And I think I've already set this as a prefabs. Yeah, so we've got a tomato here. So I'm just going to open up the prefab in the prefab viewer. And I'm going to delete our sort of boring test sphere. And then let's go to the Devil's Workshop prefab scene. And I'm actually going to drag in one of the potions. I'm going to drag in this health potion here. So let's just drag that under our tomato. And you can see here in the game view that the prefab has updated. So I'm going to go back out into our scene, go back to our prefab here, and I'm going to rename it from tomato to health potion. And I'm going to click on our tomato inventory item data here. And I'm going to rename this to health potion. Let's call it health potion data, just so we know exactly what it is. So now I'm going to change the display name to health potion. Description. This is a health potion. Stack size and gold value, we'll just leave them as it is for now. And then let's go back to our 2D assets, come into the images folder, and then you're going to need to select everything in this folder. So click on the top item, hold down shift and click on the bottom item. And under texture type, swap that from default to sprite 2D and UI. And then we can just hit apply. And again, depending on how many images you've got in this folder, this will take a while, so just let that complete. Okay, so they're all now sprite images. So if we go back over to our item data and select our health potion, we can now open this up and we can find our potion. So we'll just type in potion, and you can see here that we've got a nice icon for our potion. And then I'm just going to rename the actual prefab in the scene to health potion as well. And you'll see that if I hit play now and we walk over the potion, we have our potion and it's gone in with the new icon. Now you can see it's a little bit stretched. It doesn't look perfectly good. So let's fix that. To do that, we need to go into our into a few different scripts. So we can go over to Canvas, Inventory UI Controller, and let's start with the player hotbar. So let's open up our static inventory display script. So we've got our script here. I'm just going to let this open properly in Rider. Okay, so we actually need to go to the inventory slot UI script. That was my mistake. So let's go through to there. So you can see here that we've got our private image item sprite. What we need to do in on awake is we need to go to item sprite.preserve aspect and just set that to true in code. The reason for that, and it's quite annoying, is if we go back into Unity and select one of our inventory slot UIs, you can see when there's not a sprite in there, you can't see the preserve aspect ratio box. So if we go to our image, so there's no preserve aspect ratio box, it's hidden. If we put a sprite in, you can see now it says preserve aspect. But obviously we don't want to have the graphics in because that's all set through code. So we just need to set that to true through code as well. And we need to do that in a couple of other places as well. So we need to do this on the mouse item data as well. So we'll come over to awake and we can say item sprite dot preserve aspect and just set that to true. So now if we go back in and we pick up the item, you can see that the icon's not stretched, and then we can pick it up and put it onto our mouse and it's not stretched there. Let's go over to our chest and we can put it in our chest and it's not stretched there. Okay, so that's all working and looking good. I'm just going to come over to our chest and I'm going to delete these two cubes. Oh, we need to open the prefab because I've made a prefab of them. So let's delete those two cubes. Let's go over to our 3D prefab scene and we've got these cool chests. So for the small chest, I'm going to have these this nice gold chest. And then for the big chest, we've not actually made a prefab of this, but let's delete our cubes from under that. And then I'm going to drag in the silver chest under our big chest item. So you see these are rotated slightly. So I'm just going to rotate this around just so the front latch is at the front. And same again with this, let's just rotate that round. And then we'll have to override, apply our changes to this prefab. And then I'm actually going to make a prefab out of this chest as well. So let's just drag our big chest in here. So now we've got that as a prefab. So to make some other items, it's quite a simple process. So I'll do another one and then I'll go through and do a time lapse of making the others. You can do sort of yours in your own time. So let's just Control D and duplicate our health potion. And then I'm going to right click, prefab, unpack completely. And I'm just going to call this one mana potion. Underneath that, we'll delete the bottle from it. And let's actually just drag this over. So let's go back to these assets. And this time I'm going to get the mana potion. You can see that's there. It's a purple liquid instead of a red liquid. Actually, just for differentiation, I'll drag in the poison bottle. And let's just rename this to poison potion, just so they look a bit visually different. On the item data, let's select one of the other datas that one of these temporary datas. I'll select the apple and then I'll rename our apple to poison potion data. We'll select the poison sprite. So we've got this sprite here. Rename this to poison potion. This is a poison potion. Max stack size can be 1. And we've got a gold value. Let's just put 10. Doesn't really matter. We haven't got any sort of currency sort of set up yet. So we've got our health potion and a poison potion. So I'm going to do 2 more different item types using some of the prefabs in here. So like I said, I'll time lapse that and you can do as many or as few as you want. Okay, so I've got our items here, and I'm just going to make some prefabs of them. So let's go back over to our prefabs folder. And we'll select all of the ones that we haven't made prefabs of, and we'll just drag them. So we'll have to drag them over here one by one. So let's drag in our poison potion, our cogs, and our sword. And our health potion, I moved the sort of visual representation down, so I'll just apply those changes. So now you can see that we can add these back into the scene. We'll have to move them up slightly. So we can drag them out and position them kind of around the scene how we want. We can drag in another sword. So if we hit play now, you can see that they're a little bit boring. They're just sort of stationary. So let's just add a bit of spin kind of movement to them. So we can go over to our item script, item pickup. So this mono behavior lives on the items. And what we can do is in the update function, we can do private void update. And in here, we're just going to rotate the items kind of over time. And we can put a speed in. So we can do serialize field, private float, and then we'll do underscore rotation speed. And what we'll say is we'll do transform dot rotate, and we'll rotate around vector 3 dot up, and then we'll times that by our rotation speed, and then times by time dot delta time. And then let's set our rotation speed to let's see 20. Let's see whether that's too fast or not. So you can see that all of our health potions now have this rotation speed. Let's set it to 20 in the inspector as well and just hit play. Let's see what that looks like. So you see that our items are just slowly rotating on the ground. I've missed these items up here. Let's drag them under our items. And we'll put a rotation speed of 20 in there. Okay, so that's just a little bit more visually interesting. Like while they're on the ground, we can run over and pick them up. They're in our inventory. We've got our potions. Let's split them. Come over here. Let's make sure everything's going to save. So let's put some potions in this chest. We've got this bigger chest here. Let's put our stacked potions in there and one of our swords. Let's save our game. Come back out. Hit play. Load our game. And you can see that all of our items are back in the respective spots. We've got our sword and potions. And our potions there, so that's still good, that's still working. So now let's make it so we can actually drop the items on the ground from our inventory. So if I go over to our mouse item data script, you can see here that we've got this thing in the update function that just says if the mouse.current.left button was pressed this frame and we're not over a UI object, currently we just delete the item by clearing the slot. But we've had this to do here for quite a while, and it's to drop the item on the ground. So let's get rid of the to do and let's actually do it. So let's just make some space up here. And I'm actually going to up here, let's make a private transform variable, and we'll just call this the player transform. And in awake, I'm just going to cache our player. So I'm going to do player transform is equal to game object dot find. That's game object with a capital G. Find object. Game object with tag, and we'll just put in the tag of player, and then we'll do dot get component, and we'll get their transform component, and we'll cache that. Now you may have a reference to your player somewhere else, like on your game manager, so you'd get them from that way. This is just like a quick and dirty way to get the player transform. And I'm just gonna, if player transform is equal to null, then let's debug.log player not found, and that's just in case something happens. We'll see that that's an issue. So let's go back to our project and let's select our player and let's make sure that they have the player tag. We need to make sure they've got that. Okay, so we're back in our mouse item data script and we need to instantiate our item here when we click it, but we need to know what exactly we need to instantiate. So for that, we're going to need to add another variable on our inventory item data. So let's go over here and let's make a public game object, and we'll just call this item prefab. And then we can go back over to our mouse item data here, and we can say instantiate our assigned inventory slots.item data.item prefab. And where we want to instantiate it is we want to do the player.transform, but we need to position it somewhere kind of in front of the player or to the side of the player. If we do it exactly where the player is, we'll just pick the item straight back up, which is a bit of a pain. So we can do player.transform.forward, and then we can just put in a bit of a drop offset. I'm just going to put 1F. We can change that if we need to. And we could make this a variable if we wanted to. So we can control it in the inspector, but 1F should be fine as long as the distance is greater than kind of where the radius of the item pickup is. So we've got, we'll put that just forward and then we'll do quaternion.identity. And then we can clear the slot. And what you may want to do is just check this. So if item prefab is not equal to null, then instantiate it, and then we can clear the slot. Okay, this is my mistake, sorry. We need to drop it at the player transform dot position plus the player transform dot forward times by the drop offset. Because we need to kind of attach it to where the player is and then just add a little bit of distance in front of the player. So that was my mistake. Let's try that again. Pick this up and then we can drop it out of our inventory. Okay, we've picked that straight back up. So now let's put this back to 1. Hopefully that'll be a bit better. Let's pick it up, drop it. Nope, still picking it up. So let's put this to 3. Pick it up, drop it. Okay, there you go. It's in front of the player now. So we can see a couple of issues here. So it's in the floor and it's not rotating. That's because I changed the rotation speeds here, but I didn't apply them to the prefab. So we just need to hit apply all. So let's just hit OK to that message. Okay, so that should sort that. If we look now, all of our items have a rotation speed of 20. And we can see that the problem was that the item was spawning kind of on the ground and the actual pivot is here. So there are a couple of ways to solve this. And the easiest would probably be to open up all of our items and let's select the actual game objects within them. And let's just move them back up. If we look kind of where the radius of the pivot is, so now this pivot is actually going to be where the potion spawns on the ground. So let's just move them up slightly, a little bit more. Okay, so we've moved them up. Now let's get our poison, get the top level prefab objects. And we've got our sphere collider here, which we're setting its radius. We can just move this up off the ground as well by raising the Y axis. So now the actual collider is around the game object, but the pivot is slightly below. So if we go back to these top level items of our prefab, so we've got the potion, the cogs, and the sword. I don't think the cogs moved up annoyingly, so let's just move them up properly. Let's move them up a bit more to kind of like there. So let's apply those changes to our prefabs and we'll see that the other items should sort themselves out as well. So we'll hit apply and there you go. All of our prefabs have updated. And now we can select all of the items in the world and we can actually reset their axis on the Y. Okay, so they're all on the ground now, but they're floating. So let's go back in and we'll pick them up. And then we can pick them up and drop them out of our inventory. And I made the changes to the mouse object in play mode, so just make sure you set that not in play mode. Come back over, pick them all up, and then hopefully finally we'll be able to pick it up and drop it kind of in front of us, and it spins and we can pick it back up. So currently, if we pick up our 3 potions and drop them on the ground, just 1 potion will be dropped, not all 3. So let's sort that out. So instead of clearing the slot, what we can actually do is we can say if assigned... Oh wait, is the game still running? No, okay. Let's get rid of that. So if assigned inventory slot dot item data dot stack... Oh, not data. Assigned inventory slot dot stack size is greater than 1, then we want to do something. Else we can clear the slot because it'll be the last item. So instead of clearing the slot, if there's more than 1 item on the item prefab, what we actually want to do is we want to take our assigned inventory slot and we can add to stack, and we're actually going to add -1, so that'll take 1 away. And then we can call our update mouse slot function. And I'm actually going to make a version of this method that doesn't take anything in. So let's get rid of this. And then get rid of that. And here, I'm going to call update mouse slot. And here, we don't need to assign the inventory slot because we're going to do it here. So let's get rid of that. And then instead of taking from our items, this inventory slot that we passed in, because we've already assigned it, we can just pop it in here. And we can make that private because we're not, oh no, we may call that from somewhere else in the future, who knows. So we'll just leave that public, and then we've got our update function here, so it's going to take 1 away from the stack, and then it'll update the actual UI to show that. And we'll spawn it on the ground. So let's pick this up. So we've got 3 health potions, we can pick it up and we can drop 1. So we've got 2 left on our mouse, we can do it again. Okay, you'll notice a bit of an issue here with our unique ID script, which I didn't actually catch earlier, so that's good. We can debug this. So we've got our unique ID script, and what it seems to be doing is it's spawning it with the ID from the prefab, because that's what we have assigned it to in the prefab. So we need to update our unique ID script. Okay, so that was a bit of a pain. I've had to do some jiggery-pokery of the unique ID script. I think it's working. I've tested, starting the editor, closing the editor, starting it up again, changing scenes, building and running the game, making a save in the built version of the game, loading it back up in the editor, making a save in the editor, loading the built version of the game, and it seems to be working. It's quite robust. If you do have any problems or you know any better way of doing this, do let me know in the comments. I'd love to make sure this is kind of like production ready and we could actually use this properly. But for now, I'll just go over some of the changes that I've made. So you can see that I've got rid of the onValidate function, and I've actually generated, and I've changed it to the awake function. The private string, I've got rid of the generating GUID there. The reason for that is that it doesn't need to be called because we're checking and generating a key here anyway, if it needs to be. And the reason we don't need onValidate and we can actually use awake is because of the execute in edit mode tag on the script, this attribute here. So this is going to work in the same sort of way as onValidate would. When we generate a new item, like duplicate an item or drag it out of the inspector, it will do the right checks and it will generate it. Something else that's worth noting is I'm initializing it here, but there was some instances where it wouldn't actually be initialized. The database would be void for some reason. So I'm just checking if in await, just doing a null check to see whether the database has actually been initialized. If it hasn't, we'll just create a new database. So that's just this bit of code here, but we're putting it here instead. And then this is the same as what was on in the onValidate function. So if the database contains the ID already, then let's generate a new ID. And if it doesn't contain it, let's add it to it. And then in onDestroy, we're just saying that if the database contains the key, let's just remove our ID. And then generate, I've not changed that, that's the same. And the only other thing I've changed for this script then is over on item pickup, I've moved the ID get component unique ID into start instead of on awake. The reason for this is that we are generating the ID in the unique ID awake. So if this script gets called after this awake function, then the ID wouldn't be ready, it wouldn't have been generated. Then if we try to add it, it wouldn't work, it wouldn't have generated, and it wouldn't have, there was no guarantee that it would have been unique, because it may have been the same sort of ID before we actually generated a new one. So we can go back over to Uni and we can see this kind of working. So if I hit play, everything's going to be working the same. So if I pick up all of these, so I've got 3 cogs, 2 potions, 2 swords. I can drop my potions, and you can see over in the console, there's no sort of errors. This was just a test over in the unique ID script. Just debug.logging the actual count of the database when we generate it. I was just making sure that was working. But you can see we've got 2 potions here, and we can pick them back up. And we get our 2 potions, and we can drop them again, and there's no sort of errors there. And we can do the same with the cogs. We can pick up the cogs, and we can drop some cogs, and we can, every time it generates a new ID, you can see that we're getting the count of the database. When we pick it up, so there's 8 and 9, if we pick up the items and then drop them again, you can see that, you know, it's obviously reducing them as we're picking, it's obviously reducing the database count as we pick up items, and then generating new ones when we spawn them back in if it needs to. The first one that we drop will have the same unique ID as the prefab, but that's fine. You know, as long as it's unique, that's okay. So we can pick up all of our items, we can hit save, come out of the game, go back into the game, and then when we hit load, because we've already picked up these items, they will delete themselves. And then we can come over here and we can put some stuff in the chests. Let's split this cog stack, hit save, come back out. And then if we run the game, so we'll build and run, and we can hit load, they'll delete because we've had them. We've got our hotbar, we have our cogs, let's add them. We have our potions, let's take one of them, split the stack, keep that there. And there you have it. So that should all be working. Like I said, if you've got any issues with this unique ID script, do let me know. I'll carry on doing some experiments with it as well and see if I can break it. And if I do, I'll fix it. Okay, so the last little change I want to make is I want to come up here and I want to add a Cinemachine camera. So let's go to Window, Package Manager. And let's go to the Unity registry and look for Cinemachine, and let's just install this package. So with Cinemachine installed, let's just come up to Cinemachine, we'll create a virtual camera, and that'll put it at the kind of spot that our camera was at. So I'm just going to reset everything to 0. And then in our camera, I'm going to drag our player into the follow, and I'll drag our player into the look at as well. And then we can move our camera up slightly and kind of position it into sort of the perspective that we want for our player. And then under binding mode, I'm just going to do a simple, I'm going to swap that to world space, and then I'm going to select do nothing on the aim. So you see that if we hit play, now as we walk along, the camera will follow our player around the scene, so we can make it a little bit more dynamic as we're walking around and we're accessing this stuff. But yeah, there we have it. Ended up being a bit more long-winded than I was hoping because of that bug, but you know, it's good that we caught it and we can kind of correct that. So as I said, the project files for this video are over on my Patreon, which is patreon.com/dampos. I'd just like to take a minute to thank my supporters. In the 10,000 XP tier, we have Omega Mike. And on screen now are all the amazing 4,000 XP tier patrons. If you've been enjoying the series so far, it'd be great if you could hit the like button. It really helps the channel out. And if you've got this far through without subscribing, it'd be great if you could hit the subscribe button as well. In the meantime, thanks for watching, and I'll see you in the next one. Bye! Hello and welcome to episode 12 of the inventory tutorial series, and episode 1 of the shop system. In our shop system, there's not much really visibly to show kind of in-game. You can see we've got these 3 capsules here. These are going to be our shop NPCs. So we can see here we've got shop NPC. And it's got a shop system, and it's got 3 items, and it's holding different amounts of those items. We've got our shop NPC here. This is the weapon shop. It's got 10 swords available. Got the shopkeeper here. This is the potion shop, and it's got 50 of the health and poison potions, which you can see in the world. So there's a poison and health potions. And this is all defined by these scriptable objects here. So if we go to our potion shop, we can see that I've said that we've got 50 poison potions and 50 health potions, as well as the shop having kind of available gold that can be used to buy items from the player. Each one of these has different values, and that's driving these shops with the shop NPCs. That's what we're going to get to by the end of this video. So let's just jump straight into it. Okay, so let's just get started. So to start with, I'm going to right click, create a folder. We can call this shop system, and let's enter this folder. And I'm going to right click, create just a few scripts. So I'm going to create a shop item list, and this is going to be a scriptable object script. This will allow us to define which items a shop is selling and how many of them they've got, as well as how much gold that shop has access to for buying items from the player, and a way of influencing the price of items to either make them a little bit more expensive or buy them for less money than they're worth. But you'll see that as we kind of go along, that's how we can do that. So let's just open this script up. Okay, so we've got our script here. So instead of model behavior, let's derive this from scriptable object. And then let's make a create asset menu. And we can do menu name is equal to, we'll do shop system / shop item list. So as I said, this is going to be everything that the shop has in stock. Okay, so the first thing we're going to do is we're going to have a serialized field private list of shop inventory item, which is a new class that we're going to make. And I'm just going to call this underscore items. We'll have a serialized field private int max allowed gold. Sorry, again, have that like that. I'm going to do a serialized field private float, and this is our cell markup. And we'll have a serialized field private float by. So let's create this shop inventory item now. And what this is going to be is it's just going to be a struct. So we can come out of our class here, and we'll just do a public struct shop inventory item. And this is just going to have a public inventory item data called item data, as well as a public int amount. I need to make sure my item convention names are all. We've got our shop inventory item here, and we need to mark this as serializable. So we're going to do system.serializable. Okay, so now we need to make a shop keeper, which is going to be the NPC in the world that holds our shop inventory, and it's going to be kind of like the inventory holder script we've got. So let's go back over to our project, and we can right click, create, and we'll create another C# script, and we'll call this shopkeeper. And again, we can go and open this up. So shop system, shopkeeper. So our shopkeeper is going to be kind of like chest or other items in the world that we want to save, because we're going to be influencing their inventory. We want to be able to save them out. And because there's going to be multiple of them, we need to use our unique ID component. So we'll just say require component type of unique ID. And then it's going to be a mono behavior, and it's going to inherit from interactable as well, because we're going to need to interact with the NPC. So we can implement the missing members from our interactable interface. So we'll implement these soon. We're not going to use them straight away. Let's just get rid of these for now as well. What I'm going to do is I'm going to create a serialized field, and this will be a private shop item list, and we'll call this shop items held. So this is going to control again, which kind of items the shop is selling, and this will be here. And then we need to create a shop system, which lives on our shopkeeper to kind of hold and manage the shop interface. And now this is kind of like we've got the inventory holder, which has an inventory system. Now we've got a shopkeeper, which is going to have a shop system. So again, go back to Unity, right click, create C# script, C# script, and we'll have a shop system script. And then on our shopkeeper, we can have a private field. We can have a private shop system for this shop system. Now let's jump into our shop system script. So it's going to have some similar functionality to our inventory system script, but it's not going to derive from that. We're going to kind of copy some of the code over where we need to, but it does so much different that it's not sort of, I don't really see the point of making kind of like a parent class to inherit from. So the first thing I want to do in our shop system is let's make a constructor. So I'm going to say public shop system, and this can take in an int for the size of the system, an int for the amount of gold that the system will have, a float for our buy markup, and a float for the sell markup. And then up here, we need to just make a private int. We can say available gold, and we can set available gold to gold from our constructor. We'll need a private float buy markup, as well as a private float sell markup. And again, let's do buy markup is equal to buy markup, and sell markup is equal to sell markup. And then I'm going to make a public, and then I'm going to make a private void set shop size method, and this will take in the int size. And what this will do is we'll set all this up, and then we'll set the shop size, and we'll pass in our size. And the kind of main thing that this is going to do is it's going to create a list of shop slots, which is another class we'll have to make. So let's do a private list of shop slot, and we'll call this our shop inventory. And before we make this method, let's make this class. So we're going to go back to our project, and now we're going to right click, create C# script, and we'll call this one shop slot. Now we're going to have to do a bit of refactoring to get this to work. So let's get rid of start an update, and I'm going to open up our inventory slot script here, which is one that we made way back when. I'm just going to open these up side by side. So I'm actually going to put a lot of this functionality into something called an item slot, and then the inventory slot will inherit from item slot. So again, we'll go back over here, we'll right click, create, and I'm actually going to put this in our item scripts folder. So I'm going to right click, create C# script, and we'll call this one item slot. So we've got item slot here, and actually need to, let's have these open side by side. If you can split them, I would do. It makes this a lot easier. So for item slot, that's going to implement iSerialization callback receiver, so we can implement those missing members. And then inventory slot is going to inherit from item slot, and item slot is going to be an abstract class. We've got public abstract class item slot, and that's where our inventory slot is going to inherit from. And then we can actually copy all of this to our item slot class. So let's get this. We're going to Control X to copy it, and we're going to paste it, cut it, and we're going to paste it over here. You see that we need to import missing members there. And instead of being private, these now need to be protected. So the this class can access them, but no other class can. So protected. I'm going to start moving some of these methods over. So public void clear slot. I'm going to take clear slot, and I'm going to put that onto the item slot class. Assign item. I'm going to take that, and we'll cut it, and we'll pop it over on the item slot function, the item slot class. You can see that add to stack is now red, so we need to take add to stack and remove from stack. Let's cut them, and then we'll pop them onto our item slot class. And now in inventory slot, we don't need this on after deserialize, so we can take this, we'll cut this into this method here, and we'll get rid of this exception, and we can get rid of these, So now in our inventory slot, we've still got access to all of these methods because again, we're inheriting from item slot now. And we've just left, so on inventory slot, we've now got our enough room left in stack methods, our split stack method, a constructor to make an inventory slot that just sets it up as a clear slot, and this other constructor here. So the reason that we haven't copied these over to item slot is that we don't need to check on a shop slot if there's enough room in the stack. So what I've done here is I've taken the stacking ability functionality out of the shop slot, because shops don't need to stack. It's going to just show a list of an item and how many it's got. It doesn't care about stacks because that'd look really weird in the UI to have multiple entries for the same item just showing different stacks. So an inventory slot can stack, a shop slot can't. But a shop slot needs to be able to kind of add items to it, remove items from it, access its save data, be able to assign an item to it. So that is shared functionality. So that's why we've put this into our abstract item slot class. So now if we go back to shop slot, this can inherit from item slot. And then all this is going to do is when we make a new shop slot, is it's just going to create a clear slot. So now in our shop system, we've got our list of shop slots. And I can close our inventory slot functionality. And first, let's just make sure that we've not broken anything crazy with our normal inventory system. So we can go over to play and we can pick up our items and they're all still stacking nicely. And we can go over to our inventory and we can put the items in the inventory. So that's working fine. So we've not broken anything there, which is always a plus. So now on our shop system, back in our private void set shop size function, we're just going to set our shop inventory equal to a new list shop slots with the size that we define. And then we're going to say for int I equals 0. And whilst I is less than the size, we're going to get our shop inventory and we're going to add a new shop slot to our shop size. So we've created a new shop inventory and we've filled it with our slots. So now if we go back over to our shopkeeper in the awake function, we can say shop system is equal to a new shop system. And this is going to take in, so the size is going to be the amount of items that it held. So shop system, so shop items held dot items dot count, and we need to go to our shop item list and be able to get access to our items. We're going to need to make sort of public getters for all of these. So we can say public list of shop inventory item called items. This just returns items. Public int max allowed gold. This can return max allowed gold. Okay, so I've done that there. We've put getters in for our fields here. So we go back to shopkeeper. So we're going to pass in the items count, the items held max allowed gold, the items held buy markup, and the shop items held sell markup. I'm just going to drop this down to a new line so it all fits on one screen. So we've got our shop system here. Shop system, we need to get rid of mono behavior as well. So we're going to add the items from our list to our shop system. So we can say for each variable item in the shop items held dot items, let's add it to our shop system. So shop system dot add to shop, which is a method that we're going to need to make. And we're going to pass in the item item data as well as the item dot amount. Pop over to our shop system and let's make that method. So public void add to, which is going to take in an inventory item data called data and an int amount. So this is going to be quite similar to our inventory system. So let's go our inventory system script open. I'm going to put this next to it in this window here. So we've got our add to inventory here. We're going to need to do some similar stuff, but not the exact same. So that's why I'm not deriving this from like an item system. We can just copy it over for the most part. So the main thing is this contains item. Let's just copy this over and then we'll have to change some of the code. So copy that, paste it over. So we've got contained item. Zoom out just a tiny bit. So instead of passing out a list of inventory slots, this is just going to pass out a shop slot, and it's going to pass out. And here we're going to say shop slot is equal to shop inventory is equal to shop inventory dot find, which is a function. So we'll do shop inventory dot find. We can say I for item. So if the item data equal to the item to add, which we've passed in here, and we're just going to find the first one, and then we can return whether return shop slot is not equal to null. So if we've found the item already in the shop, then we're going to get the shop slot that that item is in, and then shop slot won't be null, so it'll return that it's not equal to null. It'll be true, so it'll say, yep, we contain the item. And if it returns false, and if it is null because it hasn't found the item, it'll return false. So in our add to shop, we can say that if contains item, we can pass in the data and get back out the shop slot. Let's put shop slot. Then we're just going to add the amount to the stack. And again, we don't care about like enough room left in the stack on a shop slot. It's just it can hold an infinite amount of items. So we'll say add to stack. If the shop doesn't already contain the item, we need to get a free slot, and that's just going to make a new slot. So we can say bar free slot is equal to get free slot, and then this can be a private function which returns a shop slot. So private shop slot get free slot, and all this is going to do is going to make a free slot, and it's just going to find the shop inventory of first or default, and it's going to find the first slot where the slot's data is equal to null. And if for some reason our free slot is equal to null, so if it hasn't found a empty slot, then our shop can have as many slots as it needs. So all we're going to do then, just as a bit of a fail safe, we can do free slot is equal to a new shop slot. We'll add that slot to the inventory. So we can add the free slot, and then we're just going to return our free slot. So this will never be null. We're always going to get a slot. Ideally, it'll be the one from our inventory, but just as a fail safe, as I said, we can create a new one and add this to the inventory. We can always get the free slot up here, and then we can assign free slot dot assign item, and we'll pass in our data and amount. And this is complaining because we need to put from our inventory slot. Oh yeah, so on our item slot, we need to make another function that assigns an item by taking in some data and amount. So public void assign item, and this will take in inventory item data called data, and it'll take in an int for the amount. And if the slot already contains data, so if item data is equal to data, let's just add to the stack the amount. Else item data is equal to data, item ID is equal to the data.id, stack size is equal to 0, just to default it out, and then we can just add to stack the amount. So back over on our shop system, so we're going to add it to the shop. If it contains the item, we'll just add to the stack. And if it doesn't, then we're going to make a new slot and assign the data to it. So back on our shop system, back on our shopkeeper, we can now see this method here. And that's all working. So when the shopkeeper, when the game starts, we're going to make a new shop system. And then we're going to add an item to the stock of that shop. So we're going to loop through all of the items that the shop holds, and we're going to add it to our shop system. And that's it for the shopkeeper for now. Okay, so let's make an NPC to try and interact with. So I'm going to come over to our scene here, and I'm going to right click, create an empty, and I'm just going to call this our shop NPC, and I'm going to right click, create 3D object capsule. So this is our shop NPC. So let's drop the shopkeeper script onto it. You can see that it needs a item held list. I'm going to get this and let's bring that over here. You can see we've got a bit of an issue here where it already adds a script. When it adds the unique ID script to an object, it's not working straight away. So let's just, we can do context menu generate ID, and we can just generate an ID for that to get rid of the error that we were having. So now in our shop system, let's create a folder called shop item list SO for scriptable objects. And we can right click, create shop system, shop item list. And we'll just call this default shop list for now. For the max allowed gold, let's say the shopkeeper can start with 1,000 gold. And for the markup, this can be, this is going to be a percentage. So we can say, it's going to mark up the price by 25%, by 25%. So if something is you know, worth 100 gold. So, and what that's doing is if we look into our item data folder, you can see we've got a gold value here, which is going to be set to something like 100, for example. And that's kind of a base value. Now, using these markups, if I put 0.25 here and say 0.5 in the buy markup, what this is going to do eventually is that when we try to sell if we try and sell that cog, which is worth 100 to the shopkeeper, he's actually only going to offer us 75 gold for it instead of 100 because he's going to take 25% off. And then he will sell cogs to us for 150 gold. So that's kind of the markup. So now you've got to think of these as kind of like a base value. This is kind of, you know, so in an ideal world, if a shop really likes you, for example, they're not going to mark it up. This is how much it's going to cost. But we've now got that flexibility to kind of, you know, rip off the player or even reward the player. We can offer them more than the actual value. If, for example, that NPC really wants certain items or really likes you, you can specify that here. And in our items list, we can now drop in some stock. So we can open up this and we can say cog. So the shop is going to stock 99 cogs, and let's say it will stock 10 potions, and let's say it can stock 1 sword. So that's its stock list. We can go back over to our shop NPC and let's add our default shop item list to that. And then let's just, we're not going to get the UI set up in this video, but let's just put a debug.log in. So back on our shop system. So over on our shopkeeper script, we'll say for each item in shop items held, let's just debug.log item, and we'll make a new string and we'll say item data dot display name, and then we'll put a colon and we'll put in the item dot amount. So this is just going to debug.log every item that's getting added to the shop and the amount of that item as well. So if we hit play, you can see that when we've set up our shopkeeper system, we've got our cogs 99, health potion 10, and the shop contains 1 sword now. And if we go over to our shop system, we can actually add system.serializable to our shop system. So we've got our shop system. So after we've added system.serializable, we can serialize these fields, and then we should be able to see them in the inspector. So we'll do serialize field, and then if we go over to our shopkeeper, let's serialize this field as well. And then if we go over to shop slot, we also need to mark this as system.serializable as well. And now this is serializable, the shopkeeper is serializable. So if we go back to Unity, we should be able to see this all in the inspector. So we've got shop inventory, and we can see our inventory there. So if we hit play, we can now see our shop inventory has 99 of item ID 2. It's got 10 of item ID 50 and 1 of item ID 0. And we can see that our cog has an ID of 2. We've got our cog here, we've got 99 of them, and our shop NPC has 99 of item 2. So the great thing about this is we can have multiple NPCs now. So if we Control D and duplicate our PC and make another one, and it's got the same list. So let's right click, create shop item list, and we'll say weapon shop. And this can be a shop that has all of our weapons. We've only got 1 item here, but let's say it carries 10 swords. It can have 2,000 gold. It's got a sell markup of 1.5 and a buy markup of 1.5. Now we'll go back over to our NPC. We'll give it the new sort of stock list. We'll hit play. And you can now see that this has got 10 swords. This one has only got 1 sword, but it's got all of our other items. And we've defined all of these different things in our shop systems. And again, to show you kind of how easy it is, we can make shop system and we'll say potion shop. This will stock 2 items. It'll stock the poison potion and the health potion, and it'll have 50 of each. They'll have 500 gold, but they're going to rip you off with the markup. And then we can make another bean. This will be our potion shop. So we'll make a potion shop, hit play. So we've got 3 individual shops here. So we've got our NPC here, which has got the default shop list. We've got this NPC, which is a weapon shop. We've got this NPC, which is a potion shop. So that's going to be it for this video. I know it was a lot of like jumping between different scripts and refactoring stuff, but that's kind of the way these things go. But hopefully that all made sense. And if you've got to this point in the inventory tutorial system, hopefully it will all make sense, because these are scripts that we've kind of dove in and out of numerous times. And it's a lot of the kind of same concepts of the sort of inventory system. So if I skipped over anything quickly, maybe go back and watch the previous videos to kind of get up to speed with, for example, how the contains item function works, or, whatever. In the next video, we'll start to set up the UI for the shopkeeper, which will display their inventory in a list. And we'll see how far we get with that, and whether we have to make another video about actually purchasing and selling items to the shop. If you want access to the project files from this video, you can head over to patreon.com/danposs, where they are available. I'd just like to take a minute to thank all of my patrons. On screen now, we can see the 10,000 XP tier, which is Sector Sweep. And I want to thank all of the 4,000 XP tier members as well. If you need any help with this video, make sure you head over to the Discord server, which is linked in the description below, or just leave a comment on the video and I'll do my best to help you there. But in the meantime, thanks for watching, and I'll catch you in the next one. Bye. Hello and welcome to episode 13 of the inventory tutorial series, and episode 2 of the shop system. So we've got our shop system here. You can see that we've got this kind of pop-up window that's going to be our shop. And you can see that it's going to be able to have buy and sell tabs. So this is going to show either the shop inventory or the player inventory. We're going to add things to this window here, which is the shopping cart, and then we'll be able to buy the items or sell our items. That'll be coming in the next video. In this video, we're just going to be working on laying all this out, getting it all set up, making a few scripts, and just, laying the groundwork to actually plug in the UI to the shop system we made in the previous video. And you can see currently, if we hit play, we can walk over to our NPCs, which we've made, and we can interact with them, and it'll bring up the window. That's what we're going to get to in this video. It's not the most exciting thing, but it's a necessary step on the way to displaying our shops. So let's just jump straight into it. Okay, so let's get started. So let's go on our canvas here, and I'm going to make a new empty. I'm going to call this the shop UI controller, and to this I'm going to make a panel. So right click UI, and I'm going to put in the graphic that I've been using for the other inventory stuff. Panel, it's not there. What's it called? So with that panel, I'm just going to make it a kind of brownie color. You can put any sort of graphics in here that you want. So I'll make it this color here, and I'm going to get the panel, and let's go into sort of 2D UI mode, because we're going to be doing a lot of UI stuff. Let's zoom out, and we can make this panel nice and big. You can make it fill the screen if you want, if you want the shop to kind of fill up the whole screen. But I'm just going to make it like this. So it'll pop up like this. And then I'm going to make a new empty. I'm just going to call this window left, because we're going to split our shop window into two sections. And I'm also going to make a empty, say window, to our panel object. We're going to add in a horizontal layout group, and we're going to let this control the child size, and we're going to say the child alignment is going to be the upper center. Now if we go over to our window left, you can see that the box is now half of the panel that we've made, and the other box is on the other half of the panel that we've made. So to our window left object, I'm going to create two UI buttons. And if you've got all of these weird lines up, you can remove visualize. I'm just going to bring this up here. Let's make it a bit bigger. And this will be the buy tab. So we'll click this and it'll show us the items that we can buy from the shop. And then we can click, we're going to make a sell button, which will show us the items in our inventory. And this and allow us to sell them to the shop. So we've got our buy button. Let's rename this just so we know exactly what it is. Buy button, and then we'll Control D, duplicate. This will be the sell button. Move this over, and then swap this text to say sell. And then underneath our buttons, we're going to make a UI scroll view. I'm just going to drag this just above the buttons in the hierarchy, and we're going to select stretch to fill the whole the whole canvas, but then we'll just bring it down to not kind of overlap the tabs. I don't want the horizontal bar on our scroll rect, so I'm just going to uncheck horizontal, and we can remove the horizontal scroll bar. We'll just select none. Then under scroll view, we can just delete the horizontal scroll bar. And then if we go to the vertical scroll bar, we can just drag that out so it fits our entire panel. Then I'm going to twirl out that, and I'm just going to rename this content object to item list, just so we know kind of, I'm going to rename this to item scroll list, just so we know if we're just looking at this, that this is the scroll list. And then we need to just make this a bit bigger, just kind of just below the scroll bar. And you can see, depending on how big this is, that's kind of responsible for how much we can scroll. So we'll have to change and tweak this probably as we go, but for now that's fine. And then over on the right hand side, so let's just close that. So on the right hand side, I'm going to make another empty. We're going to call this item preview, and can make this fill this side of the screen, take it all the way to the top, and to our item preview, we're going to add a sprite. So UI image, and we'll call this the item sprite. And let's just drop in a sprite just so we can see how this is all looking. So we'll do our bottle, we'll do preserve aspect, and let's just make this a little bit bigger. We're going to add some text, so we can say UI text mesh pro, bring this down, we'll auto size it, we'll align it horizontally and vertically, and here we'll just say health potion, again just so we can lay this all out. This will be all changed through code anyway, and then we'll rename this to item name, and let's just duplicate it. We'll move it down. This time I'm going to make this a little bit bigger there. And I'm going to left align it and top align it and say this is the description. And we'll make the max size just a little bit smaller. And then we'll rename the object to item description. And then we're going to make another object. We'll right click, create empty, and this is going to be the shopping cart. So this is going to have another scroll view. So we'll right click UI scroll view, and then let's drag this down. So we'll position that kind of down here. Again, we'll make it fill the this half of the canvas, so we'll just drag that out. And like before, we don't want a horizontal one, so we can get rid of the horizontal bar, the vertical scroll bar fill the actual frame, and it says missing. Let's just select none on there. Got our scroll list here, and then again let's rename the content panel just so we know exactly what this is. So this is going to be the shopping cart list, and then to our shopping cart item, let's create a button. So we'll say UI button text mesh pro, and this will be the buy sell button, and we'll just drag this down here just under our shopping cart. Let's make it a bit bigger. We'll go to our text and we'll say buy items. So we're going to make some more text. So we're going to right click shopping cart, UI, text mesh pro. Let's bring this down here. We can make it a bit bigger, kind of to here. And I'm going to center and right align this. And I'm just going to put in total 5,000 gold. That's how much our shopping cart. This is going to display how much our shopping cart is worth. So we can rename this object to basket total, and then I'm going to duplicate this and let's move it up. And this is going to be shop gold. So this is how much gold the shop has access to. So let's say 1,000. I'm just going to make this a little bit smaller. So this is the shop gold, and then let's duplicate this again. Move it over. We need to left align this, rename it to player gold. Oh, what's going on? Rename this to player gold, and then in the text we can say player gold, and we'll say 500G. So this is how our shop's going to look, and it's going to have items kind of added to it into this scroll view here. And let's get a look for what that's going to look like. So if we go up to our window left scroll view, let's go to our item scroll list, and let's create an empty, and we can call this shop item list UI. So to this, we're going to add in a item sprite. So we'll say UI image. Let's call this item sprite. And again, just for simplicity, let's put our item in it. And I'm going to make this the size of our panel here. So we've got our item sprite. We're going to add some text to this. So we'll say UI text mesh pro, left align it. I'm going to center it though. And we'll say health potion out to about there. We can position this kind of where we want it. This is going to be item name. We'll duplicate this, move it down. This will be the item amount. So this is going to be how many of the item the shop has. So we'll say it's got 5 potions. And I'm just going to make this a little bit smaller than the text and the name of the text. And then I'm going to add 2 more buttons to this. And then that should hopefully be most of the UI done. We'll just need to start the kind of code side of it. So let's do button text mesh pro. I'm going to say add to cart button. I'm going to make this a square. And for the text, I'm just going to put a plus symbol, this a bit bigger. So this is going to be to add it to the cart. We can drag that over. And then let's duplicate this, move it over. We'll call this the remove from cart button, and instead of a plus it can be a minus, and then you may want to move it up so it's sort of center in the button. There's our shop item list UI, and to get this working correctly into a list, we just need to add a grid layout group to the item scroll list. So we'll say grid layout group, and we'll say upper left. Instead of constraint, we'll say fixed column count, and there's just going to be 1 column. Pivot on our shop item. Okay, so you can see it's gone off kind of kilter here. We need to set the items to be pivoted to the top left corner. So unfortunately, I'm going to have to relay these out. So we'll select all of our items. We'll click onto the anchor preset. So we'll hold down Alt and then click the top left corner one. And then let's just reset our layout here. Okay, so we've adjusted them, got our item scroll list, and then we can start to put in some padding. We'll do 32 on each of the grid layout group, which again is on the item scroll list object. And let's just these just to see how these are going to lay out. So now we can adjust the sort of spacing and the cell size. So if you want a bit more of a gap between them, you can say like 64. 32 kind of works. Cell size shouldn't matter too much because we're kind of controlling that all through the sort of position of this shop list item UI. So you can see that these are looking quite good. We can duplicate them, and because it's in a scroll box, it'll go kind of below the sort of scroll view, and we'll be able to scroll down kind of in the game. I'm actually going to delete all these, go to our prefabs, and I'm going to drag in this shop item list UI, and I'm going to make a prefab out of it. And then we're going to delete it from our view. And I'm going to go over to the shop UI controller, which is the kind of top level object. And this is going to be what sort of pops up when we access a shop. So it'll bring up the shop and we can close the shop. So this is the sort of top level object. And to this, I'm going to add a script. I'm going to go to my UI scripts folder. I'm going to right click, create C# script, and we'll call this the shopkeeper lay. Let's open this up in our editor, and let's get started adding some variables to this. Okay, so we're going to need to start making fields for all the kind of UI elements that we've just made. So I'm going to make a serialized field private, and this is going to be shop slot UI, which is going to be another script that we put onto that shop slot that we've just made. So I'll say shop slot prefab, and then let's actually make that. So in our UI scripts folder, let's create another script. We'll call this the shop slot UI. So this is the thing that we just made with the buttons to add and remove to the cart. We're going to need another one for, we're going to have to do something quite similar for the shopping cart section, but we'll get to that kind of later on. We want a serialized field for a private button, and this is the buy tab. We'll need a one for the sell tab. And you can see this is red here because we need to import type using Unity Engine UI. We need to make sure we've got that to kind of access the button. I'm going to make a header here. I'm going to call this the shopping cart. This will be the shopping cart section. I'm going to do serialized field, private mesh, pro, UGUI, basket, total text. I'm going to duplicate this a couple of times. We're going to have the player gold text as well as the shop gold text. Gonna have another button reference, so serialized field, private button, and this is the buy button on the shopping cart. And then we want a serialized field, private text mesh pro GUI, and this is the buy button text. So this is going to change to say either buy or sell, depending which sort of tab we're in. And I'm going to make a new header. We'll say item preview action. We'll do serialized field private image, and we'll do the item preview sprite. Serialized field private text mesh pro GUI, and this is the item preview name, and we can copy this, and this is the item preview description, and we need a serialized field private game object, and this is going to be our game object item list content panel, and we'll duplicate this, and this will be our shopping panel. So let's go back to Unity. We'll go to our shop UI controller, and to this we can add our shopkeeper display, and we need to hook all of these up. So the shop slot prefab, that was the prefab that we just made. So if I go over to prefabs, shop slot shop item list UI. To that we need to add the shop slot UI script that we've made. That doesn't do anything yet, but that's fine. We can drag in our shop slot UI. For the tabs, we'll do buy tab and sell tab, basket total, gold, shop gold, and the buy sell button, text, item preview. So we've got item sprite, which can go down there, item name, item description, and then we've got our item list content panel, which is this item scroll list, and then we've got the shopping cart panel, which is under scroll bar view, viewport, and we've got our shopping cart list. So that's our UI set up there. I'm just going to press save. So let's make the other prefab, which is going to be the thing that we populate the shopping cart with. So all this is going to be, let's go to our shopping cart list. So that's this content panel here. I'm going to right click, create empty, and let's call this shopping cart item, and to that I'm just going to add some UI text for text mesh pro, and we'll put in item name times 10. We'll stretch that to fill kind of the available space it has. For our shopping cart item, I'm going to again anchor it to the top left. Let's make our item kind of fill the content panel here. We will just going to make this a bit smaller and just give it a little bit of padding. And then on our shopping cart content panel, we need to do what we did earlier. So we need to make a grid layout group on this. Fixed column count, again, is 1. We'll give it some padding, so 32. Spacing, we'll do 32. So let's anchor that to the sort of center left, actually. And let's center it out on there. Drag that in a bit. So this is our shopping cart item. See, as we've duplicated them, they've gone off the panel. We need to reduce the Y on the cell size. About there. I'm going to reduce the padding on the top as well. Padding on the left a bit. There we go. So we can add multiple items to our basket now. So let's delete them, make a prefab out of our shopping cart item, delete it from the list. Let's make a new script then called C# script shopping cart item UI. Let's add that to the shopping cart item prefab that we've just made. We'll jump back over to our shopkeeper display script, and we're going to do a serialized field private shopping cart item UI. We'll do shopping cart item prefab, and we can hook that up in the inspector as well. So let's go back to our shop UI controller, drag in our shopping cart item UI. Okay, so let's actually just get this displaying, and I think that'd be a good place to end the video because it's gone on for quite a little bit. So let's go over to our project, and I'm going to open up our shopkeeper script, and we can see here that we've got the iInteractable interface on it. So when we interact, we can ask the UI manager to display the shop system. So in our interact function, we can just let's make a Unity event. So we'll do public static Unity action, and this is going to pass to the shop panel. It's going to pass the shop system to our shop system. It's going to pass that in, and it's also going to pass in a player inventory. Do we not have? And it's going to pass in the player inventory holder. And this is just going to be called on shop window requested. So in our interact, we need to get the player inventory component. So I'm going to say player var player inv is equal to interactor component player inventory holder. And then if our player inv variable is not equal to null, then we've got the player inventory successfully. We can say on shop window requested, and we can invoke that by passing in our shop system as well as the player inventory. We can end the interaction for now, and then we'll do interact successful is equal to true. And actually, let's get rid of that. We don't need the end interaction function in there. And then we can say else interact successful was equal to false, and then let's just debug.log error player inventory not found. Okay, so back in Unity, on our main canvas object, I'm going to add a kind of top level UI controller. So right click, create C# script UI controller, and then let's add the UI controller to our UI canvas, and let's open that up. So in here, on the on enable function, we're going to subscribe to shopkeeper.onShop window requested, and let's do display shop window, which is planing because that's not a thing. So let's implement that. So we've got a method that takes in a shop system and a player inventory. Let's rename this to shop system and player inventory. And then in on disable, let's unsubscribe. So on shop window requested, let's unsubscribe the display shop window function. Let's take in a serialized field, shop private shopkeeper display, and we'll say shop display. Let's call it shopkeeper display. Yeah. So the first thing, all we're going to do for now is we're going to open up that panel. So shopkeeper display dot set active dot game object, sorry, dot set active to true, and then in awake, let's make sure the shopkeeper display is closed. So game object dot set active false. So back in Unity, shop UI controller goes into there. So if we go over to our NPCs, we need to add them to the interactable layer. So let's just choose interactable, and we'll just say no, this object only. We don't want to set the capsules as interactable. And let's add capsule colliders to the actual top level NPCs and remove them from the capsule graphics. So if we hit play, that should work. Go over here, we can hit E, and that's going to bring up our shop system window. So that's going to be it for this video. In the next video, we're going to work on looping through the shop system and the player inventory and displaying them accordingly in this panel here. And then when we click the buttons on those shop UI panels, we'll add them to the cart, and we'll allow the player to actually buy the item by clicking the buy item button. Obviously, all of this will update and work very nicely. If you'd like the project files for this video and this entire series so far, they are available on Patreon, which is patreon.com/Dampos. I'd just like to take a minute to thank all of my patrons. On screen now, we can see the 10,000 XP tier, which is a sector sweep. And I want to thank all of the 4,000 XP tier members as well. If you need any help with this video or any of my other videos, feel free to leave a comment below or head over to the Discord server, which is linked in the description. And in the meantime, thanks for watching, and I'll see you in the next one. Bye. Hello and welcome to this video. At the end of this video, we'll be able to interact with our NPCs and utilize the shop system UI that we made in the last video. So we're going to come over here. We can press E to interact with our NPCs. So we'll press E and it'll bring up the shop window. It's going to list all of the items that the shop has in stock. So you can see from our scriptable objects that there's 99 cogs, 10 health potions, and 1 sword item in this shop. And the shop has 1,000 gold available. So let's just jump straight into this video. Okay, so let's just continue where we left off. So in the previous episode, we'd set up the canvas and we'd made this shopkeeper display script, but it currently doesn't do anything. So let's make it do some stuff. Okay, so the first thing that it would make sense to do is actually to spawn the items from the shop in our shop list on that left-hand panel. So let's set that up first. So we'll do a public void display shop window, and in here this will take in a shop system. We'll just call this we'll just call that shop system, and we'll do player inventory holder, and we'll call this player inventory holder. So let's assign the shop system and the player inventory holder to some sort of like script wide variables that we can kind of keep a reference to. So we'll we'll do a private shop system, and we'll call this underscore shop system, and we'll do a private player inventory holder, and we'll call that player inventory holder. So the first thing we'll do is we'll get our shop system, and we'll get underscore shop system, and we'll equal this to shop system, and underscore player inventory holder, and we'll equal this to player inventory holder. And then we'll refresh the display, which is going to be a new method that we'll make. So we'll do private void refresh display. And the first thing we'll do here is we'll clear our slots. So you'll notice this is seeming, and this is sounding a little bit like the dynamic inventory display and our static inventory display. There's not really a huge amount of copied functionality. Like, we don't need to be able to click on the slots or anything. So I didn't want to kind of have shopkeeper display derive from inventory display, but of course there are some functions that are, of course there are some stuff kind of in common. So for example, clear slots, but we're not going to copy this over wholesale. I just thought I'd point that out. I am aware that there's similar sort of naming, but they're different enough to not kind of need to derive from inventory display. So we're going to have clear slots, and this is going to be a private void clear slots. So this is going to loop through every item in our item content list panel and a dot transform, and then we'll do cast transform. So that's just like we're doing here, but we're doing it on our display. And we're going to destroy item dot game object. Then we're going to do the exact same thing again on the shopping cart content panel. That's going to clear the slots. And we actually need two dictionaries which are going to keep track of what we have in our shopping cart. So let's come up here and we'll do private dictionary, which is going to take in inventory item data as well as an int. And this is going to be our shopping cart, which is going to be a new dictionary of inventory item data as an int. And then we're going to have a private dictionary again of inventory item data. And this is going to be the UI kind of side of it. And this is going to take in our shopping cart item UI. And this will be the shopping cart. And this will be the shopping cart, I'll call it UI. So this equal to a new dictionary. So there's our two dictionaries. So as well as in clear slots, as well as deleting all of these items, we're going to clear out these lists, these dictionaries as well. We're just going to delete them, make new ones, that replace them with these new dictionaries, just to make sure they're nice and fresh. So that's our clear slots function, which we need in our refresh display. And then we're going to disable the basket total text, because obviously there won't be anything in the basket at first, but we may as well disable it. You could also just set it to 0, but I am going to set it to false. So basket total text dot enabled is equal to false. I'm going to turn off the buy button. So buy button dot game object dot set active false. We're going to make another int up here. We'll do it here. So private int, and this is the basket total. This is going to keep track of how much our basket is going to cost. So obviously when we're refreshing the display and the slots have been cleared, we can actually set that back to 0 because we know there's nothing in the basket. So it won't be worth any kind of amount of gold. And we can refresh the text. So we can do player gold dot text is equal to string. So player gold. I'll set this equal to the player inventory holder dot inventory system dot gold. And I don't think we've actually implemented that yet. So let's go over to the primary inventory system. Let's actually serialize field private int gold. So let's introduce the concept of gold to our inventory system. And we'll do public int gold, and we will return gold, our private int gold up here. And then as well as this public inventory system constructor, we're going to make another one, which can now give us some gold. So public inventory system, which will take in a size and a gold amount. And here we can say gold is equal to gold, and then we will call our here we say gold is equal to the gold amount that we've passed in. Here we'll just set gold to 0 as a default, and I'm going to take this bit of code, and I'm gonna a private void method called create inventory, which takes in a size, and then we can just say create inventory size and that down here as well. So we've got two constructors now. One just takes in a size, one takes in some gold to give to the player. So we've introduced the concept of gold to our inventory system. Let's go back over to shopkeeper display. So we've now got gold, so we're going to display the player gold, and then we want to do the same but for the shop gold text, and then we'll say shop gold, and this will take from the shop system the available gold, and I don't think that's we haven't got a kind of getter for that, so we'll just do public int available gold, which will return available gold, and then we'll go back over to our shopkeeper display, and you can see that that's working there now. Okay, so now we just want to make another method, and this one is going to be a private void display shop inventory. And we're not going to use this one just yet, but I'm just going to make a private void display player inventory as well, just while we're doing that. So up in refresh display, let's call that, so display shop inventory. And all we're going to do in this method is we're going to loop through every item in our shop systems inventory. So shop system dot items, which I don't think we can get. It's this shop inventory here. We need to allow a getter for that. So public list of shop slots called shop inventory, which will allow us to get the shop inventory variable. Go back over here and we can say for every item in our shops inventory, if the item dot item data is equal to null, then let's just continue because we only want to populate, we only want to spawn in a slot if it's not null, and then we can say var shop slot is equal to instantiate the shop slot prefab underneath our shop list panel, what's it called? Underneath our item list content panel dot transform. And then we can initialize the shop slot, so shop slot init, and this is going to pass in our item along with the shop system dot by markup, which again we can't get. I'm going to do a public float by markup, which will return the by markup, and then we may as well do the cell markup while we're here. We will need to do that. So this init function, this is going to be on our shop slot UI class that we made and never did anything with. So let's do a public void init, which will take in shop slot and a float. So shop slot and float markup. Okay, so let's work now on initializing our shop slot. So we'll go over to the shop slot UI class and we'll serialize field private image in Unity Engine UI item sprite. We'll do serialize field private text mesh pro UGUI item name, and let's just duplicate that to be item, and we'll do a serialized field private shop slot signed item slot. So in our awake function, we're going to set the item sprite dot sprite equal to null, item sprite dot preserve aspect equal to true, item sprite dot color equal to color dot clear, item name dot text is equal to just a blank string, and item count dot text again equal to a blank string, an empty string. We want our buttons as well, so we want a serialized field private button, and this is the add to cart button, so add item to cart, as well as a remove item from cart button. Now call these buttons just so we know exactly what they are. So to our buttons, we're going to add some methods. So we're going to say add item to cart button. If it's not null, we're going to add a listener to the on click button, and it's going to be an add item to cart method. We've got remove item from cart. On click, we'll add a listener. We'll remove item from cart, and we can also get a private shopkeeper display. Let's call this parent display. Once you're going to make this public with a getter and private setter. We don't need to assign that in the inspector, so we're just going to do get private set parent display is equal to transform.parent.get component in parent shopkeeper display. Now let's make these functions here. So add item to cart, let's create a method for that. And let's create a method for remove item from cart. Okay, so before we start hooking up these buttons and making them work, let's get rid of these throw new not implemented exceptions. I'm going to make a private void update UI slot, which is going to take in shop slot, as well as the markup, so float price markup, and I'm just going to move this init function up here just so it follows a bit more of a logical order. So in our init function, I'm just going to set our assigned item slot equal to slot and call update UI slot, passing in our shop slot and markup. And then in our update UI slot, we can say if assigned item slot dot data is not equal to null, just as a check, we're going to say item sprite dot sprite is equal to assigned item slot dot item data dot icon. We can set the item sprite dot color equal to color dot white. The item count dot be equal to the item slot, the assigned item slot dot stack size dot toString, and then the item name dot text is going to be equal to item slot, assigned item slot dot data dot display name. And then for now, we're just going to do the item slot item data dot value. So this isn't going to take into account the markup for now, but let's just get this in and working. And then here we can say else. So if the item is null, then let's just clear the slot out. So that's that there. Think about it, we don't actually need to pass in shop slot like that. Let's just get rid of those. And then let's store this markup so we can use it later in a public float markup again with a get and private set. And here we'll just say markup is equal to markup, just so we can access that down here when we do actually want to use the markup. And then assigned item slot, obviously we're setting here when we initialize it. Okay, and then just to make sure the buttons are getting set up properly and kind of registered to these events, let's just say, let's debug.log, adding item to cart, and then removing item from cart. Okay, so now on our UI controller here, when we set our display to active, so when we interact with the NPCs and we turn on the shop window, we want to set it active, and then we want to call the display shop window method on this function, and we can pass in the shop system and the player inventory here. So we're going to interact with the NPC, it's going to call this method, which is going to turn on the actual game object so it pops up and we can see it, and then we're going to call the display shop window method. That's going to set up the shop system and the player inventory holder, and then it's going to refresh the display, which is going to clear any slots that were already there on the panel. It will then reset all of the sort of text and the variables, and then it will display the shop inventory, which is going to spawn in our shop system prefab. It's going to instantiate them under the scroll list that we set up on the left hand side. And then it should initialize the shop slot with the item. So let's see if that actually works. So let's hit play, and before we do that we need to set up some stuff. Obviously I always forget to do that. Let's go to our prefabs. We've got our shopping list item UI, and you can see that we've now got all of these fields that we need to fill in. So drag in the item sprite, item name, item count. We don't need to do anything with the assigned item slot, but we can drag in the add item to cart button as well as the remove from cart button. Okay, so hopefully we've not missed something. We probably have. Let's hit play and just see what happens and see in which way it breaks. So let's go over here. So this is one of our NPCs. We can open it. Oh, and there you go. I'm surprised that worked first time. So we've got our cogs, which are worth 1G, our health potions, which cost 100G, and our sword items, which he's got one of, they cost 100G as well. Currently, I've got no way to close the panel, which is a bit of an oversight. So let's come out and go back in here. This has got our sword. They've got 10 of them at the sword shop. And then we can come over here. We can access the potion shop, and we've got the poison potion and the health potion. And okay, I know this was a bit of a shorter video, but I'm going to leave this one here because in the next video, we're going to set up the actual shopping cart system, and there's a lot of quite like dense kind of stuff we need to do involving kind of like the marking up of the items. So I'd rather do that in its own separate video to try and keep that one concise. But hopefully you liked this video. All of the kind of series doing this shop system is already available over on patreon.com/danposs along with the project files. So if you don't want to wait a week for the next part, feel free to head over to the Patreon, and if you support me there, you'll get access to the videos kind of early because they're all done and filmed. I'd just like to take a minute to thank all of my patrons. On screen now, we can see the 10,000 XP tier, which is a sector sweep. And I want to thank all of the 4,000 XP tier members as well. If you need any help with this video or any of the other videos in this series, leave a comment below or head over to the Discord server where you should be able to get an answer from me there. And in the meantime, thanks for watching, and I'll see you in the next one. Bye. In today's video, we're going to be carrying on with our shop system that we've been working on. So you can see over here, we can go to our NPC here. We can see the player's got 500 gold and the shop has 1,000 gold. And we've got cogs, we've got 99 cogs, 150 health 10 health potions, they're 150g, and there's one item which is 150g. If we then click on these buttons here, we can add to our basket total. We can remove from our basket, and you can see that it's updating here. If we add too many items to the basket that we can't afford, so if we go over the player's gold, so the player's 500 gold, the basket totals 610 gold, we can't afford them. If we hit the buy button, nothing's happening. So let's just remove the potions from the basket total. So now we've got 5 cogs, 3 health potions, and then we hit buy items. You can see that we've bought the items. The amount that we had in our basket's gone into the shop gold, and it's been taken away from the player's gold. And then if I shut this panel, you can see in our inventory, we've got the cogs and potions here. I'd already picked up some potions from the floor. Let's just drop them on the ground. Let's drop the cogs on the ground. Let's go over here, press E. So let's buy some more cogs. So I'll buy 7 cogs, close our inventory, and you can see that we've got 7 cogs in our inventory now. And we've got our 4 potions, which we bought earlier. So that's what we're going to do in this video. Let's just jump straight into it. Okay, let's just jump straight into this one then. So we're going to work on adding the functionality to add and remove things to the shopping cart. So the first thing we want to do is we need to introduce a variable that's going to keep track of like the temporary count. We don't want to actually change the underlying shop slot. What we want to do is have a private int, which we will call temp amount. And then when we set up the shop slot UI and we assign everything here, we're going to set the temp amount equal to the slot.stack size. So now we can add and remove stuff to the cart, but if we exit out of the interface, we're not going to have actually changed the shop's inventory. We're not going to have removed anything from the shop's slots until we actually press the buy button. Once we press the buy button, then we'll actually take it from the stack size. So we're just creating this temporary amount to keep track of that. So let's work on adding stuff to the cart first. So with add item to cart, we want to just check to make sure that there is actually an item to add to the cart. So if our temp amount is greater than 0, then we're going to remove an item from the temp amount because it's going into the cart. We're going to call our parent display and we're going to add item to cart. And we're just going to pass in ourselves as this. And we can make that function there over on the shopkeeper display script. We're going to have a add item to cart, which takes in a shop slot UI variable. And we'll go back to our shop slot UI script. And then we're just going to update the item count dot text is going to be equal to our temp amount dot to string. I'm going to invert that if. So if it's less than or equal to 0, then we're just going to return. And if not, then we can reduce 1 from the amount, add it to the cart, and then update the UI slot text. And then for the remove item from cart, we're just going to do the opposite. So if temp amount is equal to the assigned item slot dot stack size, then let's just return, because there's nothing to, because if the temp amount's the same, then there's nothing in the cart. So we don't need to manipulate it in any way, so we can just remove, and the remove item button won't work, it won't do anything. But if the temp amount is different to the actual amount of the shop slot, then we're just going to increase our temporary amount. We're going to call parent display remove item from cart, again passing in ourselves, and then we're going to update the item count dot text to the temp amount dot to string. And again, let's make this method over on our shopkeeper display. So it's going to be remove item from cart, taking in a shop slot, and that's on the shopkeeper display script. And for now, I'm just going to remove these system exceptions. Okay, so if we go back over to Unity and we hit play, let's go over to one of our shops. So you can see that there's 99 cogs, 10 health potions, and 1 sword item. If we hit the plus, this is going to start adding stuff to the cart and removing from the temporary amount. But if we actually check the NPC, we haven't changed the shop inventory. We're not going to do that until we actually press buy, because there's no guarantee that the player would complete the purchase. They could press escape and close this panel and then go back to it, and that we need the shop to have been reset. So we don't want to actually change the shop inventory until we've hit the buy button, which is going to be over here. And you can see that we can remove items from the cart, and we can go back up to the original stack size, but we can't remove items that we don't have. So we can't go up to 100 cogs. And we can do this all the way down to 0, and we can't add any more than the shop inventory currently has. So now we need to actually add them to the cart, which is going to be this window over here. Let's go do that. So let's go back over to our editor. And this is where it's going to be quite confusing. Hopefully you'll follow along. I'll try and explain everything as I go. So we're going to get a reference to the data from the shop slot UI. And we'll get the assigned. We're going to need to go through to the shop slot UI, and we need to make a public getter for this shop slot. So we're going to make a public shop slot called assigned item slot, which will return our assigned item slot. And now back over on our shopkeeper display, we can get the assigned item slots item data. We can just cache that in this variable, which we're going to call data. And then here we will update the item preview, passing in our shop slot UI. Again, this is going to be another method. We'll work on this later, but this is going to be where it shows the name and the description and the thumbnail. But we'll do that. Okay, so we're now going to use this shopping cart dictionary that we made, which remember takes in an item data and an int. So here we're going to say if our shopping cart dot contains key data. So if our shopping cart already has this data in it, and how do I stop that? So if we already have the data in it, so if this item is already in our shopping cart, then we are going to add to the shopping cart 1. So if the shopping cart already has it and we're adding an item to the cart, we're just going to increase the int in the dictionary by 1, meaning that there's going to be 1 more of that data in the cart. And then this is where the markup's going to start to come in, the shop markup. So we're going to do make a new variable called price, and this is going to equal, and I'm going to make a new method called get modified price, because this is we're gonna use this in a few different places. So we're gonna pass in the shop slot. So So to this, we're going to add in the data. We're going to add in an amount, which is just going to be 1 in this case. And then we'll do shop slot UI dot markup. So this is going to be the markup value. And let's make this method. So this is going to be a private static int, again called modified price, which is going to take in some data and amount as well as the markup here. And all this is going to do is we're going to get the base value. So base value is equal to the data dot gold value times by our amount. So remember, this gold value here is what we define as the value of the item. So if the gold value is 100 and we pass in 2 of the amount, the base value before we change it with the markup is going to be 200. Once we've calculated the base value, we can just return the mathf.round to int, and we can do the base value plus the base value times by the markup. Let's just see that math kind of in action. So if we take our base value of 100 and we have one of them, so the base value is going to be 100, and then we have a markup of 50%, which is going to be 0.5. So 50% of 100 is 50, and then we're going to add that to the base value. So we're going to do the base value times by the markup. That'll be done first, and then it'll be added to the base value. So it would be 50 plus 100 is 150. So that's the markup. And that'll work for sort of, anything. So if we do a base value of 75, there's a markup of 30%, and then we add 75 back to that, the price is going to be 97.5. And the reason we're rounding it to an int is that obviously the gold amount is an int. We don't want 0.5 gold. So we're just going to round that up. So that's how we're going to get our modified price. And once we've got this price, we can then make a new variable called new string, and we'll equal this to a string that's got the shop slot, that's got the data.display name. And then I'm going to put the price in brackets. So we'll do price with a G, so that's how much gold there's going to be, and then we'll pass in from our dictionary the amount of that data that we have. So shopping cart at data, so that's going to be the value, so that's going to be the int, so it's going to be display name with the markup, so a cog for 100 gold, and it'll show that we've got 10 of them in the basket, for example. And then remember, we've also got the other dictionary, which is the one with the shopping cart item UI in it, which will correspond to this bit of data here. So we can go to our shopping cart text, shopping cart UI dictionary. I'm going to get the value with the key of our data, and we're going to set item text. We're going to pass in our new string. Now, again, this is another method we need to make. So let's create that method. So this is over on our shopping cart item UI, which we've not fully set up any of the variables yet. So let's do that now. So all this is going to have is a serialized field, private text mesh pro UGUI, and we'll call this item text. And then all we're going to do here is set item text.text equal to our new string. And let's actually set up this prefab in Unity. So let's go back over to Unity. And we've got our shopping cart item prefab here with the shopping cart item UI script. So we're just going to get the script and drag the text into the serialized field of the item text. We'll go back to our main scene here. So that's the shopping cart item UI script. Let's jump back over to our shopkeeper display script. And here we're going to increase the basket total by the price. So this is the current cost of the basket. So basket total plus equals the price. And then we can set the basket total text to display that price. So we can say total and then pass in our basket total, and that's the amount of gold that the basket is currently going to cost. So this is if our shopping cart already contains the key. This is our shopping cart. This is if our shopping cart already contains the data that we're trying to add. If it isn't, then we're going to need to add to the dictionary and then do some of this stuff. So we can say else shopping cart dot add. We can pass in the data and the amount. So it's going to be 1 in this case. Then we're going to instantiate a new shopping cart text object, and I'm going to get a reference to this so we can modify it. So we can instantiate, and we're going to do the shopping cart item prefab, and that's going to be attached to our shopping cart content panel transform. We're going to get the price, and I'm actually going to just copy that and I'll pop it outside of the item cart. I'll pop it outside of this if statement, and then we can just use the price down here. And we could actually do that with new string as well here. And we want to set our shopping cart text obj, and we could do set item text, passing in our new string. And we want to add this shopping cart text obj to our dictionary that contains the text. So shopping cart UI dictionary dot add, and we'll pass in the shopping cart text obj. And that says the value. We need to pass in the data as the key. And then after that, we can update the basket total. So again, I'm just going to cut that out and I'm going to place it at the bottom here. So that's just cleared this script up and made it a bit easier. In my test project, I seem to have a lot of duplicate code. Hopefully this will work. So then once the basket total is calculated, we can say if the basket total is greater than 0 and the basket total text isn't active, then we just want to enable the basket total text, and we can say enabled equals true, and then we can set the buy button to be true, to be enabled as well. So game object dot set active true, and then finally we're going to have another method called check cart versus available gold, and we'll make that method here. So this is going to be a private void check cart against available gold, and here we're going to do a new variable gold to check, and here we want to see whether we're selling an item or buying an item. So to do that, we need to introduce a variable that's keeping track of which kind of buy mode we're in. Are we in selling mode or buy mode? So we can just make a new bool, and I'll move this to the top in a second, but I'm just going to put it here for now. Private bool is selling, and we can say, are we selling? If we are selling an item, then we're checking the shop system dot available gold, and if we're not selling, we need to check the player's gold. So we can do player inventory holder dot inventory system gold. Again, we've got those tabs that we set up, the buy and sell button. If we're buying, when we add things from the shop system to the cart, and then we try and buy it, we need to make sure the player has enough money. And then if we are selling items to the shop, we're going to add items from the player's inventory to the shopping cart. And then when we click the sell button, we need to check to see if the shop has enough gold to buy all of that. So that's what this is doing here. And we'll use this bool a bit later on. By default, this is going to be false until we set up the tabs. So this is going to be checking the player's inventory for their gold amount. And here we're going to update the basket total text dot color. We're going to set that either to white or red, depending on whether the player has enough money, just as a bit of an indication that you've gone over the sort of the basket amount. That you've gone over the amount that the player can actually afford to buy. So we can set the color based on this, the basket total. Is the basket total greater than the amount of gold that we currently have available to us? If it is greater, then we're going to set the color of the text to red, and this could be sort of any color that you want that fits your style. And if we do have enough, we're just going to set it to white, and obviously if it's already white, it won't change. So that's that for now. We'll be doing a bit more in this method later on when we set up the selling mode, but let's just focus on getting buying items to work for now. Okay, so then we need to check as well as the available gold, we need to check to make sure the player inventory has enough space in it to buy the to buy these items. And if they don't, we can update the basket total text to say something like not enough room in inventory. So let's make an if statement here. So if we are selling items to the shop, then we can just return, because we're not going to... So if we're selling items to the shop, then we don't care about this step of, you know, checking the inventory. So we're going to do if we're selling, or the player inventory holder dot primary inventory system, and then we're going to make a new method called check inventory remaining, and we're going to pass in our shopping cart dictionary. So this is going to be a method over on our inventory system script, and it's just going to return a bool, and we're going to do some stuff to check whether we have enough room in our inventory for the shopping cart to fit. So to make this work, we're going to make a clone of the current inventory system, the player's inventory, and then we're going to attempt to add all of the items from the dictionary to that cloned inventory system. If we get an error saying that the inventory system is full and we failed to add it, then we're just going to return false. And if we successfully get through that check on the cloned system, we'll return true, because there's obviously enough room in the inventory to add all of this stuff to the player's inventory. So if that doesn't make sense, hopefully it'll make more sense as we start to code it. I'm going to make a variable called cloned system, and this is going to be equal to a new inventory system, and it's going to be of the same size as our current inventory size. And then to this cloned system, we need to go into a for loop and add all of our current items to the cloned system. So we can say for int I, whilst I is less than our inventory size, I++, and then we're going to get our cloned system, get its inventory, get its inventory slots at position I, and we're going to assign the item that corresponds to our inventory's inventory size. So we can say this dot inventory slots I dot data, and this dot inventory inventory slots stack size. I'm just going to make that go onto a new line so we can see that. So we've got a clone system, and to every inventory slot, we're going to add the corresponding slot on the player's inventory to this cloned system. So this is the actual cloning of the player's inventory. So now we need to go into a for each loop, and we're going to say for each, I'm going to call this KVP for key value pair. In our shopping cart dictionary, we're going to add one by one the items to the player's inventory. So we're going to go into a for loop now. So for int I, whilst I is less than our key value pair dot value. So remember, this shopping cart takes in data and an amount of that data. So we've got cog as the data, and the player's trying to buy 30 cogs from the shop. We're going to go through each of those 30 cogs and try to add them to the player's cloned inventory. So if cloned system dot add to inventory, we're going to pass in the data key in this case, and the amount, which is just 1, because we're adding them in one by one. I'm going to return false. So if we fail to add this to the inventory system, then we're going to return false. And just as a refresher, add to inventories this public bool method here, and this will return false if we don't have a free slot. So if it gets to here and we can't successfully add it to the inventory system, we're going to return false. So if we get to this point and we can't add any more stuff to the clone system, we'll break out of the loop, we'll just return false, and then that'll say that the player doesn't have enough inventory to fit the shopping cart in it. And if it successfully loops through all of this and completes this method, then we can just return true. We clearly do have enough inventory space remaining. So then we can go back to our shopkeeper display, and now this should work. So if we're selling, or the player has enough inventory space, then we're just going to return. But if neither of them are met, then we're just going to set the basket total text to read not enough room in inventory, And then we can set the basket total text dot color equal to color dot red. And there was a bit of an error there. That was my mistake. The price can stay outside of this if statement, but the string can't, because we're trying to access the shopping cart. We're trying to access the value which is at the shopping cart dictionary, but we don't know if it's there yet until we get to this if statement. So let's just cut new string and paste it back into our if statement, and we'll do it twice. And if this is the first one to be added to the shopping cart dictionary, then we can just say x1, because there's one item in the dictionary. And here we know that we contain the key, so then we can actually access the key here. So that should work. So let's go over to Unity and make sure that what we've just done is actually all set up and working. Let's hit play. And we'll come over to this NPC here. We'll press E. And let's try and add some cogs to our inventory. And you can see here that as we add them, the player doesn't have enough gold. So the total has gone red to kind of indicate that we can't afford it. That's adding stuff to the basket. Currently we can't get any back out of the basket, but you can see that's working. And we actually need to use this modified price up here when we add stuff to the display. So let's just add that quickly. So to do that, we're going to go up to the display shop inventory method here, and we're going to jump into this init function on our shop slot UI script. And here, instead of setting it directly to the assigned item slots gold value, we can actually get the modified price from our shopkeeper display. So let's do shopkeeper display, and we made this a static method, so we don't need to reference our parent. We can just do shopkeeper display get modified price, and I've just realized that we need to make this public. So public static int, not private. So that should work here. And I'm just going to put this up here. So we'll do we'll make a new variable. So variable modified price is equal, and then we're going to get the modified price. So remember, this takes in some data, so we can do the assigned item slot dot item data. It takes in the amount of the item, which we just want 1 for now. We're just going to show kind of how much 1 costs, and then we can pass in our markup. So then here in the text, we can just pop in our modified price instead of the sort of base value. So that should be that. So now we've got the cart set up and working, we want to be able to actually buy the items when we hit the buy button. We want to buy the cart and add it to the player's inventory and take the gold from the player. So let's do that. And I'm gonna move this bool up to the top just to try and keep everything sort of up here. So private bool is selling. And here in refresh display, just before we do clear slots, let's do some stuff with the buy button to set it up so we can actually buy the basket. So if we'll say, if our buy button is not equal to null, then we're going to set the buy button text equal to, and then here we're going to use the is selling bool again. So are we selling an item or are we buying an item? Are we selling our items to the shop or are we buying items from the shop? So we can say is selling. If we are selling, it'll be sell items, the button will say. And if we're not selling, we'll do buy items. And maybe this should be renamed to like the use cart button instead of the buy button. I'm just going to leave it called buy button for now. Then I'm going to get our buy button, and I'm going to remove all of the listeners from the on click event, and then we're going to check if we're selling. So is selling. If we are selling, we're going to add a listener to the on click button, and this is going to be a sell items method that we're going to make, and then we'll do else buy button dot on click dot add listener buy items. We're going to make a method called buy items. So every time we refresh the display, we're going to change what the buy button is doing, which is this button here, we're going to change what this button does and says based on which tab we've clicked up here. So let's make these methods. So we've got a private void sell items, and we'll make a private void buy items method. We're not going to focus on selling stuff at the minute. This video is already getting on quite long. I just want to focus on being able to buy the items and add them to the player inventory. So let's allow the player to actually buy their basket and add it to their inventory. So we're going to say if the player inventory holder dot primary inventory system dot gold is less than the basket total, then we're just going to return, because the buy button doesn't need to do anything. We could just disable the buy button based on this if we wanted, but I'm going to leave the button there. So the player could click it, but nothing will happen if they don't have enough gold for the basket. And then we want to check if the player inventory holder dot primary inventory system dot check inventory remaining shopping cart. So we're going to see if the player doesn't have enough space for all of the items in the basket, then we're just going to return. And maybe this would be a bit more performant if we used it as a bool. If we keep a kind of a reference to the result of that here, so we're only doing it once. I mean, that's up to you if you want to do that. I'm just going to leave it like this for now. Again, I don't want it to get too bogged down with extra stuff. And then we're going to say for each AVP in our shopping cart, we're going to purchase the item from the shop. So shop system dot purchase item, which again is a new method we're going to need to make, which takes in a key and an amount. So let's make that method over on our shop system script. So we're going to make this purchase item method, and all this is going to do is we're going to check whether we actually contain the item, which this is just a failsafe. We should have the item in our inventory. We should have the item in our inventory anyway, because we've added it to the basket from our inventory. But this is just another sort of catch, all just to make sure that nothing's gone wrong anywhere and we don't actually have the item for sale. And then we're just going to remove from the slot. And the other thing it does is it gives us the slot back. So if this is true, we still get this slot, and we can just say slot dot remove from stack and pass in the amount, which is what I'm going to call this. So amount. I'm going to rename that to data. Instead of a new inventory item data, I'm just going to pass in data. So if we have the item in our inventory, we're going to add this amount to. So if we have the item in our shop's inventory, we're going to remove that amount from the stack. And if we don't, we'll just return, because, like I said, we don't want to let the player buy something that the shop doesn't have. So back over to shopkeeper display. So we're going to buy the item from the shop. We're going to add now the item to the player's inventory. So we can say for int I, whilst I is less than the key value pair I++, and then we're just going to add the item to the player's inventory. So player inventory system dot add to inventory avp dot key and 1, because we're going through one by one and we're adding them all to the shop. And then we're going to add the basket total to the shop. So the shop system is going to gain gold, passing in the basket total, and the player inventory holder dot primary inventory system is going to spend some gold, the basket total. So let's make this gain gold method first, back over on the shop system script. And this is quite simple. We're just going to do available gold minus equals plus equals the basket total. And then let's make the spend gold method over on our inventory system. So spend gold, and that's simply just going to minus from our gold, the basket total. And then back on our shopkeeper display, once we've done all of that, we just need to refresh the display again, because obviously stock has changed. So we can reflect the UI to handle that. So let's go over to our project. Let's give our player some money, give him a payday. So we've got gold here. Let's set this to Let's make them rich. Let's give them 5,000 gold. Actually, no. I want to show it working to show that the player doesn't have enough gold for something. So we're going to do gold 500. And let's go to our shop. Let's go to our item scripts into the database. The item data, and let's make something more expensive. So what have we got? So swords 100, gold value 10, 100, okay, and 1. So that's fine. They're good values. So if we press play and we go over to our shopkeeper, and we've now got our inventory system here. We've now got our shop system display here. We can add cogs to the basket, and the player gold didn't update. Let's fix that. Okay, the reason that didn't work is when we create the inventory system here, we set the size to, if we don't pass in the gold, it'll just reset it to 0. So even though it's, even though we put it in ahead of time, the inventory holder is kind of overwriting that. So what we need is we just need a serialized field, and we can do a protected int gold. And then when we create our inventory system on the inventory holder, we can just pass in that gold amount. And the good thing about this is because we're doing it on the inventory holder, not the player inventory, chests could have a gold amount as well. If you've got enemies and they have loot on them, they're going to have an inventory system. You can give them gold for the player to get from the enemies and stuff. That should be fine. Let's go back over and try this out now. So it's not the inventory system gold, it's this gold that we need to change. So we'll do 500 gold here. Let's press play. And if we go back over to our shop, so we can now see the player's got 500 gold. Let's add some cogs over. And you can see that these are reacting now with the markup value. So the health potions and the sword are 150 gold, even though the base value was 100. We can add these into the basket, and then let's get some health potions as well. You can see that we can't afford all of the health potions, so and I've forgotten that we've not actually set up removing items from the cart as well. We may as well get that done now. It'll extend the video just a little bit, but not too much. Let's go back over to our shopkeeper display, and here we have, do we have a remove item from cart method yet? Remove item from cart, yeah. Let's move this up above add item to cart, just so we can go there. Okay, so this is very similar to the add item to cart, but we're kind of doing it in reverse. So we're going to get our data. So var data is equal to shop slot UI dot assigned item slot dot item data. And then we're going to check, does the shopping cart contain data already? If it does, we're going to reduce the value we're going to reduce the amount that the cart holds by 1. We're going to get the modified price. So we're just going to copy this underneath data here. We're going to copy the new string as well. And in fact, let's just copy all of this. So I'm going to copy the new string and the shopping cart UI at the data. And if we reduce the amount of the item in the cart to 0, so if shopping cart data is less than or equal to 0, then we're going to call shopping cart dot remove RP because it's no longer in the cart. We're going to get a reference to the game object of our shopping cart text, so equal to shopping cart UI data dot game object. We're going to remove the shopping cart UI from the shopping cart UI dictionary, so shopping cart UI dot remove the data key, and then we're going to destroy our temp obj. So here we instantiate it when we add it to the cart, and then when we remove it completely from the cart, we're going to destroy it. And then we're going to say that if the basket total is less than or, so then we need to modify the basket total. So we can do basket total minus equals the price. We can update the basket total text to reflect the new total amount. So total basket total G. And then we're going to say if the basket total is less than or equal to 0 and the basket total text is active, then we're just going to hide the text. So basket total text.enabled is equal to false. We'll hide the buy button. So buy button.gameObject.set active to false. We're going to clear the item preview, which is, we've not implemented the item preview section yet. We'll do that in the next video, but let's make that method now ahead of that. And then finally, we're going to check the cart versus available gold. And we only need to do that if we haven't just set it to active. So let's just return here. If there's nothing left in the basket, let's return because there's nothing left in the shopping cart, so we don't need to check it against available gold. So hopefully you followed along with that, because it is just the kind of the reverse of what we're doing down here. Let's go back over to Unity and hopefully, oh wait, let's just check one more thing, sorry. We need to go over to the shop slot UI, go to our remove item from cart method on the shop slot UI. And okay, we've already set that up, so that's fine. I just wanted to check that. So let's go back over to Unity, hit play, over to our shop cart, our shop NPC here. Let's add some cogs. Let's try and remove them. Okay, so you can see that we can now add and remove things from our basket. Let's add in, you know, some potions. Okay, we can't afford that many potions. We can afford this many. We'll hit buy. That buys the items. It adds the amount to the shop's gold. It decreases the player's gold. And now if we go back, which I've just realized we still can't close the shop panel. Let me just manually close that. Shop controller UI. Okay, so, you know, we can see that we've got the 4 cogs and 3 potions in the player's inventory. So I know that was very, very long-winded, and I apologize. Hopefully you follow along with it. If you want the project files for this video, they are available over on patreon.com/dampos. I'd just like to take a minute to thank all of my patrons. On screen now, we can see the 10,000 XP tier, which is a sector sweep. And I want to thank all of the 4,000 XP tier members as well. If you want any help with this video or any of the other videos on my channel, feel free to leave a comment below, or better yet, join the Discord server, which is linked in the description. But for now, thanks for watching, and I'll catch you in the next one. Bye! Hello and welcome to today's video. Hello and welcome to episode 16 of our inventory tutorial series, as well as episode 5 of the shop system series. So by the end of this video, we're going to be able to pick up all of our items off the ground. We're going to be able to come over to this shop, which doesn't currently have any poison potions. So we can sell them a poison potion. So we'll sell items. And you can see that as we click these items, it updates the item preview panel that we've got here. I'm going to click sell items and sell the poison potion to the shop. The shop now has a poison potion in stock. I'm going to come over here to the potion shop, and let's sell them one of my swords. And they've got a sword in their inventory. I can come over here and we'll put some items in that chest, put some cogs in this chest, and maybe let's store our sword as well. Let's save our game, come out. Let's go back in. We can now load the game. All of those items will disappear because we've already picked them up. We've got our cogs and our sword in this chest. We've got our potions in this chest. Let's make a new stack because we can. Why not? You can see that the sword item has been stored in the shop. We can check over here, and this has got the poison potion in stock that we sold them. So we've got the shops saving and loading, as well as remembering their gold and the player gold. All of that is saving quite nicely. That's where we're going to be by the end of this video. So let's just jump straight into it. Okay, so let's crack on with getting the item preview working and being able to sell items from the player's inventory to the shop. So let's go over to our inventory system script here, and we're going to start by displaying the player inventory based on the tabs at the top. So in our refresh item display in our shopkeeper display class, we've got this thing here, and currently we're just saying display player inventory. But actually what we want to do is we want to say if is selling, then we want to display the player inventory. Else we want to display the shop inventory, display layer inventory. Let's cut this, put that there, let's get rid of them. Okay, so let's check. Let's start to build this display player inventory method. So what we need to do here is we need to loop through all of the items in the player's inventory and then display them in the list on the left-hand side of the shop. So for that, we're just going to do a for each loop, and we're going to go through every item in the player inventory holder primary inventory system, and then we're going to make a method called get all items held, which is going to return a dictionary of items that the player holds. So let's create this method. So this is over on the inventory system.cs script, and it's currently public enumerable. And we're going to make it a dictionary of inventory item data as well as an amount of that. So this is going to be a dictionary made up of distinct items that the player has, because currently the player's inventory is organized into slots, and those slots can have the same item in them and multiple amounts because of the stack splitting and stack assigning and stuff. So what we need is an organized list of how many cogs does the player have. We don't care about what stacks they're in, just how many cogs are in the player's inventory. So that's what this is going to do here. So we're going to make a new dictionary called distinct items, and this is going to be a dictionary of inventory item data and an int, and this is what we're going to return at the end of this method. And here we're going to loop through all of the items in the player's inventory. So we'll do for each item in our inventory slots. If the inventory slots, if the item.data is equal to null, then we don't have an item in that slot, it's empty, so we can just continue, which will skip to the next item in the loop. But if it's not null, then we can check this dictionary to see whether we've already put the item in it. So we want to say if distinct items doesn't contain key, our item.data, which, the first time this goes around, it won't. So if distinct item.contains key item data, then let's add it. Let's add the data to the dictionary. So item.data, and the int is going to be how many of that item we have. So stack size. And then we can say else. So here we're checking if it doesn't contain the key, then let's add it to the dictionary. And if it does contain the key, let's just increase the amount of the item that we've got. So we can say else distinct items using the data as the key, and then we can plus equal item.stack size. And then finally, we can just return our distinct items dictionary here. So now we have a dictionary that's organized by inventory item data and the amount of that we've got. And that's looped through all of our slots. So now we're going to make a variable called temp slot, and this is going to be equal to a new shop slot. Because obviously the other shop slots in the display shop inventory are being driven by the shop's inventory list, the scriptable object. Here we're doing it from the player's inventory. So we're going to make a new temporary slot. To that slot, we're going to assign item, and it's going to be our item.key and item.value from this dictionary that we're looping through. And then we're going to instantiate a shop slot. So shop slot equal to instantiate shop slot prefab and the item list content panel at the transform. And then we're going to initialize that slot by passing in our temp slot as well as the shop system. And this is going to be the cell markup. So here we can offer the player more or less for their items based on the shop cell markup. And that's it for displaying the player inventory. Everything else should work kind of fine with it. But the one thing we do need to do is we need to set up the tabs that change mode, that change kind of, whether we're buying items or selling items. So to do that, we're going to make two methods here. We're going to do a public void on buy tab pressed and a public void on sell tab pressed. And we're going to say is selling is equal to true if we've clicked the sell tab. and then we can refresh our display. And if the buy tab is pressed, then we're just going to set is selling to false, and again, refresh the display. And while we're here, we've got this update item preview method that we made but never implemented. Let's just implement that, just so we can kind of get everything tied up in this video. So we'll do variable data is equal to the shop slot UI dot assigned item slot dot item data. And then we're going to set our item preview sprite to the data sprite.sprite equal to the data.icon. We're going to set the sprite color equal to color.white. We can update the item preview name.text to equal the data.displayName. And the item preview description.text is equal to the data.description. And I'm just going to copy these. Copy. I'm going to go to our clear item preview function that we made, method. I'm just going to paste them in. And then here we can set the sprite to null. We can make it invisible. We can set the text to an empty string. And we can set the description, to a empty string as well. And now we can copy the clear item preview method, and when we display the shop window and we call refresh display, so it's clearing the slots, let's clear the item preview as well. So let's just check that that is all working, see where we're up to with that. So let's pick up some items here. We've got poison potion, health potion, some cogs, and 2 swords. So let's go over to this shop here. So we're currently in buy mode. If we click the sell tab, oh, sorry, nothing will happen because we need to hook up those buttons. The tabs don't actually do anything. So we'll go to buy button. We'll get this on click event. We'll drag in our shop controller, shopkeeper display on buy tab pressed. And then with the sell button, again, drag in the shop UI controller, shopkeeper display on sell tab pressed. So again, let's make sure we pick up some items. So we'll come over here, pick up all these. We'll go over here. Let's press E to bring up the shop window. Now let's click the sell tab. And we can see now, this is the player inventory. You see this shop is actually offering us more for the potions than they're actually worth, which is quite good. But it is selling them for 150G. And we can add these to the basket here. And you can see that the shop's got 1,000 gold. If we go over the 1,000 gold mark, I don't know if we'll be able to. I don't think there's enough stuff to go over the 1,000 gold mark. I mean, there isn't because we've got shop gold. Because we didn't pick up enough stuff. There wasn't enough stuff in the world. But that's now adding it to the players, to the shopping cart. So now when we click the sell item button, we need to be able to sell the items like we can buy items from the shop. So let's go back over to our script, and we've got private void sell items on our shopkeeper display. So here we're going to do similar to sort of the buy items. We're going to say if the shop system dot available gold is less than the basket total, and let's just return because we don't want to continue. We don't want to sell anything to the shop. But if the shop does have enough gold to buy all of the players' items, we're going to loop through with a for each loop. We're going to loop through every item in the shopping cart, and then we're going to get our shop system. I'm going to make a new method called sell item. And there we're going to pass in the key value pair key, as well as the kvp dot value. And we'll make that method in just a second. And then I'm going to do variable price is equal to get modified price kvp.key kvp.value shop system dot sell markup. And the reason we're not doing this in here is because we need to use the price to reduce the gold from the shop and increase the gold on the player's inventory. What we could do is pass the price through to sell item. Actually, let's do that. That might make a little bit more sense. So let's do that. So we're going to calculate the price. We'll pass in the price to this sell item method. And then we can do player inventory holder primary inventory system dot gain gold, which will take in the price. Let's make this method in a second over on the player inventory. And then we'll do player inventory holder dot primary inventory system. And then we'll remove items from inventory. And we're going to remove the key value pair dot key. That's the item that we're going to remove and how many of the item we are going to remove. So let's make this sell item method first. So this is over on our shopsystem.cs script. And all this is going to do is it's going to add to shop, and it's going to add the key VP key and the KVP value to the shop. And then we can just call gain gold and we can pass through the price. So now let's make these two methods on our inventory system. So I'm going to implement gain gold and implement remove items from inventory. So gain gold is just going to do available gold plus equals price. Nice and simple. Now for the remove items from inventory, let's get rid of that. I'm going to rename that to data and amount just to keep, so that's what I've named kind of all of the other inventory kind of add-in variables. Makes sense. So we're going to say if contains item data, and we're going to get back out a list of inventory slots called inv slot. We're going to get out our list of inventory slots from our contains item method, and then we're going to see for each slot in our inventory slot list, we're going to get the stack size, so var stack size, and set that equal to slot.stack size. And then we can say if stack size is greater than the amount that we're trying to remove from our inventory, then we can call slot.remove from stack, and we can just remove the amount from that one slot. If, however, we have, but for example, if amount was greater than stack size, then we need to go to the next slot in our list and remove it from that. So we can say else slot.remove from stack size, and then from amount that we've passed in, we can minus equal the stack size. So then it'll go around again to the next slot that has the item in it, and it'll remove the next from that stack size until it's been through them all. And we need to also, once the slot has been modified, we need to call on inventory slot changed and invoke that method or that action and pass in the slot. And we just need to add to this remove from stack function. So we want to say here, if stack size is less than or equal to 0, then let's clear the slot. Because at that point, you know, it's all gone. We don't need to, because obviously at that point, we don't want to go into minus. We just want to clear the slot out. Once we've got to 0, we can just make it an empty slot. So let's go back to shopkeeper display. So we've got sell items here, and then we just need to call refresh display. So let's see if that is working. So let's press play. I'm going to come over here, let's pick up these items, and we can come over here, we can press E, bring up our shop window, go over to the sell tab, and let's sell 2 potions to the shop. So we should see the player gold will increase by 250 and the shop gold will reduce by 250. So let's hit sell items, and we've made a little mistake. Instead of gain gold, we need to reduce gold, which isn't a method that we've made. So reduce gold. Okay, so this is where this gets a little bit confusing, because the way I've named all this is from the player's perspective. So sell item, obviously we're a shop, so that can be a bit confusing. Are we selling the item to the player, or is the player selling an item to the shop system? I've gone from the point of view of the player, because it's the player that's doing kind of the acts in the world. So when we sell an item and call this, the player is selling an item to the shop. So it's going to add to the shop, and then we need to reduce the shop's gold amount. So let's hit play and just make sure that works as planned. So let's go pick up all of this stuff, press E, sell 2 of our other, that's buy. Let's go over to our sell tab. So let's sell 2 health potions, and we can see here that the description, the item preview, it shows the last item that we clicked. So if we try and add a cog to the basket, it'll display this is a cog. We can remove that cog from the basket, and then let's sell our items. So now you can see the player gold increased by 250 and the shop gold reduced by 750. And then if we go back over to the buy tab, we can see now that the health potions have been added to the bottom of the list, and we've got a bit of an issue here. So you can see that it's added them to the shop, but it's also added them at the bottom of the list there. So let's just figure out what's going on there. Let me just sell those items to the shop. Go to the buy tab. Okay, so there's a little bit of a bug there. It is adding it to the shop, but we're getting this these additional items as well, which we don't obviously want. So let's figure out what's going on there. Okay, so the problem was we just need to return. So when we, on the shop system script, we've got our add to shop function. Once we've added it to the stack, we needed to call return. So what was happening is we were adding it to the stack, and then we were also assigning it to a free slot. So if we just put return in our add to shop function on the shop system script, that should solve that issue that we were having. Let's just confirm that. Let's pick up some items, go over here, go to the sell tab. We'll sell the items to the shop. So there's 3 cogs. We can hit the sell button. The store sold the money. Go back over to the buy tab. And now we can see that the cogs have increased, the health potions increased, but we've not actually got in the bottom that issue that we were having. So, and then we can buy items from the shop. So we're going to spend 610 of the player gold and increase the shop gold by 610. So let's buy. And then we can go over to the sell tab, and now we can see we've got our 4 health potions and 5 cogs. And we'll sell the cogs back. You can see there's a bit of an issue there. The rounding seems to be having a bit of a problem. Let's figure out why that was. Okay, so that was a quick change. All we needed to do, in our get modified price, it was rounding up. We just needed it to round down. So instead of round to int, I've put floor to int. And that's on the shopkeeper display. So that's what that issue was there. So one of the kind of other things that we want to do is be able to save and load our shop system to kind of reflect that we've, that the shop has gained and lost stuff. And the place that we do that is over on our shopkeeper.cs script. So over on our shopkeeper script, just like we've done with our other save and load items, what we want to do is in awake, we're going to store a reference to our ID. So let's do private string ID. And then here we'll say in awake ID equals get component unique ID. And let's get the ID of the NPC. And then we're going to make some shop save data. So outside of our class, we'll do public class shop save data. And we can do system.serializable for our shop save data. And this is just going to hold a public shop system reference in it, which I'll call shop system. This could take in a position and a rotation if you wanted. So for example, if the shopkeeper kind of wandered around, you could save that data. I'm just going to keep it basic though. So I'm just going to store the shop system for now. But just so you know, you can store other stuff in this, like whatever you care about for your shop. And I'm just going to say public shop save data. This is the constructor, and it's just going to take in a shop system, which I'll call shop system. And you guessed it, we'll do shop system equals shop system. So back up to awake, we're going to get the ID here. And then under that, we can say shop save data, which we're going to keep a reference to. So private shop save data called shop save data. So shop save data is equal to new shop save data, passing in our shop system in a start method. So private start, we're going to make a new dictionary on our save game manager. Just like we did with the chests, they're all stored in a dictionary. If you think about it, the NPCs are kind of like chests, but slightly different. So we can do if save game manager dot data, and we'll do dot, and then we're going to do shopkeeper dictionary, and then we'll check whether the dictionary contains the key of our ID. So let's make this shopkeeper dictionary over on our save game manager. It's going to be save data, this class. So I'll do this underneath our chest dictionary. So I'll do public serializable dictionary, taking in a string and some shop save data. And we'll call this the shopkeeper dictionary. And then here we'll do shopkeeper dictionary is equal to a new serializable dictionary of string and shop save data. So if it contains the ID, so if it doesn't already contain that ID, we'll do save game manager dot data dot shopkeeper dictionary dot add ID and shop save data. And I'm going to rename this to be consistent to just have an underscore. And then in our on enable function, we can say save load dot on load game, and we'll do load inventory, which will be a new method that we make, as well as on disable. Copy this, paste it in here, and we'll unsubscribe from it. And then we're going to make this load inventory method, which takes in some save data, which I'll just call data. And here we'll say if the data dot shopkeeper dictionary, and we'll try and get our ID out of the dictionary. And if it does exist, if the value is there, we're going to get out the shop save data, which I'll just call shop save data, and we'll return. So if the shopkeeper dictionary doesn't have a reference to the current shopkeeper, then we'll just return. But if it does, then we can say our shop save data is equal to shop save data, which is this here. And then we can say our shop system is equal to the shop save data dot shop system. So again, this save and loading, this way of doing save and loading is what we've done with the player inventory, what we've done with the chest inventory, what we've done with the stuff that's on the ground. So that should hopefully all make sense to you. If not, maybe go back and watch the save data video again. That should work. We may have an issue with the unique IDs. So if I go over to our shop NPCs, so I want to make sure that these IDs stay the same. So 2D093041, we'll hit play. Okay, so that's staying the same. There's no errors there from console. I'm going to get rid of this debug.log though. So let's hit play. And let's just check that this is working. So I'm going to go over, pick up these items to our shop. I'm going to, it's got 99 cogs. I'm going to buy, let's say buy 9 cogs. We'll buy them from the shop. We'll sell them a poison potion. So sell items. That's now there in the shop. If I close the shop and walk away, go back. So that's all working. It's got 90 cogs, 1 poison potion. Let's hit save. So we can see saving game. Let's exit, come back in. So it's reset to default. Let's load our game. We can see that the stuff that we'd already picked up has gone. We've got the cogs that we bought in our inventory. And the poison potion is there, and the cogs are all gone in the shop. So that's the saving and loading of the shop done. One thing I do really want to quickly do, because it's annoying me, is on our UI manager that we made, the UI controller, in an update function, I'm just going to say if keyboard.current.get escape key was pressed this frame, then I want to set the shopkeeper display to false, just so I can close the shop without having to keep actually selecting the game object. So that's pretty much it for the shop system. That's all done. I don't think there's anything else we need to cover. I thought maybe there'd be a couple more episodes left, but there's only, I think that's everything done, unless there's something ridiculously glaring. I may have to pop in from the future while editing this to say that that's the case, but I mean, that's all working. That's the shop inventory done. We can close these shop windows now with the escape key, which makes it a lot easier. We've got all of our items on the ground, which we can pick up. We can come over here. We can put poison potion and some cogs in this chest. In this chest, we'll put a sword to this shop. We will sell a sword. We'll save our game. We'll come back in. We'll hit play. We will load the game. They'll all go. Got a sword in that chest. Poison potion and a cog in this chest. And they've got one more sword than they had earlier. So, yep, that's all working. We've got the save and load in. I hope this series was enjoyable and you kind of got it all. If there's any big glaring issues that you need some like clarity on, let me know in the comments or join the Discord server where I'll be able to help you a bit better. If there's like frequently asked questions, then I'll probably do a follow-up video or maybe like a code review or something. But for now, thanks for all your support from this series. I'm going to take a little break from this inventory tutorial series while I just think up of kind of what I want to do next. I may do in a couple of weeks a crafting system. So that was quite simple to set up. So if you want to see how we can use items from our inventory to work in a crafting system, do let me know. What I may do though is do a bit more of a general crafting system video. And I'll probably mention in that on how we could probably hook this into the system just to make it a bit more generic. But for now, thanks for watching and I'll see you in the next one. Bye. I'd just like to take a minute to thank all of my patrons. On screen now, we can see the 10,000 XP tier, which is a sector sweep. And I want to thank all of the 4,000 XP tier members as well. Hello and welcome to today's video. Today's video is just going to be a little quick video, hopefully quick, showing how we can set up this hotbar system to be able to choose a slot, and then for example if we left click we can use whatever item that we've currently got highlighted on our hotbar. So if I left click, you can see down in the console we're saying using health potion, but using cog, using poison potion and using sword item. And you can see with the scroll wheel I can scroll kind of just infinitely through all of these slots, and then I can also select individual slots with the number row on the keyboard. So this isn't going to be a line-by-line tutorial, like kind of follow along. The project files are available obviously to download on the Patreon account. If you do want to download the code and just plug it straight into your inventory system, you can obviously do that by downloading the Patreon files. If this video ever ends up on YouTube, because it's originally going to be a Patreon exclusive, the URL for the Patreon is linked in the description below if you're watching this on YouTube, kind of in the future if I release this sort of down the line. But what I will be doing is I'll be walking through exactly what I've done and I'll be showing the code on screen. And obviously feel free to pause and kind of copy it down if you want to do that, or like I said, just download the project files. So let's just jump straight into it. There's only going to be a couple of changes really to get this to work. So I've made a hotbar display script. So if we open up this, I'll go through this kind of line by line. You can see there's a lot of just boilerplate code, which I thought it'd be quite boring to just type it out line by line. So we've got our hotbar display class, which inherits from our static inventory display. Previously, our hotbar was just a static inventory display, which is this class here that we set up way back when we did the UI for the inventory system. And that itself inherits from inventory display, but we don't need to worry about this class. We're not going to do anything there. And all we're going to do on this class is we're going to swap our inventory slot UI variables over to protected instead of private, so we can access it from our hotbar display class. We're going to make sure our on enable and on disable are protected virtual voids instead of private voids. And that's it for the static inventory display class. We're not going to change any of the other functionality. It's just making that protected and making these two protected virtual voids. So if we now make a hotbar display script and have this inherit from our static inventory display class, here we're going to keep track of which slot on our hotbar we've got selected, and this is going to be done via a int, an index. And I've set this as a private int. We've got a max index size, which I defaulted to 9. But we are setting it to the slots.length -1, because obviously arrays are 0 based. So if you've got 10 inventory slots and you want to access the 10th slot, we would actually want to be at index 9 to access that in the array. And then this is a little bit butchered. Over on our player movement code, you can see here that we've got private player controls, and we're making some new player controls, and that's how we move our little bean around without getting too bogged down. So we need some input on our hotbar display script. And you can see we've got some copied code here. We've got private player controls equals new player controls. And what you'd probably want to do is not do it this way and have instead a separate input manager script. But again, that's its own separate video. I'm just trying to do this the easiest way to show you the logic of this hotbar display script. Just like our player movement code where we're setting up new controls so we can access those controls, we're doing the exact same thing here. So we're making some new player controls in our protected override void on enable and protected override void on disable. We're calling our base.onEnable, which is just going to do this. And then we're going to do our own stuff. So we're going to enable the player controls. And then in our onDisable, we are just going to disable them. This just avoids any memory leaks. And now we can see this big kind of subscription to all of these events, and then we're unsubscribing from them here. So the way I've set up these input controls, you can see we've got hotbar 1, hotbar 2, through to 10, and then we've got use item as well. And then we've also got a mouse wheel input here. If I go back over to Unity, go over to our input controls. So here's our player input controls using the new input system. Up until now, we've only had movement because we've just been moving the bean around. We haven't needed any of the controls. You can see here I've got hotbar 1 through to 10 plus mouse wheel plus item. So 1 through 10, these are all of the same. So it's just a action type of pass through and it's a button. And 1 on the keyboard, I've got an interaction of press only. And then I've done this on every single one. It's the exact same. So hotbar 2 is number 2 on the keyboard with an interaction of press only. And you can see all the way to 10. 10 is actually 0 on the sort of row of number keys on your keyboard. Obviously that's slot 10, which is after 9. That's 0 on the keyboard. We have mouse wheel, which is pass through an axis. And I've chosen for the path mouse scroll Y. And then use item, again, is a button with a left mouse button. And there's an interaction of press only there as well. So this is how you need to set up your input action asset with a key for every single row on the keyboard of the numbers from 1 to 10 or 1 to 0. Mouse wheel and use item. And with that done, we can go into our script and then we're just listening out for when the player presses a button. So we've got hotbar 1.performed plus equals and then a method called hotbar1, which just takes in an input action.callback context called obj. And I've done that through 1 through 10. And then I've made a method called use item as well. And we're unsubscribing from them here. And you can see that we've got hotbar 1. And then we've got a setIndex method, which takes in an int, which I'll show you in just a second. We've got setIndex in 0, 1, 2, 3, 4, 5. And the reason these are offset, so we're pressing number 1 on the keyboard. And again, the array is 0 based. So if we press 1 on the keyboard, we want to access the first slot in our slots array, which is index 0 because they're 0 based. So it's a little bit, annoying that that's the case. So we're setting, when we press 1 on the keyboard, we're going to set our index to 0 to access the first element in our slots array. And we do that through hotbar 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And obviously when we press 0 on the keyboard, we actually want to set it to index 9. And I've just wrapped these in a region just so I can collapse them because they're kind of messy to look at. In our update function, I've got if playercontrols.player.mousewheel.readValue float is greater than 0.1, then obviously we've scrolled the wheel up during that frame. So we're going to change the index and we're just going to knock the index up 1. And similarly, if it's less than minus 0.1, we're going to knock it down. And you can see here that I've got private void use item. So again, we're listening out for the left mouse button. When that's performed, we're going to call our use item method. We'll do private void use item. And we're going to say if there is item data in the slot that we have selected. So if that slot actually has an item in it, Then we're going to call the useItem method over on our item data. I'm going to jump quickly over to the inventory_item.cs script, and I've just added a public void useItem, and that's just going to debug.log our display name. Depending on your game, you're going to do different things based on which item is selected. So you may have useItem, and then if you've got a weapon, you may want to make a new scriptable object that inherits from inventory item data, and that's the weapon class. And then useItem calls some weapon logic. If you'd like to see that kind of setup, let me know and I'll do a follow-up video for that. I wanted to keep this video just about the actual hotbar display to keep it short and sweet. So then we've just got our actual index handling code. So we've got change index, which takes in a direction to change it. So are we changing it up or are we changing it down? And again, we're calling that here in our update function based on which way we're scrolling the mouse wheel. And here we're going to toggle the slot UI's highlight, which I'll show you in a second. And then to our index, we're just gonna add the direction. So for index 3 and we go up 1, that'll obviously change current index to 4. And if we're at index 3 and we go down -1, obviously that'll put the current index to 2. So once we've changed the current index, we need it to wrap around if it goes over the max index size. So if we're at index 9 and then we go up to index 10 and our maximum index size is 9, then we're going to loop it back around. We're going to set the current index back to 0. And the sort of inverse of that is if we're already at index 0 and we try to scroll the mouse wheel down and we go below 0, then we're going to set the current index back to our max index size. So it'll loop back around to the top. And then we can carry on scrolling down, -1, until we're back to below 0. And then we're going to call this toggle highlight code again, which again, I'll show you. And then set index is pretty simple. We're just directly setting the index to, whichever key we've pressed on the keyboard. I do have some sort of validation stuff here. Again, just doing that wraparound functionality. We should never need to use it because we are setting it directly. But just for example, if you set a static, if you want a hotbar of size 5 instead of using the full number keys, and you've forgotten to change this and remove the keys, this is just a good way of making sure that we're safe, that it will always display the correct sort of index. So if our max index size is 5 and I press 0 on the number pad, I'm just going to set it to the max index size, and that'll just make sure we don't get any errors. You may want to debug.log something there as well, just so you know that you've gone kind of out of bounds when you've pressed the key. And then we're going to set our current index to our new index. And then we're going to call this toggle highlight functionality. And the reason we're calling this twice here is because we're going to toggle it, so we're going to turn it off for the slot we're currently on. Then we're going to change the index, and then we're going to toggle that new index on. So if we just click through to our toggle highlight script, so this is on our inventory slot UI script, and we've got a public void toggle highlight, and it's just going to set our slots highlight to the inverse of itself. So we'll toggle it on or off. And this just saves having to have a toggle highlight on and a toggle highlight off method. You can see up here, we've got a serialized field, private game object slot highlight. So we're just setting that active. So we're just turning that on or off by calling set active here. So then if we go over to our inventory slot UI prefab, you can see here I added a new image which I've turned off in the inspector. We need to remember to turn that off. And all this is it's an image I've made in Photoshop. It's just a square, square sort of highlight, which I've made it white in Photoshop so I can change the color of the highlight here. Maybe we want it to be sort of a nice kind of green color, or keep it kind of yellowy orange. And then I've dragged that image over into our slot highlight on the prefab script. If we look at our canvas, you can see we've got our highlights here. And again, I need to remember to turn that image off. So they are all off. And then one last thing, in our hotbar display class, over in our protected override start. So here we've got protected virtual void start, and this calls refresh static display. So on our display, we're just overriding start. We are refreshing the display by calling base.start. We're going to set the current index to 0. We're going to set our maximum index size to slots.length -1, and then we're going to toggle the highlight of slot 0 on. So if we press play, there you go, we can see we've got that. If I click and the slot's empty, nothing happens. You can see nothing's happening in the console. But then if I pick up some stuff, we've got our cog, we've got our potions, using health potion, and then we're using our sword. So there we have it. That's how we can set up a little hotbar selection. Obviously, there is more that we can do with this, depending on your game. So for example, when we change index, we might want to instantiate the sword for the player to be holding it, and then if we scroll off it, it will disable the sword. You know, we might want to show a potion in the player's hands. Again, using sort of events like we've used events all throughout this project. You know, you could call an event that says slot changed and it passes through the item that is in that slot, and then you can do logic with, and then wherever you want and whatever your game calls for, you can do logic with that. This was a quick sort of fly through. Again, this was filmed as a Patreon exclusive. If you're watching this on YouTube, project files for this are over on Patreon, which is patreon.com/Dampos. If you've got any questions, let me know in the comments or join the Discord server. I'll be able to help you kind of debug anything that's gone wrong. But for the meantime, thanks for watching, and I'll see you in the next one. Bye.